Hello people, so we are here with a recap of all the POTDs of November, and if you have missed any, don't forget to check out the whole video to practice all the 30 questions again. And before starting the video, let me first give a shout out to the top 3 performers having the highest streak of all time. Topping the list, we have Udit Sharma with the highest streak of 844 days. The next up, we have Kaisar Ali Suleimani with the streak of 816 days. And then we have Lakshay Bang with the streak of 761 days. Guys, you have shown commendable dedication in solving POTDs, and I hope you're gonna keep on doing that. And to everybody else, if you want your name in this list, be dedicated to solving POTDs. Keep coding.
Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to see the solution of the problem frequencies of limited range array elements. First of all, let us start by understanding the question. What does question say? Given an array ARR of n positive integers which can contain integers from 1 to p, where elements can be repeated or be absent from the array. So what does that basically mean is that we have an array of size n in which the integers, the values of the arrays are between 1 to p, okay, and the elements can also be repeated. Your task is to count the frequency of all the numbers from 1 to n. So we need to tell the frequency or the number of occurrences of each integer from 1 to n. Remember, the elements can be between 1 to p. We need to tell the frequencies of number between 1 to n only. Make in-place changes in array ARR such that array of I equals to frequency of I. So we want to return a frequency array which will tell the frequency of each and every element from 1 to n in the array. But we want to make the in-place changes in this array only. So we do not want to declare another frequency array. Okay. Assume one-based indexing. The elements greater than array n in the array can be ignored for counting and do modify the array in place. So the elements which are greater than n, because we are doing in place changes, the size of the array is n. So the elements which are greater than n, there is no valid index for them and we can ignore them. We want to count the frequencies of elements from 1 to n only. So for example, if my n is 5 and the number of elements are 2, 3, 2, 3, 5, okay, and p is 5. So what will be my output? So this will basically represent the count of 1 in array, this will represent the count of 2 in array, this will represent count of 3 in array, this will represent count of 4 in array, and this will represent count of 5 in array. So how many 1s are there? 0. How many 2s are there? 2. How many 3s are there? 2. How many 4s are there? 0. How many 5s are there? 1. Okay. So you can see the explanation here. Similarly, you can go through this example also and this example also. You do not need to read input or print anything. Complete the function frequency count that takes array ARR and integer n and p as input parameters and modify the array in place. That is, do not declare a new frequency array to store the frequencies of the elements. Modify this array in place only. So modify that array which contains the elements initially should finally contain what? The frequencies of the elements, okay, to denote the frequency count of each element from 1 to n. The expected time complexity is big O of n and expected auxiliary space is constant, and the constraints are given here. So now if we think about solving this problem, then for example, let's say n is equals to 7, the size of the array is 7 and the elements are this, okay. Now since n is equals to 7, let us suppose that p is equals to 8, okay, or p is equals to 9. So the array elements will be between 1 and 9, okay. But we need to tell the frequencies of all the elements from 1 to 7 only, and the changes should be made in this array only, okay. So your count of 1 will come, your count of 2 will come, your count of 3 will come, your count of 4 will come, your count of 5 will come, your count of 6 will come, and your count of 7 will come. So what will be count of 1? 1. What will be count of 2? 1. What will be count of 3? 1. What will be count of 4? 2. What will be count of 5? 1. What will be count of 6? 0. What will be count of 7? 0. So this initial array should finally get modified and look something like this, which basically denotes the frequencies of elements from 1 to n or 1 to 7. Okay, and this is 0 index. Remember, this is 0 index, this is first index, this is second index, this is third index, and so on. So ith index will store the frequency of element with value I plus 1. Okay. Now, if this question was asked where we can declare a new frequency array, then the question would become very easy. We can declare a new frequency array, make all the counts as 0 initially, and then traverse this array and increase the frequency of that array respectively. But here we are said that we need to make the changes in place. Okay, so we need to modify this array into this array. Okay, Now what the problem will occur is, let's say you traverse the array and you found 3. Okay, so now you have encountered the first 3. So at this index you know that the count of 3 will be stored, so you here mark 1. Now when you mark 1 here, what about 4, where it will go? You need to take care of that also. This value should not be lost, because I want to know the count of this also, right? So if you make the count of second index as 1, that you have encountered the first 3, then what about this value? That's the first issue. Second issue is that when you make the count 1, now when you are traversing the array and you see that this index has value 1, so this one, does it represent the frequency of some element, or is it the value of the original array? Are you getting my point? When you are traversing the array, let's say here you have 1. Okay, so is it the array element, or is it the frequency count of 5 in the array? What is it representing when you are traversing the array? Because you are going to make changes in place only. So you need to take care of these two things. Okay, first, when you are traversing the array, whether a particular element is representing frequency or whether it is the array element of the original array, right? Because you want to make changes in place only. Second, if you find a particular element and you let's say you encountered 3 and you made the changes at the second index, which basically holds the count of 3 in the array, then what about the element which was at that index? How will you handle that, right? So what we will do is, we will store counting negative wise. So what I'm trying to say, let's say I encountered 3. So instead of storing 1, I will store -1. Now whenever an element is minus, that is basically frequency, but we have just replaced it with minus sign, so that we know that it is not the original array element, it is the count of frequency. Are you getting my point? So one problem is solved. Second problem was that what about the original element which was at that place? So what we will do, whenever we change the frequency count at some index, we will see element at that index. First of all, we will swap that with the current index and then make the changes. So what I'm trying to say is, let's say I have 3, 4, 4, 8, 1, 2, 5. I encountered 3. Okay, so now 3 will be stored here. Here count of 1, here count of 2, count of 3, count of 4, count of 5, count of 6, and count of 7. Okay, now 3's count will come here. Okay, I am traversing the array from left to right. So here I will store -1. Why minus? So that I know it is not the original array element, it is frequency count. What about 4? So before storing -1, what I will do, I will swap 3 and 4. And then instead of 3, I will make it as -1. So this data is lost. At this point, I have -1, right? But I do not require this data anymore, because I have stored that count of 3 as -1 here, right? And I have got my 4 here. Okay. Now, whenever an element, whenever a particular index, while traversing from left to right, until it has a positive value, we will not move on to next index, right? Because it is a value which was swapped with some other index while counting, right? So we swapped 3 and 4 because we no longer needed 3, but we needed 4. So we took 4 here and we made the count here as -1, right? But we will not move further. First, we will handle this value. Until a negative value comes here, we will not move forward. Now 4 counting will come here. So I'll exchange 4 with 8, because at this index value 8 is stored. Okay. And then I'll replace 4 with -1. Okay. So this is the -1 count of this 3. This is -1 count of this 4. Now 8 is greater than n. So simply what I will do, I cannot exchange it with anyone, but simply I'll mark this index as 0. Right? Because I know that the elements in the original array are positive only. Now when I will encounter 1, I will make this -1. Okay. Now again I encountered 4. Now I will check at third index what is the value. At third index I have -1. Now -1 is a frequency, it is not a value, because it is negative and the values are only positive. So what I will do, I will not exchange it. I will simply make the count -2. So if the a value at a particular index is less than equal to 0, we'll simply decrease it by 1. Okay, because we want to increase the frequency count, but in negative way. Okay, so I'll just do -2 and I'll make the count of this index as 0. Then I'll move forward. I'll see here it is -1 at this index. So it is not a value, it is frequency. Then at this index also value is negative, so it is frequency. Then at this index value is 1. Where will 1 be stored? At 0 index. What is the value at 0 index? 0. So it is not a value, it is a frequency, because values are only from 1 to p, positive. So what I'll do, I'll not exchange it with anyone, but at this index I'll mark 0 and I'll decrease this by 1, because I have found 1. Okay. Then I'll see 2 will be stored here. Here it is 0. So I'll simply make the value at this index as 0 and decrease the count at this index. Okay. Then I will encounter 5. 5 will come here. That is 0. So I'll make the count at this index 0. Okay, now this index value is 0 and this 5 I will make this -1. Okay, so my array will be -1, -1, -1, -2, -1, 0 and 0. And finally I'll multiply it by -1. So 1, 1, 1, 2, 1, 0, 0. 1, 1, 1, 2, 1, 0, 0, 1, 1, 1, 2, 1, 0, 0, and I have got my answer. So just to sum up, what I will do, I will basically traverse the array from left to right, and I will see what is the element at ith index. It is array I. Okay, so it will be stored at index what? Array of I minus 1. If the value of the ith index is array I, its frequency will be stored at index array of I minus 1. If the value is 5, its count will be stored at index 4. So I will see what is the value at 4th index, or what is the value at, let's say, the 4th index, right, for array of I equal to 5. If that value is positive, I will exchange it with this index, with ith index, and make the count at this index -1, because I have encountered 5 for the first time, right? If the value is already less than equal to 0 at 4th index, it means that I have encountered 5 before maybe, or the count is 0 at that index. I'll simply decrease its count and move on to next index. But if the value is positive, first I'll exchange the value, then make the count at that index -1, and then again operate on the same index. Okay, and in this way we will complete the traversal, and then finally we will multiply it by -1 so that the frequencies again gets converted into positive elements. Now let's look at its actual code. So if we look at the actual code, so what I have done, I have taken some variables to traverse. Then for I equals to 0 to n, if the value of the element is greater than 0 or less than equal to n, then only I have to consider it for counting its frequency. Because if the value is less than equal to 0, it means that is not a value, because original values are between 1 to p. If the value at ith index is less than equal to 0, it means it is a frequency count. Okay, so I'll not consider this. So if it is between this, then I need to consider the frequency. If it is greater than n, then we do not need to consider it frequency. There are only n elements in the array, so I'll simply make the array of I equals to 0, and I'll move on to the next index. If the array is not greater than n, and if it is not between 1 to n, then it will definitely be negative, so it will represent a frequency count. So I'll simply move on to next index. Now if it is between 1 to n, I need to increase its frequency count. So first of all, I will see the index where its count is to be increased. So if the value of the ith element is array of I, its count will be stored at array of I minus 1 index, that is j. Now if that index has already value less than equal to 0, it means it has occurred before and there is no swapping required. So what I'll do, I'll mark the array of I as 0. I'll decrease the frequency count by 1 at jth index where it is supposed to be stored, and I'll go on to next index. But if the value at the jth index where array of I frequency will be stored is not less than equal to 0, it is positive, then first of all I'll swap that value with array of I. So now this value comes at ith index. Then I'll make the count of array of j equals to -1, because since it was positive, it means that this value which is at ith index is encountered for the first time. So I'll make its frequency count as -1, and I'll not move on to next index. I'll not do I++, because now the element which was at jth index, the positive element, has come to ith index. I also need to take care of frequency count of that element. So I'll again operate on the ith index. Okay, and this way I'll complete the loop. And finally I'll multiply it by -1, or I can say I'll say array of I equals to minus array of I, so that the frequency count which was negative will become positive and 0 will remain 0. What will be the time complexity? Time complexity would be big O of n, because we are running a for loop of size n. And what would be the auxiliary space? the auxiliary space here will be constant because we are not using any array or something. We are just taking two variables and we are making the changes in place for this array. Okay, I hope you have understood it. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. So in this video, we are going to look at the solution of the problem of the day, that is minimum distance between two numbers. First of all, let us start by understanding the question. What does question say? You are given an array A of n elements. Okay, so we have an array which has n elements. Find the minimum index based distance between two distinct elements of the array x and y. So what it basically is saying is we need to find the minimum distance between two distinct elements x and y which are given to us in the question. So let us say x is at index 2 and y is at index 5. Then the distance between them is 3. Okay, so all such possible distances between x and y we have to calculate from the given array because there can be multiple pairs of x and y, and out of that we need to return the minimum distance possible. Okay, and distance is calculated based on index. Okay, so if x is at index i1, y is at index i2, then the distance between them is i1 minus i2 absolute value. Okay, return -1 if either x or y does not exist in the array. So let us assume there is no x in the array, or there is no y in the array, or there is no x as well as y in the array. In that case we will return -1 because if elements are only not present, then how can we calculate the minimum distance, right? So for example, if this is the given array and x is 1 and y is 2. Now understand one thing, first element and second element, first is x, second is y. So we can calculate distance between these two. First is x, fourth is y. So we can also calculate distance between these two. They also form a pair of x, y. The distance between the first index and second index is 1. The distance between first index and fourth index is 3. The minimum distance out of 1 and 3 is 1. So our output is 1. Explanation: x is equal to 1, y is equal to 2. There are two distances between x and y which are 1 and 3, out of which least is 1. Okay. This is the second example, x is 42, y is 12, so I don't think there is 42 as well as 12, so the output is -1. Complete the function minimum distance which takes the array and three integers n, x and y and is the size of the array as input parameters, and return the minimum distance between x and y in the array. Return -1 if either x or y does not exist in the array. Expected time complexity is big O of n and expected auxiliary space is constant, and the constraints are given here. So now if we think about solving this problem, so basically what they have given is, let us assume we have an array A which has n elements. Okay, this is our array. Okay, let us take it a bit bigger. Okay, so this is our given array. Now its size is n, there are n elements in it. Now in the input we are given two integers x and y. Okay, so basically we need to find the minimum distance between the pair x and y. X and y will be distinct. Okay, it is given in the question. Okay, so let us say here we have x, here we have y, here we have y, here we have x, and let us say here we have y, and here also we have y. Okay, now understand one thing. So basically what they are trying to say is, whenever we can get different pairs of x and y. So let us say this is i1, this is i2, this is i3, this is i4, this is i5, this is i6. So basically they are saying whenever you get a pair of x and y, then you need to calculate distance between them, and the minimum distance out of all such possible pairs is my answer. Okay, so distance between these two x and y is how much? I1 minus I2 absolute value. We have to calculate distance based on indexes. Distance between I1 and I3 is I1 minus I3, right? Distance between I3 and I4 is I3 minus I4, right? Distance between I1 and I5 is I1 minus I5 absolute value, and so on. Understand one thing, it does not necessarily mean x should come before y. X can be after y also. We just need to calculate distance between two elements whose value is, one is x and another is y. Okay, so out of all such possible values, we need to return the minimum possible value. Now understand one thing, one way to do this is to use two for loops by the brute force method, and whenever we get one value as x, another value as y, calculate the distance between them, take one answer variable and store the minimum distance out of all possible distance in the answer variable, right? but that will take big O of n square time because we are using 2 for loops. Here we need to do it in big O of n time. We need to think of something more efficient. So now understand here one thing, that the minimum distance will be always when the x and y are adjacent, right? So what I'm trying to say is, see, this is one x and y, right? So if this is one x and y, then this distance will definitely be less than this x and y, because this y is nearer to this. Okay, so there is no need to calculate this distance. Again, this x and y distance will be definitely less than this x and y distance. Are you getting my point? Then what can we else say? So this now there is no x more, right? Let us take one more x. This x and y distance will be definitely less than this x and y distance, right? So what I'm trying to say is, for all the values of x, either the nearest y is on the absolute left side, the nearest left side, or the nearest right side. Similarly, for all the y's, the nearest x for that y is either on the next x on the left side or the next x on the right side. Okay, for this x, this y will not give the minimum distance because there is already one y here. So what I can do is, I can start traversing from left to right. I can maintain two variables. One is xi and one is yi. Xi is the index of the last x which was encountered, and yi is the index of last y which was encountered. And whenever we get xi and yi with some valid value, we will compare it with the answer variable. Okay, so what we can do is, we can initialize both of them as -1. Okay, now here there are some random values, okay, which are neither x nor y. Okay, so I start traversing from here. I encountered x, so its index is i1, so I'll say xi is equals to i1. Okay, now but yi is -1, so there is no reason of comparing the distance between x and y with the answer, because we have not encountered y yet. Now I moved further, I encountered y, so I said yi is equals to i2. Now xi is not -1, yi is not -1. It means we have found a pair, this x and this y. So what I'll say, answer is equals to minimum of answer comma xi minus yi, right? So that is i1 minus i2. So we have considered this pair. Okay, now we will go further. Okay, so let us say we again encountered y. Okay, so what I'll change yi equals to i3. Okay, now again xi and yi are not they are not -1, so I can compare it with the answer. So I'll again compare it, but answer will not change because this distance is obviously more than this. But the magical part is, yi has now become i3. Why it is magical part? Because now x will become i4 and we do not require i2 anymore, because for all the indexes greater than i3, whenever I encounter x, this will be nearer than this. So I did not require this value anymore. So I changed it to i3. So whenever we encounter x or y, we update the value of xi and yi. Now I moved further and I encountered i4. So x is equals to i4. Okay, so now the current value of xi and yi are this. So I'll again compare it with the answer, and if this is less than this, it will get updated. Now again I'll move further and y will become i5. Then I'll again compare i4 and i5 distance between them with my answer variable. Then I'll again get y and then I'll again get x. Okay, so basically what I'm trying to do is, I'll start moving from left to right. Whenever I encounter x, I'll update the xi value. Whenever I encounter y, I'll update the yi value, and I'll whenever xi and yi both are not -1, I'll compare it with the answer variable, and in this way we will get the minimum value of distance between x and y in the given array. How? Because as we saw here y got updated from i2 to i3, and it was true, because further if I encounter any x, this y would be nearer than this y, right? So I no longer needed the index of this y, so I updated it from i2 to i3, and that updation will go at every step. Now let's look at its actual code. So if we look at the actual code, so I have taken answer variable as -1 initially, then I have taken xi and yi as -1. I have taken one variable I to iterate, then for I equals to 0 to n -1. If a of I is x, then first of all update xi value is equals to current index I. If yi is not -1, so if y was encountered before, then only we can calculate distance between x and y. So then we will calculate the answer variable. Now if answer equals to -1, it means this is the first pair of x and y, because answer was initialized with -1. So I'll directly say answer equal to absolute value between xi and yi. Otherwise answer equals to minimum of current answer and absolute difference between xi and yi. Similarly, when I encounter y, first of all I'll update yi equals to I, and if xi is not equal to -1, it means x was encountered before. If answer is not equal to -1, this is the first x and y pair, then answer equal to absolute difference between xi and yi. Otherwise answer equal to minimum of current answer and absolute difference between xi and yi. And finally I'll return answer. So if I do not encounter any pair, it will be -1 only. I'll return -1, otherwise I'll return the minimum distance. What would be the time complexity? Time complexity would be big O of n, because we are using one for loop of size n. What would be the auxiliary space? The auxiliary space here would be constant, because we are only using some variables. Okay, we have not declared any array or something. Now let's submit this code. Okay, so let's submit it. So we have solved this question successfully. I hope you understood the solution completely. Thank you. Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem Pythagorean triplet. First of all, let us start by understanding the question. What does question say? Given an array ARR of n integers, write a function that returns true if there is a triplet ABC from the array where A, B and C are on different indexes that satisfies A square plus B square is equal to C square. Otherwise return false. So basically what we need to tell is that we are given an array which has n elements. We need to tell whether a triplet exists such that it follows the Pythagorean formula or the Pythagoras theorem, that is a square sum of squares of two elements is equal to square of the third element or not. So even if there is one triplet, we need to return true. We just need to tell whether there exists such a triplet or not. If there are no such triplets, we will return false. For example, here we can see A equals to 3, B equals to 4 will give me 9 plus 16, that is 25, and C equals to 5. 5 square will also give me 25. So 3 square plus 4 square is equals to 5 square. We have found one triplet, so we will return yes. Here there are no such triplets, we will return 0. You don't have to take input or print anything. You have to complete the function check triplet, which takes an array, a single integer n, that is the size of the array, as input parameters and returns boolean denoting the answer to the problem. Boolean variable will be true if there is a triplet which follows Pythagoras theorem, otherwise false. The driver will print yes or no instead of corresponding to the boolean value returned. So yes or no printing will be taken care by the driver code. The expected time complexity is n plus max of array of I square. So max of array of I is the maximum element of the array and it's a square, and the expected auxiliary space is max of array of I. The constraints are given here. So now if we think about solving this problem, so basically see, there are n elements in the array given and we need to tell whether a triplet A, B, C exists such that in the array such that A square plus B square is equals to C square, such that it follows the Pythagoras theorem. If even one pair exists, we will return true, else we will return false. Okay. Now what can be the brute force approach? The brute force approach can be to use three loops, like one loop with index I, another loop with index j, and another loop with index k. I will take care of A, okay, one loop will be for this element, another loop will be for this element, and another loop will be for this element. We will basically traverse over all the triplets possible, and for each and every triplet we will check whether A square plus B square is equal to C square. If we get even one triplet, we will return true. Okay, so this would be the brute force approach, but the time complexity of the brute force approach would be big O of n cube, right? So we cannot do this much. We have to decrease its time complexity. Now, and tell me one thing. See, what we can do here is, if I convert this into two loops instead of three, if I convert it into two loops, so let us say one loop for A and one loop for B. Okay, so I will get A square plus B square, right? So I can assume it to be C square. right? Then how will I get C? C will be equal to nothing but square root of a square plus b square. Are you getting my point? What I did in brute force, I needed 3 for loops. I want to decrease the time complexity. So can I do it in 2 for loops? Yes. So what I can do is, I can loop for these 2 elements. One loop will be for A, another loop will be for B. Every time I will calculate a square plus b square. Right? Now instead of looping over for all the possible values of C, what I said, okay, I have a square plus b square, then my C will be equal to under root of a square plus b square. Okay? If my C exists in the array, then my answer will be true. Else I will move on to the next pair possible of A and B. Right? In brute force, we were checking using 3 for loops, all the possible values. Here what we did, we calculated a square plus b square, calculated C as under root of a square plus b square. Why? Because understand one thing, if my A is 3 and B is 4, so 3 square will be 9, 4 square will be 16, the sum would be 25, that is C square, and C would be equal to 5. So now I need to check whether C equals to 5 is present in the array or not, instead of looping over all the values. Because for a particular A and B, there can be only one C possible if it exists, right? So there is no sense looping over all the elements, right? So now I can simply check whether my C exists or not in the array. But here also we can think of optimizing it even more. Why? Because if I use 2 for loops over the complete array, it will still be big O of n square. And we were said that the elements of the array are up till 1000. The array of I goes up till 1000, right? So what I can do is, I can take a count array, let's say count array of size 1001, right? Then what I can do is, I can store the frequencies of each element of the array in my count. So what I basically mean is, I can say count of 3 equals to 4. What does this mean? That element with value 3 has occurred 4 times in my original array. So I can use one for loop and update the count array. Basically, I'll take a count array, initialize all the indexes as 0, then traverse my original array and update the count array. So what I can do, I can say count of array of I plus plus for I equals to 0 to n minus 1, right? So I will store the frequencies of all the elements in my array. Now what I can do, see, suppose this is my count array with indexes 0, 1, 2, 3, 4, 5 and 6, okay, which basically represents the count of each element in the original array. Suppose my array is, let's say suppose the values in the array are between 0 to 6 only, okay. So let's say it is 1, 3, 3, 4, let's say 5, 6 and 2, okay, or let's say not 2 but 1. So what will be my count array? Count of 0 will be 0, count of 1 will be 2, count of 2 will be 0, count of 3 will be 2, count of 4 will be 1, 5 will be 1 and 6 will be 1, right? Now I can loop over this array. Okay, I can use 2 for loops. Why this will be more beneficial? Because here the size of the loop will be 1000, because the maximum value of any element is 1000, so the count array will be of 1000 size, whereas n was of size 10 to the power 5. Are you getting my point? N was the maximum size was 10 to the power 5 and the array of I maximum size is 1000. So if I do 2 loops over count array, it will make a loop size 10 to the power 6, whereas n square will give me 10 to the power 10. Okay, so what I can do is, I can use 2 for loops, one for A and one for B. Okay, so let's say my I is at 3 and J is at 4. I know that count of 3 is greater than 0, so 3 is present in my array. Count of J is also greater than 0, so 4 is also present in my array. Now I will calculate value of C. Value of C will be A square plus B square. That will give me 25. So this will give me 5. Now what I can do, I can directly check if count of 5 is greater than 0. If count of 5 is greater than 0, it means that I have found a triplet. Yes, the count of 5 is 0, it means I have found a triplet. So suppose this count was 0, the count of 5 is not greater than 0, it is equal to 0, I have not found a triplet. Are you getting my point? So I will use two for loop. First of all, I will construct the count array, then I will use two for loops over the count array, and whenever count of I plus is greater than 0 and count of j is greater than 0, I will check whether I square plus j square under root, that value is present in the array or not. If that is also present, we have found a triplet. I will immediately return true, otherwise I will next move on to the next loop. Okay, I hope you have understood the concept. Now let's look at its actual implementation. So now if we look at the actual implementation, so I have taken some variables here which will be used further, and I have also taken max element as array of 0. Why? Because I want to declare that count array. So what will be the size of the count array? It would be max element of the array plus 1. So first of all, I have initialized max element as array of 0, and then I have used the loop from I equals to 1 to n minus 1, and I have updated the max element equal to max of current max element and array of I. So in max element, I will get the maximum value of the array. Then I can declare this count array of size max element plus 1, okay, in which I will store the frequency of each and every element. I have initialized all the values as 0, then I have used a loop of size n and incremented the count respectively. Then I will use two for loops from 1 to max element and j equals to I plus 1 to max elements, as I said. If count of I is greater than 0 and count of j is greater than 0, first of all, I need to check whether both of the elements are there in the array or not. First of all, so I square, okay, so here what I am comparing is I square plus j square under root is present in the array or not, okay. So I square I have stored in A and j square I have stored in B. C will be equal to A plus B. So C will be equal to I square plus j square, okay, but I need under root of this. So D will be equal to square root of C. So D will be equal to square root of C, which is nothing but I square plus j square, okay. So basically I am checking whether I square plus j square is equal to D square exist or not, okay. So D is equal to square root of C. Now I again need to cross check whether D square is equal to C or not. Why? Because it might be possible that C is not a perfect square. Are you getting my point? So for example, let's say I is let's say 2 and j is let's say 3. So I square will be 4, j square will be 9. I square plus j square will be equal to 13, and their square root will return me what? It will return me 3. Are you getting my point? Because these are all integers. So D equal to square root of C, but C is not a perfect square. So if it is not a perfect square, there cannot be a Pythagoras triplet, right? So but this will return me 3. So after calculating D, I will again cross check whether square of D is equals to C. So what I am checking here, my C is equals to 13, that is I square plus j square. My D equals to 3, that is a square root of C. Now I again cross check whether D square is equals to C. D square is 9 and C is 13. These are not equal. So this was not a perfect square. Instead, you can think if C is 25, D will be equal to 5 and D square will be equal to C, right? So this is a perfect square. So I am again cross checking if D square equals to C, and if the D this value is less than equal to max element, it should be within that range, and count of that element is greater than 0, then I have found a pair. So I will return true. If return true does not execute any time, then finally I will return false. What would be the time complexity? Time complexity would be the maximum time is taken by this, that is max element square, and here I am using max element size for loop, and here I am using n size for loop. So I can say big O of n plus max element, I can say max element square, okay, because n is the full size of this for loop and max element square is the size of these two for loops. And what would be the auxiliary space? The auxiliary space here would be big O of max element, right, which is the space occupied for this array. Now let's submit this code. Let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.
Hi and welcome to Geeks for Geeks. Today we would be discussing the problem named as find transition point. I am Siddharth Hazra and currently I'm an SD at Geeks for Geeks. Besides that, I'm also a candidate master at Code Forces. Now let's start the discussion of this. So we need to find the transition point in a binary array. Seems complex to hear, but binary array is nothing but an array which only contains of 0 and 1. And the nature of the binary array is monotonic. So we need to find the transition point of a binary array. So in this binary array, the nature of the binary array is that it would start from 0 and it would end from 1. Be it something like this. Okay, or be it something like this. These are the three cases that can occur, and you need to report these all points like this, and here you need to return something as -1. Okay, so you need to return the first point of 1. Okay, so this, like, how would you come to the conclusion, like how binary search would kind of pop into your head? Like, there are two different intuitions for two people. If you are a beginner, then there two conclusions should pop into your mind. That the very first conclusion is that this array is a sorted array and we need to search something. Okay, if you are an intermediate, one more point should pop into your mind. That is, the nature of the array is monotonic. What is basically monotonic? Just telling you everything in brief so that the hype is not created for beginners. So monotonic functions are nothing but somewhat like the 0 0 0 1 1 or simply 1 1 1 or simply 1 1 1. Like, it is not a mix of 0 and 1s. If 0 has started, it would end with 0. If 1 has started, it would end with 1. Like, yes, no, yes, no, yes, no. There can be multiple yes, and like there can be multiple yes, 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 and then no, no, no. Okay, or no, no, no simply, or no, 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 or yes, yes, yes. It can't be yes, no, yes, no. It can't be something like this. So these are all monotonic function. This is not a monotonic function. This was all about the hype. Okay, fair enough. So these are the two things that should pop into your mind, which gives you an intuition that I need to use something like binary search. Okay, but how would you use the binary search? Why? Because if we have a mix of 0 and 1s, it might be a scenario that this, like, my binary search function lands me here and I return this value, but I don't want that. Binary search might land me here and this value is also equals to 1. If I try to find 1, binary search might land me to this, and then this is a wrong answer. Let me show you the point where this would go wrong. Let's say the number of 0 is 2 and the number of 1 is something like this. Here, if you already have noticed, this is the answer, but let's say this is low and this is high, then this would point to something in the mid. 1 2 3 4 5 6 7 8. Let's add one more so that the middle element would be properly identified. 1 2 3 4, and this is the fifth. So the middle element would lie here and this is equal to 1. So we would return this index, and this is not the answer, this is not the answer, this is the answer. At this point, at this kind of instance, our simple binary search would fail. But if you notice something, that if our mid is pointing to 0, then I need to take this L and go here. Like, let's say this is 0, like let's have all of this again. Okay, and let's just see everything again. Okay, so we have L here and we have low and high at this point, like we have in binary search. Okay, so if at any instance the mid is pointing at 0, then we know that this is a sorted array, so 1 would lie on the right hand side. So we would make this L go to mid plus 1. If this is mid, this would be mid plus 1 because mid is already checked. So I would simply say that if mid is pointing to 0, I would make low is equals to mid plus 1. And let's say for scenario that the mid is being pointed to somewhere here. Then if it is 1, then what I would do is, first it might be a probable answer. So else condition would be the condition where mid is equals to 1. So first I would update the answer. That is basically save the answer. And then I would say that let's go a little back in the memory. So little back means what? Go on the right hand side, because that is where you would find the first memory of yours. So you would say that high is equals to mid minus 1. Let me give you the intuition for this, like what is the basic understanding. Let's say I got into a relationship, okay, and on 3rd of this month it was my first date. On the 5th of this month it was my second date. On 7th of this month it was my 3rd date with my girlfriend. Okay, now let's say like my girlfriend asked me that, Siddharth, can you recall our very first date? I say yes, I can, but it has become a little bit hazy because it has been a long time. So what I tried to remember the date of the 5th. So she told me like, no, this is not the first date of ours. So I would go, so if 5th and my girlfriend told me that this is not the first date, then in memory I would try to find the date with the value greater than 5th. Like I would try to recall the memory after 5th or before 5th, which would make more sense. Recalling the memory before 5th would make more sense because the first date would have been happened at that side, not on this side. Okay, on this side of the calendar. If I move to this side on the calendar, I would be able to get the first date. But if I start going further in the memory, then I won't get the first date. In the same manner, if I got 1 and I want to find the first occurrence of 1, then I need to move on the left hand side, not on the right hand side, because right hand side there is no point in moving right hand side. I won't find the first occurrence of it. So I would be going on the left hand side. Going on the left hand side means what? Keeping h here, that is mid minus 1. Mid minus 1. This is why we are doing this. And the last updated answer. So I told my girlfriend that, see, is 5th our first date? My girlfriend told me no. Is 3rd our first date? She told me yes. So the last updated answer is our answer. In the same manner, every time we are able to find a date value, we would update the answer, and the last updated answer would be our first occurrence. Let us move to the implementation. This implementation would be very much akin to binary search, and let's see this. So being a lazy person, I would make this as A, and I would make low is equal to 0 and high is equals to n minus 1. We would move till the condition while low is less than equal to high. Int mid is equal to low plus high divided by 2, and then we would say if A of mid is equals to 0, then we should move on the right hand side, that is L is equals to mid plus 1. L is equals to mid plus 1. Else in all other scenarios we should say high is equals to mid minus 1, but we need to update the answer. Answer is equals to mid. Update the answer, then declare something known as answer. Int answer is equals to minus. So if it is not updated, it would remain as minus 1. So perfect combination why we had minus 1, and then we would return the value of answer. Let us see this, compile and run and see how many errors are we making. Seems like we are not making any errors. Now let us try to submit this and see how many errors are we forming, how many wrong answers we are getting. So we didn't fail. So that was a complete ACs. The time complexity of this problem is log n. So the brute force solution is nothing but iterating from the start, and the very first point where we receive a 1, we would say this, that is not possible. Why it is log n? Because each time the search space is reduced to half. That is why it is log n, log base 2n. That's it for today. Thank you and have a nice day. Hi and welcome to Geeks for Geeks. I am Siddharth Hazra and today we would be discussing top k frequent elements in an array. The intuition of the problem is quite easy. Like we can think of a solution, but having an hold over the comparators is the main question here. What is comparators? We would talk about it. So here it is told that we need to find the top k elements. What do you mean by top k elements? Elements with the highest frequency. Okay, so we need to sort the elements based on frequency. Based on frequency. This is what we need to basically do at this point. Okay, and then return the elements. If let's say 3 also has a frequency 3 and 4 also has a frequency 3, then 4 needs to be preferred among 3. Okay, so we can understand that we need to sort the values based on frequency. This is the very first reason, and the very next thing is after that based on the value it holds. Okay, we need to sort on the basis of 2 things, not just 1. Okay, so the very first thing we can do is we can simply keep a count of all the elements. Like yes, this number 1 has appeared 2 times, this number 3 has appeared 3 times, this number 4 has appeared 4 times, and we can make a pair. Okay, let's talk about the very first sample test case. Here in the second sample test case, here 1 has appeared 2 times and 2 has appeared 2 times and 3 has appeared 3 times and 4 has appeared once. So the top two elements would be this is the very first top element, that is 3, and the next top element is 1 and 2 both, but we would take prioritize on 2, so we want 2 also. Okay, this is what we want. But how to basically do this? So we can have something like this. If the values are less than equal to 10 to the power 5, we would be using an array for hashing. Else we can simply use a map to hash the values. So this can be done. What is the implementation of this? So basically we would declare an unordered map, we would iterate on each of the values and we would increment the count. Now comes the part, and we would be dumping all of the counts in a vector of pairs. Like we would have something like this. Now the question is sorting based on frequency and value. So what we can do is we can use something like comparators. Okay, comparators. What is this basically comparators? Comparators are special features. Like let's say what are comparators? Comparators are nothing, let's say cooking orders, I can say. Suppose I told that, can you make paneer do pyaza? He said yes. So then I told that, can you lower down the spiciness of the recipe? And then I also thought of some few minutes and then I told, can you lower down the salt a little bit? And he said yes. So these small instructions apart from the primary instruction can be also given to the sorting thing, and this whole thing can be done by using something known as comparators. So what I would say to the comparators is, I would say that prioritize, okay, P dot first is the element itself. See, this is the element and this is the frequency. So this is termed as second, pair of second, this is first. So first what I should prioritize? First I should prioritize the frequency. So I would say return P, let's say P1 and P2. Let's say P1 and P2 is there. So I want P1 to be ahead of P2 when P1 dot second, that is frequency of P1 is more than P2 dot second. This is the first condition I would give. The very next condition I would give is that when I want P1 to be before P2 after frequency, when P1 dot first is greater than P2 dot first. If I write these two conditions, then it would be absolutely easy. So I would just say if P1 is greater than P2 dot second, return true. Else, if this is true, return true. So now I would just write the compare function. So let us write the compare function. Or let's write the second condition first. If P1 dot second is equals to P2 dot second, if the frequency is same, then I want P1, then return P1 dot first greater than P2 dot first. Like if this is true, return true, else it would automatically be returned false. If this is not the condition, then the frequencies are different. So we would simply like return P1 dot second greater than P2 dot second, and this is done. Okay. So if the frequency is same, we would implement this. The frequency is not same, we would implement this. This is what I would written. Now let us just compile and see how many errors are we making. Seems correct. Let us submit this and see if we can get an EC or not. And yes, we got an AC. So time complexity of this is that we have implemented first hashed the values, that is big O of n if it is an unordered map. If it is an ordered map, like simple map itself, then it is log n multiplied by n added to, we are again sorting it, that is n log n. So the time complexity lies as n log n, ignoring the constant, and the space complexity is also big O of n because every element is unique. That's it for today. Thank you and have a nice day.
So hello people, welcome to this video. Let's solve the problem of the day. Well, today we are having letters collection. So let's read the problem. Problem statement says, the postmaster wants to write a program to answer the queries regarding letter collection in a city. A city is represented as a matrix mat of size n cross n. Okay. Each cell represents a house and contains letters which are denoted by a number in the cell. Fine. The program should answer Q queries which are as the following types. Okay. So the query of type which has three integers. The first one is number of the query, first or second. Then we have ij. You can say the location of cell. Okay. Then what we have to do is to sum all the letters which are at the one hop distance from the cell ij in any direction. All right. And for 2ij, we have to sum all the letters which are at 2 hop distance from the cell in any direction. We will see what we mean by that. The queries are given in a 2D matrix, queries, no problem. Okay. And these are the hop directions given. So let's try to understand what this question is saying. Here we have the examples. Let's try to calculate the answer for it. Seeing this example, we are given our n and m values, right? And the whole matrix here. Now the point of queries is here. Number of queries is given as 2, and this 2D matrix, which is actually having the queries, is here. So how do we read a query? Once we encounter query, we have three things written here: 1, 0, 1. This one means we're talking about the number of query, and then we have I and J. Correct? This is the address of cell in which we have to perform the query. Now for the second situation, we have 2, 0, 1. Correct? Let's solve the first query. The first query is to sum up all the elements at one hop distance. What do we mean by that? Okay, when we are talking about all the distances at one hop, that means we are talking about the 8 directions. What are the 8 directions? These ones. Okay, we have the 4 primary directions: the up, down, right, and left, and along with it, all the diagonal directions as well. So we need to cover each and every cell. If we are given 1, 0, 1, that means we have to perform the query in 0, 1 cell. What is the 0, 1 value here in this matrix? It is going to be this 2, correct? It is going to be this 2. So performing the first query on that would mean that we have to take each and every element that is present at one hop distance. That means these ones. That means these ones. Okay, what are the values? Values are 1 plus 5 plus 6 plus 7 plus 3. Right? And that results in 22, and that is given here. Correct? Okay. We could have had these values above as well, because that is out of the bound. That means that is beyond the boundary of the matrix. So we need to keep in mind that the boundary is there. All right, performing the second query, we have 2, 0, 1. Okay, 2 is not changing, but this time we have to perform the second query, right? So assuming 2 is the value that we are performing the query on, for that, we need to see all the elements which are at 2 hop distance. So let me mark the first hop one. After that, the next border. That means we are going to take this line. These are all at 2 hop distance. We cannot go here, correct? We cannot go here because this is out of the bound. Here, all these values, those are present. These are 9 plus 1 plus 3 plus 4 plus 8 plus 4, correct? Which will result in 29. So the problem is pretty simple. We just have to figure out how we have to travel this in a efficient manner. Okay, if we have to see one more example, the same thing is here. Here we are given a matrix, and then we are saying that we are going to be having only one query. The query is this. We have to perform the second query on 3, 2, on 3, 2. Third row, 0, 1, 2, 3, 3, 2, 0, 1, 2. That means this value. We have to perform a query in this 21. What will we do? We will see all the 2 hop elements. What are going to be the 2 hop elements? This time it is going to be this complete block, correct? Because all the 4 squares that are being formed, these 2 rows and 2 columns for our 2 hop distance nodes, or you can say the cells, the whole thing is actually coming under the boundary in this one. That is why we are beginning from here. 7 plus 8 plus 9 plus 10 plus 11 plus 17, which goes up to adding all the things up till 13 here. Okay, and then we simply have to return the sum. Now, how are we going to do that? What is the approach? Very simply, I have made one cell here just to tell you once more what are we actually going to do. If assume this is your ij cell, this is your ij cell, and we are talking about the first query. That means the first hop. So the cells which are directly associated with are just adjacent to it in the 8 directions, including the diagonal directions. We have these values, correct? We have all these values. So we have to just travel it, and we have to sum it up, correct? Now what if we are given the second query? Then we have to travel this complete matrix, this complete border, okay, which are at 2 hop distance, 1, 2, which are at 2 hop distance. Every element here is at 2 hop distance. Fine. Now, once we are given our I and j, what can we do? How can we travel these? Well, let's say if you're talking about the first query, that means we can do I minus 1 and j minus 1, right? I minus 1 and j minus 1. Where will this value get us? This value will get us here, correct? Similarly, I can go for I plus 1 and j plus 1. I will go to this cell, correct? Now I have I and j value of this, I have I and j value of this. I can simply travel like this from top to this end, this end line, correct? And I can simultaneously take this 2 and keep on summing it up. Then once I'm here, I can go from this to this direction because I will be having my j from here to here. Then I can move it from here to this cell. And along with this, we can parallelly add up these values, right? And eventually, when the sum is calculated, we have to return that. one more situation is there. What if my matrix is actually this much? Okay, is actually this much, and this being my ij value actually is going to be including these many cells at one hop only. We do not have to calculate these. For this, just to avoid this, we can simply make a utility function, which usually go by valid. And we can, what we can do is we can just check the boundary of our ij matrix, and simply we will see if the ij value for the cell are going out of the bound, we are not going to consider them. We are not even going to access them. Correct, resulting in no error. So it is pretty simple. This is for the first for the one hop, and the same thing can be done for the second hop as well. So if you are here, you can try figuring out this value by doing I minus 2 and j minus 2, and simply this value by doing I plus 2 and j plus 2. Once that is done, you just have to travel the boundary and we will get the sum of it. Correct? So let's see how can we code that up. Well, here's the code for the same. What I've done is I have created one normal list, which is what will be containing my answer in the end. After all the queries are performed, I'll be returning that. Now comes for query in queries. That means I'm traveling all the queries, and one by one we are executing all the queries. What I'm doing here is I have created an answer 0 just to keep the count of everything, to keep the summation of everything. Now I've taken these IJ, ILJL and IRJR. Told you which are these cells. These are the top left and bottom right cells, so that we can travel all the boundaries with the minimum efforts. Now what I'm doing here is I am traveling like this. Okay, and once I'm traveling this way, I can also travel this parallel way, right? That is what I'm doing here. I've taken up the queries. What I'm doing here is query 1 minus 0. That actually is I minus whatever the query is. If the query is 1, it will be I minus 1. If the query is 2, it will be I minus 2, right? I'll be having the values of these corner cells. What I'll do, I'll first of all run my I from IL to IR plus 1. That will take care of my rows, of both my rows. It will be adding these up. And how am I adding it? I've created a utility function valid here. I'm first checking that if the I and j are in the boundary of a matrix, only then I'm making the call and I'm adding the values. Okay. All right. This will be resulting in sum of both of these two, and this loop will be resulting in the sum of these two. Okay. Once we are traveling the columns. Fine. So eventually the answer will be containing the complete, you can say, two hop boundary or the one hop boundary, depending upon the query. Eventually, what do we have to do? We have to append it to the result, because there could be several queries, and eventually we have to return the result. Talking about the complexity of the problem, well, it solely depends upon the number of queries. The number of queries we have, you just have to execute it, because there are fixed number of cells that we have to travel, correct, for the one hop as well as for the second hop. So let's try to run this code against test cases. Here we have the same code. Let's try to compile it. Okay, so it is giving us the desired output. Let's try to submit that to test it against all the test cases. Okay, so it has passed all the test cases. So the problem was quite simple. I hope you've understood it. And if you liked the video and the approach, do tell me in the comments. Thank you so much.
Hello and welcome everyone. My name is Jadal Sanya, and in this video we are going to solve the question sum of lower and upper triangles. Okay, so the question is pretty easy if you know how to use loops on matrices. Okay, so let's try to understand what the question is trying to say. So given a square matrix of size n cross n, you have to print the sum of upper and lower triangular elements. So upper triangle consists of elements on the diagonal and above it. The lower triangle consists of elements on the diagonal and below it. Okay, so let's try to understand with the help of example, and let's start. So I've written down the first test case example which is given to us in the question. So you have to find out the sum of upper and lower triangular elements. So this is going to be your upper triangular, including the diagonal, primary diagonal, and this is going to be your lower triangular section of this matrix. So if I write down over here the upper triangle, so that would be 6, 5, 4, 2, 5 and 7. This is your upper triangle, and the lower triangle will be 6, 1, 2 7, 9 and 7. Fine, this is the upper and lower triangular elements. Upper, and this is your lower triangle. And you have to find out the sum. Let's find out the sum. That would be 6 plus 5 plus 4. That would be 9 plus 6. That is going to be around 15. 15 plus 2. That would be 17. 17 plus, let's say 7 will be equivalent to 17 plus 7 plus 5. 7 plus 5 is going to be 12. And 12 plus 17 is going to be your 29. Right? And this is going to be the sum of your upper triangle. And let's say to find out the sum of the lower triangle. So 6 plus 1, 7, 7 plus 2, that would be 9, 9 plus 9, that would be 18, and 18 plus 7 plus 7, that would be 14, so that would be 8 plus 4, that would be 12, and this is going to be your 32. So the sum of lower triangle is 32. And in the output, first of all, you have to print the sum of upper triangle and then the sum of lower triangle. Right, so 29 and 32. If you have a look at the output, it says 29 and 32 for this example number 1. Okay, so that is what the question is trying to say. It is pretty much simple, right? So now let's try to understand what can be the approach for this. So now if you focus on the upper and lower triangle, I have understood that, okay, we need to use for loop in order to solve this question. Then that's a good thing, because we simply need to iterate over the elements of upper and lower triangular, right? So basically you need to iterate over the upper triangle and iterate over the lower triangle to get the sum of the elements. So now I'll be writing down the indexes as well. So this will be 0, 1 and 2, and this is 0, 1 and 2. And now let's say if I'm going to use the nested for loop for this upper triangle. So one of the outer for loop will be having a loop variable, let's say I. This I will be iterating over each and every row, and there will be one more loop variable, that is inner loop variable, that will be j, and it will be iterating over the elements column wise, iterating over the elements of a particular row. Now let's say in the first row, how many elements are there? In the first row, which elements are going to be included? 0, 0, 0, 1, and that would be another one is 0, 2, right? So you can see that the loop starts from I and j, that is 0 and 0. When the loop starts for this j, the value of j is similar to what the value of I is. Basically, the j starts from the row number. Row number is 0, so j starts from 0. Similarly, let's say if I is equal to 1, how many elements are there? I can say 2 and 5. So the elements are 1, 1 and 1, 2. Similarly, over here you can see I and j are equal, right? I and j. Similarly, let's say if I is equal to 2, I can see the last element is included. That means the loop variable will be starting from the last, that is from this 2. So basically, which elements are there? So I can see 2, 2. Over here again, I and j are similar. Right? So based upon this observation, I can use two nested for loops. So the outer for loop will be iterating over the number of rows. I is equal to 0 till I is lesser than n. Now inner for loop will be iterating over the elements. So it will be starting from for j is equal to I to j is lesser than n. And you can simply use a variable called as up and keep on adding the elements array of I comma j. Fine. So this is your upper triangular sum. So I simply included all the elements that are starting from I until n. So this is the logic for finding the sum of upper triangular elements. Similarly, let's try to observe for the lower triangular elements as well. So now over here, I'll be again writing down the indexes. So that would be 0, 1 and 2. And over here, this is 0, 1 and 2. Okay, so now let's try to have the loop variable as well over here. So this is the loop variable I, and this will be iterating over the number of rows, and this loop variable will be iterating over the number of elements. So I starts from 0 till n, right? So I can observe that for the first row, the value of j, which is the element which has been included inside your lower triangular, that is 0, 0 element. Now let's say if I is equal to 1. So how many elements are included? The elements 1 and 2 will be included, that is from 0 till 1. So j goes from 0 till 1. So 0, 0, that is, which element will be included? 1, 1 will be included, and 1, so in the second row, which elements are going to be included? So it will be 1, 0 and 1, 1 will be included, right? So now you can observe the ending of the element. Which element is the ending? So I can see whenever I and j are ending, till that only I need to include inside the sum. See over here, I can see I and j. Whenever I and j are same, I will not include the elements after it. Similarly, when I and j are same, I can see no elements are included after it, right? So let's say if I is equal to 2, so which elements? I can see 2, 0, all these elements, right? That would be 2, 1 and 2, 2 are the elements. So I can see again how many elements are included. Until the value of I and j are same, all the elements are included. So j will be starting from 0 and it will be going till the value of I. So that is how it is going to work. So let's write down the for loop. So the outer for loop will be starting from I is equal to 0 to I is lesser than n, and the inner for loop. The inner for loop will be starting from j is equal to 0 to j is lesser than or equal to I. Right? And now let's write down the variable and let's add the value to it, right? So array of I comma j, low plus is equal to array of I comma j. So these are the two for loops, different sections of upper and lower triangular elements. And if you write down it inside your logic, inside your solution, then this is going to work perfectly fine. So I can see over here I have two different for loops, right? One is the for loop for the upper sum, and another is going to take the sum of the lower triangular, right? So what I can do over here, instead of having two different things, I can simply have the iteration over the entire matrix, and if the particular element is the part of lower, then I'll be adding that to the lower triangular sum, and if that element is the part of upper, then I'll be adding it to the upper triangular sum. So how to find out, how to identify whether this I comma j is the part of upper or lower triangular, right? So if you observe, based on this for loop, I'll be showing you the observation. See, inside this upper sum, all the values of j, what is the range of j? I can see j starts from I and it goes to j is lesser than n, right? So I can see each and every time the value of j will be greater than or equal to I. For any I comma j, whenever the value of j is greater than or equal to I, then that means that element will be added to your variable up. Similarly over here, if you observe the comparison between I and j, let's say this is your I comma j. Now we want to identify. So I can see the range of j is from 0 to I, right? So each and every time you will be able to see that the value of j is always going to be lesser than or equal to I. So if you find any kind of I comma j and you find out the value of j is lesser than or equal to I, then that means that element is the part of your lower sum. Okay, so this comparison is only required, and you can add this comparison if condition inside the iteration. So let's add that part. Okay, so what I'll be doing, I'll be having two different loops, I is equal to 0 to I is lesser than n. And now one more for loop, that is for j is equal to 0 to j is lesser than n, right? So I'm iterating over the entire matrix. And now you can observe over here, diagonal elements are the part of upper and lower sum, both of them. So if I find that if I and j are same, then I'll be adding that element to my upper and lower sum. So array of I comma j will be the part of upper and lower sum, is equal to array of I comma j. Fine. So now let's try to handle this part. If I find j is greater than I, so what I'll be doing, I'll be adding that element to my upper sum. So I'll be checking if the value of j is greater than I, then that means that sum will be upper. So my element will be added to my up variable. And now if the value of j is lesser than I, then that value or the element will be added to my lower sum, array of I comma j. Fine. And now what I can do, I can simply end the for loop, and this is the entire logic. This is the entire code. Okay, so this is the entire algorithm. Very simple for loop or iterations are required, right? So I hope you understood how to solve this question, the entire logical part and entire implementation part. So now let's try to code this entire thing, and let's get this question done, right? So let's start. So this is the entire implementation part, and I have written the entire code in Java, but the same can be implemented with the help of the algorithm in any different language. Okay, so this is your sum triangles method. Our matrix has been passed as an argument and the length of the matrix, right? So now what I'll be doing, I'll be having two different variables, upper and lower. I have iterated over the entire matrix. And now if I find if I and j are same, that element will be the part of upper and lower sum. And if I see that the value of j is greater than I, then that means that value will be the part of your upper sum. And if I find that the value of j is lesser than I, then that element will be the part of your lower sum. Right? So this is the entire iteration. And now, as the return type of this method is array list, so I have created one array list and I have just added the upper sum and then the lower sum, and then just simply returned the array list. So that is the entire implementation part. So now let's try to submit this and let's see the acceptance. And we can see that the problem has been successfully submitted. So I hope you understood everything about this question, and let's try to analyze the time and space complexity. Try to think about the time and space complexity. So the time and space complexity of this approach comes out to be order of n square, because you can see a single iteration over the entire matrix is required, and the length of the matrix is n square. So the time complexity comes out to be order of n square, and the space complexity comes out to be constant, because you are not using anything except variables, and variables does not depend upon the size of the test case. So the space complexity in this case comes out to be constant. As we can see, it is matching with the expected time and space complexity. So that was it for in this video. I hope you really enjoyed the solution, and if you really enjoyed the solution, do hit the like button and share it with your friends, and do comment down your approaches in the comment section. So that was it for in this video. I'll be meeting you in the next video. Thank you.
Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem print matrix in snake pattern. First of all, let us start by understanding the question. What does question say? Given a matrix of size n cross n, print the element of the matrix in the snake pattern like pattern depicted below. Okay, so if we look at the pattern, if this is the 4 cross 4 matrix given to us, then we will first print 10, then 20, then 30, then 40. From here we will take on left hand side. So 80, 70, 60, 50, 10, 20, 30, 40, 80, 70, 60, 50, then 27, 29, 47, 48, 27, 29, 47, 48, and then 50, 39, 33, 32, 50, 39, 33, 32. So starting from the first row, go on the right side, then come to the left side, then right side, and then left side. Okay, until we finish the last row. So for this also it would be 45, 48, 54, then 87, 89, 21, then 70, 78, 15. Okay, and so on. You can read the explanation here. It would be 1, 2, 4, 3, 1, 2, 4, 3. You don't need to read input or print anything. Complete the function snake pattern that takes matrix as input parameter and returns a list of integers in order of the values visited in the snake pattern. So we need to return one list which will contain the values of the matrix in snake pattern. Okay, visited in snake pattern. The expected time complexity is n square, and expected auxiliary space is also big O of n square. So now if we think about solving this problem, so let us assume that this is the matrix of 5 cross 5 size which is given to us. We need to print this matrix in the snake pattern. What is snake pattern? Starting from first row, we will go in right direction, then we will come down. Here we will go in left direction, then we will come down, then we will go in right direction, then we will come down, then we will go in left direction, then we will come down, then we will go in right direction, and here we will end. So basically first row in right direction, come down, then left direction, come down, right direction, come down, left direction, and so on until the until we reach the last row, until we finish the last row. So as I said, this statement only contains the solution. So basically let us say this is 0th row, this is first row, this is second row, this is third row, and this is fourth row, right? So what can we see here? For the rows which have even indexes, in that we are traversing on the right hand side starting from left. So 10, 20, 30, 40, 7, 90, 100, 1, 2, 9, 7, 8, 9, 10, 11. And for the rows which have odd numbers 1 and 3, in that we are traversing from right to left, 8, 50, 60, 70, 80, and 10, 3, this is 4, 5, and 6. So basically what I'll do, I'll start traversing from first row to nth row. If the row number is even starting from 0 index, then I'll store the element of that row from left to right in my answer list, then go to the next row. If the row number is odd, I'll store the elements of that row from right to left in my answer list, and then I'll go to next row, and I'll keep doing this row by row until I complete all the rows. I hope you have understood this. Now let's look at its actual code. So if we look at the actual code, so basically this is the matrix which are given to us, and we need to return a list of values in the snake pattern. So I have taken one vector answer, then I have taken n as the matrix size and m as the matrix 0 dot size. But here this is not need to take, even if you do not take, this is number of rows, this is number of columns. But since the matrix is of size n cross n, you can only take this also. Okay. Then what I have done, I have traversed through all the rows starting from 0 to n minus 1. If the row number is even, if the index is even, then I'll move the columns from left to right, that is 0 to m minus 1. So for j equals to 0 to m minus 1, answer dot pushback matrix of I, j. I is the row number, j is the column number. Else, if this is not even, this is odd, then we will execute this part. So I'll move my column from right to left, that is m minus 1 to 0, and answer dot pushback matrix I, j. Okay, I is the row number and j is the column number, and then I'll return this answer list. What would be the time complexity? Time complexity would be big O of n square. Okay. Because we are traversing the matrix. Okay. And what would be the auxiliary space? The auxiliary space will also be big O of n square. Why? Because we are using this answer list which will contain n square number of elements. I hope you have understood this. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, my name is Karan Masroor. Welcome to this video. In this video, we are going to look at the solution of the problem predict the column. First of all, let us start by understanding the question. So what does question say? Given a matrix 2D array or M of size n cross n consisting of zeros and ones only. So we are given a 2D matrix or 2D array. The name of that array is M and the size is n cross n. And it is a binary matrix. It only contains zeros and ones. The task is to find the column with maximum number of zeros. If more than one column exists, print the one which comes first. Okay, so we need to tell which column has the maximum number of zeros in it, and if there are multiple such columns, we need to tell the column which has the smallest index value. Okay, print the one which comes first means the column which has the smallest index value. Here if I look in the first column I have 0 1 0, so there are two zeros, or in the 0th column. Okay, we are starting with index 0. So in the 0th column it is 0 1 0, we have two zeros. In the first column it is 0 0 1, again we have two zeros. In the third column we have 0 1 1, there is only one zero. So maximum number of zeros in any column is 2, that is in 0th column and in 1th column. But whenever there are multiple columns with maximum number of zeros, we return the one which comes first or which has the smallest index value. So I return 0. Okay, 0th column, 0 based indexes, having two zeros, which is the maximum among all columns and comes first. Okay, your task is to complete the function column with max zeros, which should return the column number with maximum number of zeros. Constraints are given here. Okay. So now here we are asked to return the column number which has maximum number of zeros. So basically what we can do is, for each column we can count the number of zeros, and whenever we get a maximum count of zeros, we can store that and update the answer column. Okay, so what I'm trying to say is, let's say this is 0th column, this is 1st column, this is 2nd, and this is 3rd column. Okay, let me take one variable maximum count of zeros as zeros. Okay, now I ran a for loop and counted the number of zeros in the first column, and it came out to be 2. Right now, since 2 is greater than maximum count of 0, because this I have initialized with 0, I will update maximum count of 0 as 2, and I will update the answer column as 0. Okay, because this is the 0th column. Now I'll come to first column. Here I'll count the number of zeros and it will turn out to be 3. So 3 is greater than 2, yes, so I'll again update it. So maximum count of 0 will become 3 and my answer column will become 1. Okay, now I'll move on to the third column. Here the number of zeros is 1. Is 1 greater than 3, the maximum number of zeros in a column encountered till now? No, so I'll do nothing and I'll move on to the next column. Here the number of zeros is 3. Is 3 greater than 3? No, it is equal to 3. And we ever said that whenever there are multiple columns with same maximum number of zeros, consider the column which comes first or which has the smallest index value. So in this case also we will not update the answer. Our answer will remain first column only, and we will return answer underscore C. Now let's look at its actual implementation. So if we look at the actual implementation, so I have taken one variable max underscore z, which will count the maximum number of zeros. Z I have taken to count zeros in a column. I have taken some variables, and answer underscore c is the column with the maximum number of zeros. I have initialized it with -1. Answer underscore c means answer underscore column. Okay. Then for all the columns, remember, don't confuse, we are traversing column by column. We are not traversing row by row. So I is representing column. Okay. So I'll traverse from column number 0 to n-1, and I'll make the count of zeros as 0, because now for that column I want to count the number of zeros. Then for that column I'll count all the rows. Okay. So for j equals to 0 to n-1. Okay. So basically, let us say this is my ith column. I am counting for this. So my j will vary from 0, 1 up till n-1. Okay, so j is the row number. I am counting for this column. So for j equals to 0 to a minus n-1, j is the column. Remember, it is the first index here. Array of ji is 0. If it is 0, then increment the count of zeros. So basically, using this for loop, I will count the number of zeros in the ith column. Then if the number of zeros is greater than maximum count of zeros, then update the maximum count of zeros as z, and also update the answer column as I, because current column has the maximum count of zeros till now. And finally, we will return answer underscore c, which is the column having maximum number of zeros. What would be the time complexity? Time complexity would be big O of n cross n, because we are traversing the whole matrix. What would be the auxiliary space? The auxiliary space will here be constant, because we are only taking a few variables. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is number following a pattern. First of all, let us start by understanding the question. What does question say? Given a pattern containing i's and d's, I for increasing and d for decreasing, devise an algorithm to print the minimum number following that pattern. Digits from 1 to 9 and digits can't be repeated. So what they are saying is, basically we are given a string which contains I and D. Okay, I means increasing, D means decreasing. Now if there is a I at a certain point of time, then there should be an increment in the number. Okay, so we need to derive a number which follows this pattern. Okay, in that number the digits will be from 1 to 9 and the digits can't be repeated also. Okay, and it should be as minimum as possible, and if there is a I, then the next digit should be increasing, and if there is a D, then the next digit should be decreasing at the respective place. Okay, so if we look at this example, so there is D. Now understand one thing, if the string length is 1, then the output will be of 2 length. Why? Let's say string length is of 3. Okay, it means there are 3 points where I can say decreasing or increasing. Now if there are 3 points, the number of digits should be 4. So I will compare first and second digit, second and third digit, third and fourth digit, then there will be 3 times increasing or decreasing. Okay, so there is decreasing. So if I relate first and second integer, then there should be a decreasing relation. So 2 is greater than 1, so 1 is decreasing, right? From 2 we went to 1. Okay, and this is the smallest number possible. Okay, now here it is I, D, D, D. So first it should be increasing, then decreasing, decreasing. So it is first increasing from 1 to 2, then from 2 to 6 also it is increasing, then from 6 to 5, 5 to 4, and from 4 to 3 it is decreasing and decreasing. Okay, so you can look at the example explanation here, and this is the smallest number possible. You don't need to read input or print anything. Your task is to complete this function which takes the string s and returns a string containing the minimum number of following the valid number. Okay, the expected time complexity is big O of n, and expected auxiliary space is constant, and the length of the string cannot exceed 8. Okay, and in the question we were said that in our answer string we only need to take digits from 1 to 9 and no digits can be repeated. Okay, here we also do not need to repeat any digit because the length of the string can be at max 8. So the length of the answer can be at max 9, right? Because length of the answer is always 1 more than the length of the string. Okay. So now if we think about solving this problem, then one way to solve this problem is by the brute force method, right? So if there is, let's say, string, let's say IIDD, so our answer string length would be 5. Okay, so first of all it will be increasing, then also it will be increasing. So this is increasing, this is increasing, then it would be decreasing. Now you cannot repeat. Okay, so here you cannot take 2, so this might not be a valid possible answer. Okay, so you can take 1, 2. Okay, then I think you can take 5, then you can take 4, and then you can take 3. So this is increasing, this is increasing, this is decreasing, and this is decreasing. Okay, so this condition is fulfilled and you get one answer. Okay, so what will be the brute force method? Brute force method would be to recursively place all the possible digits at different places and try all possible combinations, and whenever we satisfy this condition, we will compare it with the answer string, and among all the possible strings we will take the smallest string possible, right? So that will be the brute force method, but that will go into exponential, right? So we need to think of something efficient. Here the expected time complexity is big O of n, that is the length of the string. Okay, so now what efficient can we think of? See, what we can do is, let's say you have decreasing, decreasing, decreasing. Okay, so now there will be 3 decreasing relations. So one you can take is 9, 8, 7, 6. Another you can take is 4, 3, 2, 1. Now you need to take the smallest possible. So this is your answer and this is not your answer, right? First thing. Second thing is, so if there are 3 decreasing, I need 4 digits which are in decreasing order. Okay, so I can start with 4. That is the best option with me. Okay, are you getting my point? If there are 3 decreasing, so there will be 4 digits for these 3D respectively. So I need 4 digits. Now I want them to be decreasing. So what I can do is, best option is start with 4, then 3, then 2, then 1. So this is what we need to take care of. Now another thing is, we cannot repeat the digits. Okay, so let's say if I have increasing, then decreasing, decreasing, then first of all I want to increase. So now here I cannot take 2 or 3 or 4, so I need to take 5, right? But if I take 5, I will not be able to decrease 2 times. Okay, so I think the best option would be to take 7 and then 6 and 5. Okay, so this is decreasing, this is decreasing, this is decreasing, this is increasing, this is decreasing, and this is decreasing, and there is no repetition of characters. Okay, now so 7, 6, 5 were the smallest possible 3 digits which I needed to take in place of these 2D in order to satisfy the condition that it is decreasing, it is it is the smallest number possible, and there is no repetition. Are you getting my point? Otherwise I could have taken 3, 2, 1, but there should not be any repetition also. So now first of all, when we want to compare 2 numbers, how do we compare? So let's say I have 2 numbers 1, 2, 3, 4, and another is 9, 1, 1, 1. Which number is smaller? This number is smaller, right? How do we compare? We start from moving from left to right, and whenever we get a mismatch, we compare those 2 characters. Now this is smaller than this, so this number will be smaller than this number irrespective of what the other digits are there on the right hand side, and this is true for same length number. Okay, and here whatever string we generate, their length would be n plus 1 only. Okay, so this is the concept. Okay, when you are comparing 2 numbers which have same length or same number of digits, you move from left to right, and whenever you get a mismatching character, that you compare whichever string or whichever number has that character smaller, that is a smaller string or number irrespective of the characters on the right hand side. So now combining these 2 concepts, let us take one example. Okay, so let's say we have a string d d d I I d d, so it is decreasing, 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 then increasing, increasing, then decreasing, decreasing. So what we will do, whenever we find a d, we will find the consecutive number of d's, and then we will see what we can fill in this way. Like for example, here we were able to fill 4, 3, 2, 1. So whenever there are d, we will keep counting. Whenever we encounter I, we will first fill the remaining part. Okay, so here the string length would be how much? This is how much? 7. So our answer length would be 8. Right, so here I encounter d, then d, then d. So total 3 d's are there, and then I encounter I. So whenever I encounter I, first of all I will fill the remaining part before I. Okay, so now there are 3 d's, so I need 4 values, and I have not taken any values. So the best values will be 4, 3, 2, 1, right? Because I need to take the smallest possible values, right? So that we get the minimum number, and we fill it in this way. Okay, don't worry about the implementation, we will also have a look at it how we will implement it. Now we will move on to this I. Okay, now whenever we encounter I, we fill the values, we fill the remaining values before it. Now when I encounter this I, this value is remaining to be filled, which was with respect to this I, right? Whenever there is D, we just keep counting the consecutive number of D's. Whenever there is a I, we fill the remaining part before I. So now when I encounter this I, the number with respect to this I was remaining. Now what is the smallest possible number which can fit in this place? It is 5, right? So I will take 5. Okay, now I will encounter D, so I will just keep on moving. I will encounter D, so I will just keep on moving. I came out of the string. Now here there are 3 possible values, and I want it to be increasing, decreasing, decreasing. Now this increasing step we do not need to check, it will by default be increasing. Why? Because we are not repeating the characters, and from the starting we are filling the smallest possible values. Why? So that we get the minimum number. So we are filling the smallest possible values, so the next value which I can fill here is either 6 or 7 or 8 or 9. So there is no question of repetition, and the smallest possible values are filled in these 5 places. So here definitely a number bigger than that will come. Okay, now what I see that 3 places are remaining to be filled. So what are the smallest 3 values which I can take? It is 8, 7 and 6, because here it was 5, so I need 6, 7 and 8. So this is increasing and this is decreasing, decreasing, and this is the smallest possible number. So just to conclude, what we will do, we will move from the string from left to right. Whenever we encounter D, we just keep moving. We will count that, okay, this many characters are left to be filled. Whenever we encounter I, we first finish the remaining part on the left hand side and then move further, and in this way we get the smallest number possible with no repetition, and also following this pattern. Now how we will exactly implement it, let's have a look at it. So now if we look at the implementation, so this is the string in the input, then I have taken one answer string and then some variables. We will see their use now. The n is the size of this string, and I have taken one stack, and size of stack, sz represents size of stack, and I have pushed in 0. So what basically it denotes, see what we said, whenever we encounter D, we will not fill in the string, we will just mark it that these many characters are remaining to be filled, or these many indexes are remaining to be filled. So how we will know that these many indexes are remaining to be filled? Whenever we skip a index, we will not fill it, we will push that index inside the stack. Okay, and sz will represent the size of the stack which will be used further. And first of all, I'll push the 0 inside the stack. Why? Because let's say I have only one character D. So what does that denote? That second character is smaller than first character, right? But first character we are not starting to fill immediately, because if there are 2 D's, we might fill 3, 2, 1. If there is only 1 D, we might fill 2, 1. Okay, so it will depend upon the pattern. So first of all, I have pushed 0 inside the stack. Then I have moved from I equals to 0 to n. First of all, if s of I is I, that is increasing, and else part. So else means if s of I is D. What I said, whenever we encounter decreasing, we will simply push that index inside the stack, we will not fill it, and size of stack will become plus plus. Whenever we encounter increasing, we take j equals to j plus size of stack. So what is basically j denoting? J is the denoting that start from this number to fill the remaining characters. Okay, so what I am trying to say is, let's say if I take this example. Okay, so first of all, inside the stack I pushed 0, then I encountered D, so I pushed inside the stack 1, then I encountered D, so I pushed inside the stack 2, then I again encountered D, so I pushed inside the stack 3. My size of stack is 4, and now I encountered increasing. So I want to fill the 4 values inside the stack. J was initially taken as 0. So what I will say, j equals to j plus size of stack. Size of stack is 4, this is 0, 0 plus 4 is 4. So I will start filling from 4 until the stack is empty. So I will say 4, 3, 2, 1. Now j value is 4. Okay, remember this. Now I encountered this I again, but I pushed this I index inside the stack. So I will pop out these all elements because I have filled it, and inside the stack I will push 4 for this I. Now when I encounter this I again need to fill this index, because whenever we encounter I, we will fill the remaining indexes on the left side. Now it is 1. So j will be equal to j plus size of stack. Size of stack is 1, j is 4, so it will be 5. So it is telling fill 5 here. Okay, now this will be popped out. Now I encountered D and D, but before that I will push this index inside the stack. So I will push 5, then I encountered D, so 6, then I encountered D, so 7. Okay, now we came out of the string. Now I want to fill these 3 indexes. So j equals to j plus size of stack. So that is 5 plus 3, that is nothing but 8. So it is telling me start filling from 8 and go in downward direction. So I said 8, 7 and 6 until the stack became empty. So I filled 3 places and this is my answer. So j basically denotes from what character I'll start, and I'll keep on moving. I'll keep on decreasing 1 character. Why decreasing? Because whenever we encountered increasing, we filled the remaining part. So we will not encounter increasing. We will encounter decreasing only together when we are filling the stack. Whenever we encounter 2i together, we directly fill for one position, then move on to next position, right? So j is basically used for that. Okay, so if we look here, I have said k equals to j, and while size of stack is greater than 0, answer equals to answer plus k plus 48 to convert from ASCII value to numerical value. Numerical value to ASCII value, and then convert it into character, k minus minus and size of stack minus minus. Now why I used k instead of j? Because I do not want to lose j's value, right? It will be added on top of stack every time, right? On top of stack size. So we cannot lose j value, and here we had to decrement this variable. So I took k and I decremented it until the stack became empty, and then I pushed the ith index and made size of stack plus plus. Okay, then when we came out, it might be possible that the stack is not empty, so there are some possible characters to be filled. So I'll say j equals to j plus size of stack, k equals to j, and while size of stack is greater than 0, fill in the values, and then finally I'll return the answer string. What would be the time complexity? Time complexity would be big O of n, where n is the length of the string, because we are using one for loop. Okay, what will be the auxiliary space? The auxiliary space here would be big O of n, because the answer string will contain n plus 1 characters. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood this solution completely. Thank you.
Hi and welcome to Geeks for Geeks. I am Siddharth Hazra, and today we would be discussing the problem named as isomorphic string. So before we move forward, let us first understand the definition of isomorphic string, and then the problem statement would be just a one-liner. Isomorphic string tells us that if there is a string known as A, B, and there is all other string known as X, X, Y. Basically, this is the very first test case itself. So if we map A with X and B with Y, okay, then we can make this string convert to this, okay, or vice versa. So we can convert this is let's say S1, this is S2. So we can convert S1 to S2 by mapping each character to one character. But there is one thing, like A, if we replace it with X, it would become A. It would become again A, and B we have already replaced with Y, and this would become the vice versa of it. Okay. So let's take the very next example. So let's say we have S1 as A, B, and S2 as X, Y, and Z itself. So now, if we map the value A to the value X, then we see a new value, that is A again needs to be mapped with something other than X, because A is already mapped with X, and now he needs to be mapped with something else. So let's say there is a classroom, and we need to make dance partners out of that. So every boy needs to be paired with one girl, and one girl needs to be paired with one boy. So now if let's say there are different students, like let's say the very first one is me itself, that is Siddharth, then let's say Abhinav, then let's say Nishant, and let's say this is here as Samriddhi, let's say this is here as Ankita, and let's say this is here as Nikita. Okay, So if Siddharth is paired with someone, let's say Ankita, then he can't be paired with someone else. If someone new is trying to pair up with Siddharth, then this is invalid. So in the same manner, a particular character can be mapped with a single character or itself, but nothing else. Okay. So now if this is possible, that after mapping, if no characters are mapped to, if every character are mapped with one character only, no character is mapped with two characters, then we can say that the string is isomorphic. Okay. So if you just see the definition, if you write down the definition, if you write it out, then you can clearly see the solution. That if at any stage, like what the real thing we are trying to do. So we can first try to start mapping it. As of now, A is not mapped with anything. So we have mapped A with X. Okay. Now we again see something known as AY. This time A is already mapped with X. Now it can't be mapped with someone else. So we can say that at this point only, the condition of isomorphic is false and we are returning false at this position. Okay. So at this point, we can say that if at any point one needs to be mapped with something else, then it is not possible. So we would basically store the pair of both the strings. Like for this string, for the current character, A needs to be mapped with X, let's say. Let's understand this again. So we would maintain two mappings. Okay, one for S1 and one for S2. So let's say I have said that A needs to be mapped with X and X needs to be mapped with A. Here again, A needs to be mapped with Y. So A is already mapped, so we won't do anything. We would say that this is not possible. We would return a cross from this point only. So if no mapping is there, we would map it. If mapping is there, we would ignore it. And after that, we would check if the mapping of the first character is with the second character or not. Okay. Now let us do this in action. So I would just name it with S1 and this as S2. So now it is a clear solution that if the length is only different, if the number of boys is not equal to the number of girls, we can't map partners in dance. So we would say if S1 dot size, or let's have N1 is equals to S1 dot size, comma N2 is equals to S2 dot size, then we would say if N1 is not equal to N2, if the numbers are only unequal, return 0 from this point. After that, we would have two map. Okay, map of int comma character or character comma character and name it as M1, and again the same thing, M1 comma M2. Okay, now we would start iterating. For int I is equals to 0, I is, or we can just have a for each loop, for auto e dash s, or no, we need the indexes. So for int I is equals to 0, I is less than n and I plus plus. So if at this point, let's say this is A and this is X. So at this point, if A is not mapped with anything and X is not mapped with anything, then only we would map. So we would ask that if M1 of S1 dash I is equal to 0 and M2 dash S2 dash I is equal to 0, you can just have a not here instead of equal to 0, then only we would update it. So we would say M1 dash ST S1 dash I is equals to S2 dash I. We would map A with X, and then we would go to the second mapping, m2 of s2 of I is equals to s1 of I. It's done. After all of this, if m1, okay, if m1 of s1 of I is not equal to s2 of I, like if after this, if a of 0, if this is not mapped to this, if map of a is not equal to x, then we would return 0. Okay, and then the vice versa of it, the x to a, and then m2 of s2 of I, if that is not equal to s1 of I, if the vice versa is not equal, we would return 0 at any point. After all of this, if we are not able to find a violation, we would say return a true. Like as of now, we are not able to find a violation till the very end, so we are returning true. So for int I is equals to 0, so I have written here this. Now this should work. For int I is equals to 0, this needs to be n1. Yep, we can take either of the size. Yep. So we just need to map out the values, like a after mapping with x and x after mapping with a. Now after mapping all of this, we need to evaluate. If after all of this, if we go to the index a, is x really present or not? If we go to the index x, is a present or not? If after this we are checking for the violation here. If either of the condition is failing, we are saying that this is a violation and this is a false. That's it. So that's it from my side. Talking about the time complexity of the problem. The time complexity of the problem is big O of n, because we are iterating on the string exactly once and we are saving all the characters, but the number of characters, the mapping of characters, as this is a lower case, so it would be 26. So the space complexity is constant and the time complexity is big O of n. That's it from my side. Thank you everyone. Hi and welcome to Geeks for Geeks. Today we would be discussing the problem check if the string is rotated by 2 places. So the problem statement or the name itself is very self-explanatory and the problem statement is not much needed. So we just need to check if the string is rotated by 2 places or not. Okay, so let's start with the very first sample test case. So we have something like Amazon. Okay, now this string is rotated by 2 places, like B, like this is B and this is A. So we need to check if B is a rotation of A by 2 places. मतलब जो B है वो A के rotated string है कि नहीं. Now there are 2 types of rotation. One is clockwise rotation, one is anti-clockwise rotation. Okay, so now the very first one is clockwise, like anti-clockwise rotation. Let's say anti-clockwise rotation by 2 places. So everyone would go by 2 places. Fair enough. So this Z, like this A would come here and then this M would come here. So A is coming here, this M is coming here, A would come here and then Z would come here. And then this N would come here and O would come here. Okay, this is the very first way. Okay, if this is rotated on a, and the next one, okay, let's do it just above it and this would make more sense. So now this time everyone would go to the clockwise rotation. So let's just change the color and let's say by 2 places. Okay, so N should come here, O should come here, and then Z should come here, okay? Z should come here, and then A should come here, okay? And then here it should go as A should go here, okay? After A is rotated, A should come here, and then M should come here, okay? So now if you see, out of these two strings, this is the string that is B. So yes, B is a rotation of A. So basically, if you just see out the sample test case itself, you can observe that what we can really do is, given A, we can rotate clockwise, and the next one is rotate anti-clockwise. And out of this, if anything is equal to B, we would say it is a yes, else we would say it is no. We can say this. Simple enough. But the question is, how would we do it? So let's just observe the given one. We have something like Amazon, okay? So if it needs to be rotated on the clockwise, that is, everything would go on that side. So we know if everything would go on this side, everything would shift this side. So we can say that Amazon would shift to that side, and the very first two AM would come here. Makes sense? So what we really can do is, so 2 is constant. So this is the index 1, this is the index 2, this is the index 3, this is the index 4, this is the index 5, this is the index 5. 1, 2, 3, 4, 5. Yep, there are 6 characters and indexing is still 5. So we can say, we can take the substring from 2 till the value of n-1. We need to take the substring of this, and we need to concatenate the substring 0 to 1 at the end, and this would be nothing but the clockwise rotation of it. Now we need the anti-clockwise rotation, okay? We need the anti-clockwise rotation. So anti-clockwise means everything would go that side, okay? So if everything would go that side, so that means that this thing would remain constant, and O would come here, okay, like this O would come here, and then N would come here, okay? So the anti-clockwise rotation would be the last two character, that is ON, okay? That is ON, that is what? Last two, n-2 till the value n, that is n-1, the last two characters, and then we add to something like Amazon, okay, and that would be nothing but the value of 0 till the value of n minus, like how many characters? Leaving 2 characters, that is n-2. Leaving 2 characters, this is the number of characters, this is the number of characters basically. So we would have from 0 till the value of n-2, that is just this, okay? So we need the value of 2 till the value of n-1, okay? And this can be easily implemented in C++ by writing something as substring of 2. So this would automatically tell that we need till the end. If no second parameter is passed, it would take till the end. If we want 2 characters from the start, so we would say 0, 2. Why? Because that would take 2 characters from the start. This is it. So we would say this is n-2. So we would say n-2, give me how many characters? 2 characters. So I would just say 2 characters, okay? And how this can be implemented? We again want all the from 0 we need to start, and we want to take how many characters? We want to take n minus 2 characters. So we would say n minus 2 characters. And this is how we would implement. So we would be using this, 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 and this to implement this. Now let's move forward to the implementation. So we would basically have the rotation of both the strings. So we would have the rotation by clockwise and anti-clockwise, and if either of them is equal to b, we would return true, else we would return a false value. So now let us have this as s1 and s2, so that we need to write less. Now if the length is unequal, then there is no point of having that. So n1 is equals to s1 dot size, comma n2 is equals to s2 dot size. We need to do this. Okay, now we need to start off. We would say if n1, like if the length is not equal, there is no point in moving forward. If n1 is not equal to n2, return 0 from this point only. Now if there are only 2 characters, then the rotation would make no sense. So if n1 is less than equal to 2, okay, or n2 is n1, like both the string now has same length. So if n1 is less than equal to low, like if the rotation, like if there are less than equal 2 characters, then how can we rotate it by 2 places? So we would simply say return n1 s1 equal to s2. If s1 is equals to s2, we would return true, else we would return false. Why? Because if the number of characters are less than 2, how can we rotate it by 2 places? It would remain the same. Like a rotated by 3 places, 4 places, anything you do, it would remain the same. A be rotated by 2 places, it would remain the same. There is no point in doing that. So we would just return that. Now we would have the string of clockwise is equals to a blank string, and anti-clockwise as also equal to a blank string. Now we would have that. Okay, so now we would say that anti-clockwise is equal to what? S1 dot sub str of 2 added to how much? S1 dot sub str of 0, 2. Like we would take the 2 characters and we would append it at the last. Clockwise is equals to s1 dot sub str of how much? n minus 2, and we want to take how many characters? We want to take just 2 characters. And s1 dot sub str of how much? 0, n minus 2. Just a small bit of note, you can rotate a by 2 places or b by 2 places. That would make more sense. Okay, so now we would say return, okay, return anti-clockwise is equals to s2, or clockwise is equals to s2. If either of them is equal, we would return true, or if both of them is equal, it would also return true. But in all other cases, we would say it is a false value. So we wrote n, and this would be n1. Let's just take either of them, because at this point n1 both are true. Okay, seems correct. Okay, so let's talk about the time complexity of this problem. So basically we are just concatenating the string again and making a new string, and but we are just using variables. So we can say that space complexity is constant, the time complexity is big O of n. Okay, so that's it for today. Thank you and have a nice day. Hi and welcome to Geeks for Geeks. Today we would be discussing the problem shortest common supersequence. Before we move forward, let us first talk about the feedback of this problem. This problem is a medium level problem, which is a wrapper of a very standard problem, that is longest common subsequence. So at this point you might have realized that longest common subsequence is a prerequisite. So if you don't really know dynamic programming, or if you don't really have good grip over recursion, or if you have not solved up this problem, that is longest common subsequence, kindly refrain yourself from continuing. Pause at this point, learn those topics, come back to this, then you would be able to apply the learned concepts to this question, and you would be able to score one more question mark, one more solve count. So now let's move forward. So talking about this problem tells us that we are given two strings. Okay, let's say the very first string is A, B, C, D, and the very next string is X, Y, C, Z, C, D. It is telling us that we need to tell the length of a string which contains X as well as Y as subsequence. Remember this. Now, what can be the probable string? So if we just say, let's take A, B, X, Y, C, X, Y, C, D. And this should be the shortest length. Remember this. This particular length should be as minimum as possible. So now if you observe A, B, C, D, A, B, C, D, it is in the order that it is appearing. So if you are still not familiar with the definition of subsequence, it is that all the alphabets of this particular X and Y would be there in the given resultant string in the same order as they appear. In the same manner, X is here, X, Y, C, D, X, Y, C, D is in the order that it is appearing. Okay. So this is the question, and this length, you just need to return the length. Focus on this. You don't really need to return the resultant string, you just need to return the length. The very first observation is that if only the length is asked, then we should remove our focus on making up the string. So remove focus on getting the resultant string. Okay, like you shouldn't have the focus कि वो resultant string कैसे बनेगा, कैसे बन सकता है, क्या क्या हो सकता है. इसी पॉइंट से अगर आपको लेंथ ना पूछा जाए तो आपको उस लेंथ सिर्फ पूछा जाए तो आपको उस रिजल्टेंट स्ट्रिंग पे ध्यान नहीं देना है. What I meant to say is, if only the length is asked, don't focus on getting the resultant value. Focus on the length itself. Okay, this is the first observation. Now, if only the length is asked, okay, if only the length is asked. So if you observe, this is the very first observation you would see, that what is this? What is the length? The length is 6 and this length is 4. This length is 4. So if you observe that this somewhat has a relation. How? See, A, C, D. The game is played at this point. Okay? Rest everything is unique. So every unique thing needs to be represented individually, but all the common things, they kind of contribute as one. Like if you observe A, if you observe C is C and D, C and C is contributed by just once, as well as D and D is contributed just once here. मतलब जो common है वो एक बार कंट्रीब्यूट करेंगे रिजल्टेंट स्ट्रिंग पे. ओके, जैसे सी डी आर कॉमन, सो दे आर रिजल्टिंग एज जस्ट वन. ओके, एंड ए सी डी, ओके, एक्स वाई, यप, दे आर रिजल्टिंग एज कॉमन. ए बी सी डी, 6y, yep. So now, see, you can clearly see that the common is just contributing to 1. So if I can get, so I can say, like at this point, let me remove everything. I can say that this would be all the characters which are not common. That is, all the characters which are not common. That A is not common, so A. Then B is not common, so B. Then C is common, so just leave it at this point. X is not common, X. Y is not common, so Y. And rest, this would be just C and D, because C and D is common. So I can say that this is nothing but unique characters and common subsequence. This would be the length, common subsequence. Now what is this unique characters? So this would be the length of the resultant. So I can say that the number, I can say the common subsequence, that is m plus n minus the length of longest common subsequence, that is LCS, would be my answer. Because all the characters minus common subsequence, okay, would give me this. How it is coming up? See, X, Y, C, D and A, B, C, D, okay, minus C, D, okay, minus C, D. So if you observe that, see, here C, D is counted 2 times, okay, but if we just subtract the common count, then this would be counted just once. Like this won't be counted twice. Now this would look something like X, Y, A, B and then C, D would remain. So this is it. This is what the result we are trying to find. Okay. So at this point, so M and N is given. This is just the length of both of them. And we need to find longest common subsequence. Because longer it is, minimum would be the length. So when we are having the sub problem to find length of the longest common subsequence, so just simply what you can do to learn at this point is just open up this longest common subsequence GeeksforGeeks practice. See up this if you are good with questions up, and else you can just search this on the YouTube itself and you would find a tutorial of mine or other mentors of Geeks4Geeks. So now I already assume that you know longest common subsequence, and this is the pre-implemented longest common subsequence. Now what I would do is I would just reset this whole array to -1, that is mmset t comma -1 comma size of t, and then everything is reset to -1, and then I would say return this by size of m plus n minus LCS of x comma y comma m comma n. This should be true enough. Now let us just see. Okay, this is, now let's do this. Yep. And yes, we were able to solve up this problem. This was just a wrapper or longest common subsequence. So that's it for today. Happy Diwali. Take care, everyone. Or it might be the scenario, belated Happy Diwali. All the best. Thank you.
Hello and welcome everyone. I am Jadal Sanya, and in this video we are going to study the question, check if strings are rotations of each other or not. Okay, so this question is pretty simple, but it requires creative thinking on how to solve this question, right? So we'll be first of all reading the problem statement, and then we'll be moving towards the approach of this question. Okay, so let's start. So in this question, you are given two strings of equal lengths, S1 and S2. The task is to check if S2 is the rotated version of the string S1 or not. Okay, and note the characters in the strings are in lowercase. Okay, so all the characters will be given to you in all the strings will be in lowercase. So first of all, let's take one of the example and let's have a look at the problem statement. So I've taken the same test case which is given to us in the question, and this is the original string and this is the rotated string. So basically you will be given two different strings. One is original and another one is rotated string. So let's say the original string is geeks and the rotated string is for geeks. So you have to find out whether this rotated is the rotated version of this original or not. Okay, so let's take this string original and let's copy it over here. Now what I'll be doing, I'll be trying to rotate it. So if I try to rotate it, let's say if I copy this two characters GE and paste it at the end of the string. So this is one of the rotation, right? So this is what I'll be getting as a rotated string. But I don't think this rotated string and the output string which we got are matching, right? So let's try out more rotations. So let's say if I take this entire EKS and paste it over here, I can see this rotation looks similar to the string which is given to us in the output. So both these strings for geeks and for geeks are completely equal, and I can say that this original string, if I rotate it, I'll be getting this string, right? And hence the output for this test case comes out to be true. So in the output, you will be printing 1. Fine. So now let's say to understand what if the output comes out to be 0 or let's say false. What are the test cases possible, right? So now let's say what I'll be doing. This is this original string ABCD and this is the rotated string. So let's say I have different rotations of this original string to get a clear understanding, right? So ABCD. Now what I'll be doing, I'll be rotating it. So just a single character. So the rotated string will be BCDA. Now one more try. So ABCD, and I'll be pasting this AB at the end. So CD and AB. So I'll be doing A, B, C, D. One more possibility, that is ABC. Put it at the end. So that would be D, A, B, and C. And the other possibility is taking the entire string ABCD. Okay, so I'll be taking the entire string, and if I take the entire string and rotate it, so that would be ABCD. Right. So these are 4 different possibilities. Right. Now, can you see this CBDA as any of the output? No, I cannot see. This is BCDA, this is CDAB, DABC, and this is ABCD. No, I cannot see. And hence it comes out to be that this rotation is not of this string because the output does not match. So the output for this comes out to be 0. That is false, that this is not the rotated string of this original string, right? So that is what the question is trying to ask you, that basically you'll be given 2 strings, find out whether the second string is the rotation of the original string or the first string or not. Okay, I hope you got the clear understanding of the question. Now let's try to understand how to solve this question. Okay, so the thinking is very much based upon trying out different test cases, trying out how to solve the test case, right? So what I'll be doing, I'll be taking the example of this ABCD, right? So as I mentioned over here, let's say, let me copy this entire thing. Yeah. So this is ABCD, right? This is the original string. And now let's say if I want to check for the rotation of it. Now let's say if I have one different rotation of this string and the rotation is CDAB. Okay. So now what I can do in order to find out whether this rotation of this original string or not, what I will be doing, I will be simply appending this ABCD string. This is the original string. What I'll be doing, I'll be simply taking one more original string. That is, I will take one more ABCD and append it over here. So basically, this is the concatenation of this original string twice. And now I will look for this rotation inside this concatenated string. So can I find this CDAB or not in this concatenated string? And let's call this string as temporary string. Okay, can you find this CDAB? You can compare them character by character. So this character does not match. So B, it does not match. C, it matches, right? So if any of the character matches, I will be finding out and comparing the rest of the characters. So after C, I can see D. D also matches over here. After D, I can see A. A also matches. And after A, B also matches. So I can see that this CDAB is also present over here. Hence, it comes out to be that the rotation CDAB, which was given over here, is of this original string, right? So simply just concatenate the original string twice and then just compare or find the rotated string over here. Okay, so that is what the question is trying to say. Okay, so that was the entire algorithm, and now let's quickly write down few of the steps of the algorithm. Okay, so let's start. So now over here, we don't need to worry about the length of this string, right? Because it has been mentioned in the question that S1 and S2, both of them are going to be of equal length. So you don't need to worry about the length of this string. So now what I'll be doing, first of all, I will be needing a temporary string, that is concatenation of both this string, right? So both this string means the original string, that is S1. So I have concatenated them and I got the temporary string. So now inside this temporary string, what I need to do, I need to find out the string S2. So the second step is to find whether S2 is a substring of temp or not. And now if yes, then you can simply print 1 in the output, and if the output comes out to be no, then you can print 0 in the output, right? So that is how simple this question is. And now let's try to write down the coding implementation for this same. So let's start. Okay, so here is the implementation for the algorithm which we already saw right now. And now over here, what I have done, I have written down the entire algorithm in Java, but the same can be implemented in other languages, right? So the first step is to find the temporary string, that is concatenation of string S1, that will be twice. So this is my temporary string, and now I need to check whether this S2 is present as a substring inside this temporary or not. So I can use an inbuilt method present over here in Java, that is contains. So this method checks whether the argument which you have passed is the substring of this original string or not. So basically it will check whether S2 is the substring present inside temporary string or not. If it is present, then contains method will return true, and this if condition will be executed. So you can simply return true over here. And if this not contain, this S2 is not present as a substring, then you can return false over here, right? So that is the entire logical implementation part. So let's try to submit this and let's see. So as we can see that the problem has been successfully submitted, right? So now let's analyze the time and space complexity of this approach. So the time and space complexity over here, this time complexity will be order of S1, because I can see S1 and S2, both of them are of same length. So you can consider it as 2S, that is the length of this string, or you can say it as 2N, right? But the space complexity overall comes out to be order of N, that is the length of the string S1. And what about the time complexity? So the time complexity is based upon this contains method. So this contains method works on length of this string, right? It works on the length of this string which you have passed as an argument. So the contains method is also going to take order of n time complexity. So that was it for in this video. I hope you really enjoyed the solution part, and if you really enjoyed the solution part, do hit the like button and share it with your friends. So I'll be meeting you in the next video. Thank you.
Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is better string. First of all, let us start by understanding the question. What does question say? Given a pair of strings of equal lengths, geek wants to find the better string. The better string is the string having more number of distinct subsequences. If both the strings have equal count of distinct subsequences, then return string 1. So basically what they are saying is that we are given two strings in the input, and whichever string has maximum number of distinct subsequences, we will return them. And if they are equal number of distinct subsequences in both of them, we will return string 1. Now what is a subsequence? A subsequence is a sequence or a string which you get by deleting some or none elements from the original string, right? So let's say you have A, B, C. So if you delete B, you get A, C. So that is a subsequence. Okay, it does not need to be in a continuous manner with respect to original string. Okay, you just delete some of the characters from the original string and whatever is left, but you do not change the order of that. That is called a subsequence. And distinct subsequence means if a same subsequence is repeating 2 times, then we will count them only once. Okay, so for example, if we have GFG and another is GG, so GFG have 7 distinct subsequences where GGG has 4 distinct subsequences, so GFG will be our answer. Then for the second example, here there is only one subsequence and here also there is one subsequence, so we need to return string 1. You don't need to read input or print anything. Your task is to complete the function better string, which takes string 1 and string 2 as input parameters and returns the better string. The expected time complexity is max of string 1 length into string 2 length, and expected auxiliary space is also max of string 1 length dot string 2 length. Okay, and the constraints are given here. So now if we think about solving this problem, so first of all let us look at the example which was given in the question. So it is GFG and S2 is GGG, right? So if we count the different subsequences for the first string, then it would be G alone, then F alone, then third G alone, then GF, then GG, then FG, and then GFG, right? Now in this case, if you look carefully, and one more is okay, so these are the things which we get. Now here G is common, right? So these are not distinct, so we will remove them. Okay, so there is only one G. Now all of them are distinct, so total is 1 2 3 4 5 6. Okay, you can also consider empty subsequence as a subsequence. Why? Because let's say you deleted all the characters, then that empty string is also a subsequence. Okay, so these are the 7 possibilities. Here one is empty, one is G alone. Let's take all the possible cases. So this G alone, this G alone, this G alone. So G, 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 then first 2G, second 2G. So GG, GG, and all 3 Gs, right? Now this is repeating with this, so we will take only once, and these are also repeating, so we will take only once. So 1 2 3 and 4. So here we have 7 distinct subsequences, and here we have 4 distinct subsequences. So this is our answer. So that is basically what they are asking. So whenever your characters will be repeated in your string, you will get some subsequences which will be repeated. Okay, so you need to take care of that. Now so what can be the solution? See, one brute force solution to is what? To generate all possible subsequences using recursion. So if the length of the string is n, total number of subsequences will be 2 to power n. So you generate all different subsequences, add it to a set. So set will contain only unique strings, and then return the size of the stack, right? Because return the size of the set, okay, not stack. So why? Because a set contains only unique elements. Even if you add the same element again, it will count only once, right? So you can do that, okay? Or you can use hash map to see whether a subsequence is coming again or not, and so on. So you can, using recursion, generate all 2 to power n strings, but this will take big O of 2 to power n time, okay? And it will give us time limit exceeded, and this is not also our expected time complexity. So now we need to think of something more efficient, right? So what can we do here? So can we basically see at every point of time we are telling either to take a particular element or not to take a particular element, right? Because basically let's say here I have FG. So what I have done, I have taken this element, I have taken this element, and I have not taken the first element, right? So basically in recursion also what we will do, let's say I start with index 0 and my string is empty. Okay, now I say let's say I take the example of, let's say GGF. Okay, let's say I take this example. So for the 0th index, and the current subsequence till now is this. Now for 0th index I have 2 choices, whether to pick that element or not to pick that element. If I do not pick that element, the next choice will be for first index element, and my string subsequence will remain empty only. If I pick that, the next choice will be at first index and my string will be G, right? Now again at first index I will have 2 choices. If I do not pick that element, the next choice will be at second index and my string will remain empty only. If I pick that element, next choice will be at second index and my string will become G. Here also, if I do not choose, the next choice will be at second index and it will remain G only. If I choose the element at the first index, the next choice will be at second index and my subsequence till now will become GG, right? Because at every step I have 2 choices, either to pick that element or not to pick that element. So in this way we will generate all the and whenever we will now see, from here I will go to 3, but 3 I know that there is no index 3 because the length of this is 3. So whenever this index is greater than equal to n, we will add that subsequence generated till now to our answer. Okay. So for example, here I decide not to take the element at second index. So subsequence will remain this only, and here I decided to take it. So my subsequence will become GF. Okay. So now I know that there is no index 3 because 3 is equal to the length of the string. So this is the subsequence generated on this path. Okay, take the element, not take the element, not take the element, take the element, not take the element, take the element. So whenever I get here 3, I will add this to my set. Okay, and in this way I can solve using recursion. But I want to do it more efficiently. So can we think of dynamic programming? We can think of dynamic programming when we get overlapping sub problems, which means smaller sub problems are repeated again and again. So if we see here, see, these are the same small sub problems, right? The subsequence generated till now is G. Here also the subsequence generated till now is G, and here the current index which I am considering is 2. Here also it is 2. So the next whatever I will generate further will be same in both of them. So we are getting overlapping sub problems. So we need to think of dynamic programming. Now in dynamic programming, what we can do is see what will be the state of the dynamic programming. I mean the table form. If I think of tabulation approach, that is try to fill it from bottom to up, then what will be my table? See here, this is a string. This is the string in the recursion which I am generating. I do not want a string. I just want the count of distinct subsequences, right? So basically, I will count the distinct subsequences for this. I will count the distinct subsequences for this, and whichever will be more distinct subsequences, I will return them. So now here the strings I do not want. So from recursion point of view, if I think I will need a DP table of size n plus 1, where DP of I will be the count of distinct subsequences up till index I. Count of distinct subsequences up till index I. Okay, so all the possible distinct subsequences up till index I. Now how we will calculate it and how we will remove the repeated subsequences, now let's have a look at it with the help of an example. So as we talked that we will take a table of dp n plus 1, where dp of n is the length of the string and dp of I will tell us the count of the distinct subsequences up till index I. So for a particular string, dp of n will tell the count of distinct subsequences up till length n, that is the complete length. Okay, now see what happens whenever we get a new character. The number of subsequences get doubled, but yes, there can be repetitions which we need to remove. So how the subsequences get doubled? Let's say I have a string ABC. Okay, so first of all, the first choice is empty subsequence, right? Now I have to decide on A whether to take it or not take it. If I do not take it, it will remain empty only. If I take it, it will become A. So at present I have these two distinct subsequences. Now for B, either I will take it or not take it. If I do not take it, this empty will remain empty, A will remain A. If I take it and combine it with empty, it will become AB, and if I take B and combine it with A, it will become AB. Are you getting my point? So up till index 0, I had two subsequences, one is empty and one is A. Now for B, I have two choices, either to take it or not to take it. If I do not take it, these two subsequences which I generated till this index will remain as it is. And if I take it, I can attach or concatenate it to this subsequence as well as this subsequence. If I concatenate it here, I will get B. If I concatenate here, I will get AB. So I have these four subsequences till now. Now for C, if I do not take it, this empty will remain empty, A will remain A, B will remain B, and AB will remain AB. If I decide to take C, and if I can concatenate with all these four subsequences, right? I can concatenate it with this, I can concatenate it with this, and this, and this. If I concatenate it with this, it will become C, with this it will become AC, with this it will become BC, and with this it will become ABC. So here I had one subsequence, then it became 2, then in both these subsequences I either kept them as it is or I added B, so it became 4, and in all these four subsequences I either kept them as it is or I added C, so it became 8. So whenever I get a new character, let's say till index I minus 1, I had 10 subsequences. Now at index I either so now I want the number of distinct subsequences which up till index I. So either I do not add index I to any of the subsequences, so the 10 which I got till I minus 1 will remain as it is, If I decide to take it, then and I can attach it to all the 10 subsequences which I got till index I minus 1. So it will become 20. So in this way it gets doubled, but whenever there is repetition, we need to take care of that. So now let's have a look at example of repetition, and then we will see what can be the formula. So now let's take one more example. Let us say we have string A, B, C, 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 and we want to count the number of distinct subsequences for this. Let's say A, this is B, this is C, C, and C. Okay. Before A, I will have an empty subsequence. Okay. Now up till index A, up till index 0, so this is index 0, this is index 1, this is 2, this is 3, and this is 4. Here I will be noting down all the subsequences which can occur up till index 1. Here I will note down all the subsequences which can occur up till index 2, up till index 1, here will up till index 0, here up till index 2, here 3, and here 4. Okay, and we will count only distinct subsequences. Since there are repeated characters, there will be repetition, but we will observe how that repetition can be removed. In general, what we observed, dp of I is nothing but 2 times dp of I minus 1. That is what we observed. Whenever we consider the ith character, these are the subsequences which I generated till I minus 1. So for every subsequence, I can either keep it as it is or attach the value at the index I. So it gets doubled. Okay, but how to remove repetition, we will look here. So when I will come at index A, I'll either not add A, so empty will remain empty, or I'll add A to empty, so it will become A. Now when I'll come here, either I can keep this and this as it is, or I can attach B to them. So if I attach B to empty, it will become B, and B to A, it will become AB. Here I can keep as it is, or I can attach C to empty, it will become C, C to A, it will become AC, C to B, it will become BC, C to AB, it will become ABC. Okay. Now here I can either keep them as it is, so A, B, AB, C, AC, BC, ABC. So I decided not to take this element. Or if I decide to take this element, I can attach it at the end of this, I can concatenate it with this. Okay, so let me draw a line like this, so it will become C, or I can concatenate with A, so it will become AC, or I can concatenate it with B, so it will become BC, or I can concatenate it with AB, so it becomes ABC, then CC, C and AC is ACC, C and BC is BCC, C and ABC is ABCC. Okay, now what are the repetitions here? C and C is repeated, AC and AC is repeated, BC and BC is repeated, and ABC and ABC is repeated. Why it is repeating? Because I added C to these 4 characters, these are repeated, right? Now, why are they repeated? When were they first generated? They were first generated when I attached this C with these. Okay, please let's understand this carefully. What are the repetitions? CC, AC, AC, BC, BC, ABC, ABC. Okay, how am I getting this? These are the 4 subsequences which I got, not considering this C, I got this 8 subsequences. This C, AC, BC and ABC were generated when I attached this C with empty, with A, with B and with AB. So these 4 became here C, AC, BC and ABC, but these 4 were also there where I did not consider this C. Now when I am attaching this C to these 4, it is same as attaching this C to these 4. That's why I am getting C, AC, BC and ABC repeated. So these are not distinct subsequences. So how many distinct subsequence, how many repeated subsequence will get generated into dp of I? If the character at the current index is coming again, listen this carefully, if the character at the current index is coming again, then the number of distinct subsequences count up till which index? Up till index 1 before the when that character came before. Okay, so see, when I attach this C, what are the number of different subsequences generated? So let's say that is index which, this is 0, this is 1, this is 2, this is 3 and this is 4. So dp of 2 is how much? 8. There are 8 distinct subsequences up till index 2 which I can generate if I consider the string up till index 2. dp of 3 should be 2 into dp of 2, that is equal to 16, but there are repetition. What is the repetition? First of all, I need to find when did C occurred last. C occurred last at index 2. So the number of subsequences which will be repeated will be equal to the count of distinct subsequences of the index 1 before where C occurred last. C occurred last at 2, 1 before that index is this. This has 4 distinct subsequences, so 4 will be repeated, which we saw here. Okay, so I need to subtract 4, so this will become 12. Now again there is a C, so dp of 4 will be equal to 2 times dp of 3 minus number of distinct subsequences in one index before where C occurred last. So currently I am looking for this index. C occurred last where? At this index, because for this is the last index where C occurred, right? And one index before this has 8 subsequences, so I need to subtract 8 here. These many repetitions will be there. So 2 into dp3 is 12, so 24 minus 8 is 16. Let us have a look here. So for all these subsequences, I can either paste them as it is, not considering this C, because I have two choices, either to consider it or not to consider it. So B, AB, C, AC, BC, ABC, these 4 are repeated. So CC, ACC, then BCC and ABCC. Okay. Now these I took as it is, not considering this C, but I can also consider it. So let us consider it. Attach C to empty, it will become C. Attach it to A, it becomes AC. Attach it to AB, it becomes ABC. Then attach it to C, it becomes CC. Attach it to AC, it becomes ACC. Then attach it to BC, it becomes BCC. Attach it to ABC, it becomes ABCC. Attach it to CC, it becomes CCC. Then ACCC, then BCCC and ABCCC, right? Now what I told, there will be 8 repetitions. Why? Because C occurred last year, so the number of elements before that were 8, right? The number of distinct subsequences up till this index is 8. So if I add this C to these 8 subsequences, it would be C, AC, BC, ABC, CC, ACC, BCC, ABCC. Similarly, now these 8 subsequences were here also, empty, A, B, A, B, C, A, C. So if I add this C to this, it will give me C, AC, BC, ABC, CC, ACC, BCC, ABCC. So these 8 will be repeated. C is here, C is here, AC, AC, BC. What we did mistake here? So we have C, then AC, then there should be also BC. Okay, repeated. Here I wrote this became C, then AC, then BC. Okay, here BC is also there, which will be repeated. Then ABC is repeated. Then CC is repeated, ACC is repeated, BCC is repeated, and ABCC is repeated. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 repetitions. Okay. So finally what I got 16 as my answer, and this is my answer. So what we will do is, basically we will say dp of 0 as 1, because if there are no characters, empty subsequence is also in subsequence. Then for all the indexes from I to n, we will say dp of I is equals to 2 times dp of I minus 1 minus repetitions. And how will we get repetitions? Whatever is the character at ith index, we will check its previous occurrence. Suppose its previous occurrence is at index j, then my repetitions would be dp of j minus 1, right? And this will give us the answer. Finally, we will compare dpn of first string and second string. This will give, first will give the distinct subsequences in first string, and we also have for second string, and whichever count is low, we will return that as our answer. Now let's look at its actual implementation. So if we look at the actual implementations, I have taken n as the size of first string and m as the size of second string. Then I have taken two dp table, dp1 of n plus 1 and dp2 of n plus 1. Here it should be m plus 1, but I think in the question they have also said that the string lengths are equal, so no need to worry about that. Then I have taken two last one and last two. What will this denote? So for this, see here the 0 index will denote what? So here what I have done is last one of 0. 0 means A. 0 index I am corresponding to A, 1 index I am corresponding to B, 2 index I am corresponding to C, and 25th index I am corresponding to Z. Last one of 0 means if I am at current index and current index has character A, so last one of 0 will tell us the index of last occurrence of A. Last one of 10 will tell me the last occurrence of K in the current string. Okay, so because for repetitions we need the last occurrence of that index, so for that I have used last one and last two. This will be for first string, this will be for second string. I have initialized all of them as -1, so -1 will denote that that character has not occurred before. Okay, then dp1 of 0 equals to dp2 of 0. dp1 is for number of distinct subsequences of first string and this is for second string. Then for I equals to 1 to n, first of all I'll say dp1 of I equals to 2 times dp1 of I minus 1. I'll double the number of distinct subsequences with respect to index I minus 1. Now if the index at if the character at index I minus 1 is repeated, then we will remove the repetitions. Now please don't get confused. Here I am counting dp table with respect to 1 based indexing. Okay, so dp1 of 5 will tell me the distinct subsequences considering the first 5 characters, right? Why I have done that? Because I have called dp1 of 0 as 1, that is the empty subsequence is also a subsequence. Okay, so this is 1 based index dp table, but my string is 0 based index. So if I am talking about the ith character, that will be at index I minus 1. Okay, so that's why here it is I minus 1. If last one of string of I minus 1 minus 97, minus 97 is to convert the ASCII value from 0 to 25. So if this character is not minus 1, it means this has occurred before, then dp1 equals to dp1 of I minus dp1 of last of this last string 1 of I minus 1 minus 97 will give me the last occurred index of that character. Okay, let's say it returns j, then we need to remove the elements up till j minus 1. So here I have also done -1. Okay, so this will remove the repetitions, and last one of the character which is at current index I minus 1 gets updated to I. Okay, so last one of string of I minus 1 minus 97 gets updated to I because this is at current index. So for further indexes, this current position is the last occurring position, right? Similarly, I have done for string 2. So for I equals to 1 to m, first of all multiply it by 2, then if there is repetition, remove it and then update the last position. If dp1 of n, what does dp1 of n say? Number of distinct subsequences of first string considering the first n characters. Now what does considering first n character means? Considering the whole string is greater than equal to dp2 of m. So the count of distinct subsequences of first string is greater than equal to count of distinct subsequences of second string or equal, then return string 1, else you will return string 2. Okay, what will be the time complexity? Time complexity would be big O of max of n and m, but if both of them are equal, you can take any one of them, right? Because we are running 2 for loops of those size. And what would be the auxiliary space? The auxiliary space will also be equal to big O of max of n comma m, right? Because we are using this dp table which are of size n and m respectively. I hope you understood this. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you understood the solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is find the string. First of all, let us start by understanding the question. What does question say? Given two integers n and k, the task is to find the string s of minimum length such that it contains all possible substrings of size n as a substring. Okay. The characters of the string should be from integers ranging from 0 to k minus 1. So what this basically saying is, we are given two integers n and k and we need to form a string s of minimum length possible such that in that string s, all the substrings of size k, which of size n, which contains the characters from 0 to k minus 1, all the strings of size n which contains characters from 0 to k minus 1 are present as substrings in S, okay, and S should be as minimum length as possible. So for example, if my n is 2 and k is 2, so digits can be from 0 to 1, because k is 2, we can use the digits from 0 to k minus 1, and the length is 2. So what can be the different strings? 0 0 0 1 1 0 1 1. Now if I look at this string, here I have 0 as 0 0 as a substring, I have 0 1 as a substring, I have 1 0 as a substring, and I also have 1 1 as a substring, and this is of minimum length possible. So these are the 4 substrings of length n which are formed using the characters from 0 to k minus 1, right? And all of them are present in this as a substrings, and this is of minimum length possible. So this is our answer. Okay, if you look at n equals to 2 and k equals to 3, you will get this. Okay, you don't need to read input or print anything. Complete the function find_string, which takes the integer n and the integer k as input parameters and returns the string. In case of multiple answers, return any string of minimum length which satisfies above condition. The driver will print the length of the string. In case of wrong answer, it will print -1. So basically we will complete this function and return any of the minimum length string which satisfy the condition. There can be multiple minimum length strings, and if we have returned a correct string, the driver code will return the length of that string, otherwise it will print -1. Okay, the expected time complexity is k ki power n log k, and the expected space complexity is k ki power n, and the constraints are given here. So now if we think about solving this problem, then first of all, let us have a look at simple example again. Let's say n equals to 2 and k equals to 2. So we need to form a string S of minimum length possible, such that all the strings of length n which contains characters from 0 to k minus 1 are present as substrings in this string S. Okay, that is what they are asking. Okay. Now, what are the different n length substrings which contains the characters from 0 to k minus 1? So k is 2. So the characters which I can use is 0 and 1. N is 2. So the n length strings are 0 1 0 0 0 1 1 0 1 1. Now understand one thing. See, one thing what I can do is, let's say I took 0 0, I took 1 0, I took 1 1, and then I took 0 1. Now this also contains all of them as substring. 0 0 0 1 is contained 2 times, then 1 0 is present here, it is also present here, and 1 1 is also present here. But what is the length of this? The length of this is 8, and we need it in minimum length. So what I can do is, I need to form a string in which these substrings are overlapping. Are you getting my point? For example, this is 0 0. Okay, now I want another 2 length string, so I will add a character here such that it will be overlapped with this character. So I can add 1. As soon as I add 1, this is my 0 0 and this is my 0 1. Are you getting my point? Now let me add another 0, so that after this one, if I add 0, I will get 1 0 also. Now I do not have 1, this is remaining, so I will add 1 1 here. Okay, so between this string, that is 0 0 and 0 1, this 0 is overlapped here. Okay, between 0 1 and 1 0, this 1 is overlapped here, right? And 1 1 is separate. The number of characters here are 6, here the number of characters were 8. Why it got reduced by 2? Because 2 characters were overlapped. Now we want this to be maximum overlapping. Now when can it be maximum overlapping? When every time I use the last n-1 characters of the previous substring and add such a character that a new substring is formed. So for example, if I take 0 0, now I will use one character and I will add another character such that they will form a new substring. So let me take 0 1. So 0 1 is also occurred, 0 0 has already occurred. Now what I will do is, I will take 1 1. So I will do 1 1. So this 1 is overlapping and 1 1 has also occurred. Now I can add 0. So as soon as I add 0, this 1 0 will occur and I will get 1 0 also. So there is 0 0, then 0 1, then 1 1, and then 1 0. So all the characters are present and this is of length 5. Now tell me, is this the minimum length possible? Yes. Why? Because the overlapping is as maximum as possible. So what is the meaning of maximum overlapping? What I am trying to say is, the first string, okay, let's say this is my string S, okay, the first string of length n is one substring. Okay, the first string of length n is one substring. Now I will add such a character here that this string of length n, if I remove one character here and if I add another character here, this will form another substring which has not occurred before. This will form another string which is out of all the possible strings, and it has not occurred before as a substring. So substrings do not get repeated. Here see 0 1 0 1, these were getting repeated, right? We do not want the repetition. Similarly, I will add such a character here that this string of length n will be a new string. I will add such a character here such that this string of length n will be a new string. So basically between two consecutive substrings, n minus 1 characters will be overlapping. Okay, so let's say I have 1 2 3 4 and I want 2 3 4 5, so I will add 5 here. Okay, so the string length is 4, so this is 1 2 3 4 and this is 2 3 4 5. The number of overlapping characters are n minus 1, n is 4. Okay, let's suppose. So this is the maximum overlapping. You cannot overlap the complete string, then you will not get a new substring. Are you getting my point? You cannot overlap 1 2 3 4 with 2 3 4 5. That's not possible. But you can overlap 2 3 4 and add a new character such that after adding that new character, if you look at the last n characters, it will be a new substring. Similarly, I'll add a new character here such that the last n characters will be a new substring. I will add a new character here such that the last n characters will be a new substring. So in this way we will get minimum length because there will be maximum overlapping. Now what will be the length of that? See, I need to find strings of length n size as the substrings inside this string s. Okay, so the length is n. At every position I have k possible characters. If k is 3, at every position I have 0 1 or 2 to place, and there are n positions. I want to find all strings of length n containing characters from 0 to k minus 1 as the substrings in this. So total number of strings will be how much? K ki power n, because n positions, each position have k possibility. Now what will be the length of the minimum size string? There are total k ki power n different substrings which should be present inside this string s of minimum length. So what will be the minimum length? The minimum length will be the first string. I am considering all the n characters. Okay, so the first string will contain n characters. All the other strings out of these strings will be present as substrings in this by adding only one single character. Okay, by adding only one single character. As soon as I add one new single character, I will get a new substring of length n which will be a different substring, and so on. I will keep on going until all the substrings are covered. So for one string I will consider n length, and for all the other strings they will be formed, all the other strings of this will occur in this by adding only one new character, because I want maximum overlapping. I will do it in that way. So the remaining strings will be new strings. Remaining strings will be fulfilled after adding one character, because n minus 1 characters will be repeated from the previous substring, right? And there are such k ki power n minus 1 strings, because one string I have considered of length n, the first string, and the remaining character strings will be formed by adding one each character. So the minimum length possible can be n k ki power n minus 1 by maximum overlapping. Now look here. Here n was how much? 2. K was how much? 2. What is the minimum length possible? N plus 2 ki power 2 minus 1. 2 minus 1 is 1. 1 plus 2 ki power 2 is 4. That is 5. So this is the minimum length possible. Okay. So this is the concept. Now let's have a look at a slightly bigger example so that everything becomes very clear. So let us take n equals to 3 and k equals to 3. So my characters can be 0, 1 or 2, and I want a string or s of minimum length possible such that all strings of length 3 using the characters 0, 1 and 2 are present as substring inside that string. Okay. So as soon as I will form new substrings, I will mention them. I will mention the substring starting with 0 here. I will mention the substring starting with 1 here, and I will mention the substring starting with 2 here so that they do not get repeated. So what I will do is, first of all, in my answer, I will add 0, 0, 0. Okay, because that is one possible string. Now I will add the biggest character possible. Okay, so here 0 0 0 is taken. Now I will add the biggest character possible. So first I will try to add 2, then I will try to add 1, and then I will try to add 0. So when I will try to add 2, I want a new substring to be generated. N is 3, so n minus 1 characters will be used from here, and a new character should be added such that this new string of length n ending with this index should be a new substring which is not present here. Okay, because if there is maximum overlapping and no substrings are repeated, then only we will get minimum length. So 002 has not occurred before, so I will add 2. So here I will get 002 also. Now after 2 I will try to add the maximum, so I will try to add 2. If I add 2, I will get 022. Has it occurred before? No. So this is also valid. Now I will again try to add 2. So 222 has occurred? No. So this is also valid. So I will get 222 as a substring. Now I cannot add 2, because if I add 2, I will get 222, and 222 has already occurred, right? So I want a different substring. So I will go for 1. First I will check for 2, then I will check for 1, and then I will check for 0. If I add 1, 221 will be formed. It has not occurred before, that's okay. So 221 has occurred. Now again I will try to add 2. Every place I will try to add the maximum character. So if I add 2, I will get 212. That has not occurred before, so that is also okay. Now I will again try to add 2. So I will get 122. That is also not occurred, so that is also okay. Are you getting my point? This is 122 of length 3. This is a substring. Okay. Now I will try to add 2, but I cannot add 2 because 222 has already occurred. I cannot add 1 because 221 has also occurred. I'll try to add 0, that is 220. It has not occurred before as substring, so that will work. So 220. Again I will try to add 2. I will get 202. Has it occurred? No. So I will add 2 and I will get 202. Again I will try to add 2. So 022. 022 has occurred, so I will not add 2. I will try to add 1. So 021. 021 has not occurred, so I will add 1. So 021. Now I will try to add 2. So I will get 212, but it has already occurred. I will try to add 1. So 211. It has not occurred, right? So I will add 1. I will get 211. Now I will try to add 2. It will give me 112. 112 has not occurred, so that is okay. Now I will again try to add 2. So I will get 122, but that has occurred. I will try to add 1. So I will get 121. That has not occurred. So 121 and I will get 1 here. Okay. Now I will try to add 2. So I will get 212, but 212 has already occurred. I will try to add 1. So I will get 211. 211 has already occurred. I will try to add 0. So 210. 210 has not occurred. So this 210. So 210. Okay. Let me write it from here. Okay. I am repeating these two characters here. Okay, because I want 3 length substring. So now I will get I will try to add 2. So it will be 102. 102 has not occurred, so it is okay. Okay, and let me mark this with a different marker that these two are repeated. Okay, so that while counting the length at the end we do not get confused. Now I will try to add 2. So I will get 022 as 3 length substring, but 022 has already occurred. I will try to add 1. So 021. 021 has also occurred. I will try to add 0. So 020. 020 has not occurred. So it will be 020. Again I will try to add 2. So 202. 202 has occurred. 201. 201. 201 has not occurred. I will add 1 here and I will get 201. Then I will add 2. So I will get 012. 012 has not occurred. So 012. Now I will add 2. So it will give me 122 that has occurred. I will try to add 1. 121 that has occurred. I will try to add 0. 120 that has not occurred. So 120. Now I will try to add 2. So 202 that has occurred. I will try to add 1. So 201. 201 has occurred. I will try to add 0. So 200 that has not occurred. So 200. Okay, this substring of length 3. Now I will try to add 2. So it will be 002. 002 has occurred. I will try to add 1. So I will get 001. That has not occurred. Okay, so it is 001. Now I will try to add 2. So I will get 012. 012 has occurred. I will try to add 1. So I will get 011. 011 has not occurred. So I will get 011. Now I will try to add 2. So 112. 1 1 2 has occurred, I will try to add 1, so I will get 1 1 1, that has not occurred, so I will add 1. Now I will again try to add 2, so at every step we try to add 2, then 1, then 0. So 1 1 2 I will get, that is already present. 1 1 1 is also present. I will try to add 0, I will get 1 1 0, which is not present. Then I will try to add 2, so I will get 1 0 2, 1 0 2 is present. Then I will add 1, so 1 0 1, 1 0 1 is not present, so I can add 1. Then I will try to add 2, so I will get 0 1 2, 0 1 2 is present. I will try to add 1, 0 1 1, that is also present. I will try to add 0, I will get 0 1 0, that is not present, 0 1 0. So I will get 0 here and 0 1 0 I will get. Now I will try to add 2, so I will get 1 0 2, 1 0 2 is present. If I add 1, 1 0 1 is also present. If I add 0, I will get 1 0 0, which is not present. Okay, so I will get 1 0 0. Okay, now if I try to add 2, so I will get 0 0 2, which is present. If I try to add 1, then 0 0 1, 0 0 1 is 0 0 1 is also present, and if I add 0, then 0 0 0, that is also present. So now we cannot do anything further. So these many substrings are present here. Now tell me, what will be the number of substrings of length 3 starting with 0, where you can use characters 0 1 and 2. So this place is fixed. Here you can use 3 characters, and here also you have 3 choices, so total will be 9. Similarly, substring starting with 1 of length 3 will be 9, and strings starting with 2 of length 3 will also be 9 if you have 3 characters. So here, so all these substrings are present in this, so this should be 9. Okay, 1 2 3 4 5 6 7 8 9. So all the substrings starting with 0 are present. 1 2 3 4 5 6 7 8 9, these are also present. 1 2 3 4 5 6 7 8 9, these are also present. So all the substrings are present. Now at every step we added only a new character, and n-1 characters were taken from the previous string. So this is maximum overlapping, so this will give us minimum length. What was minimum length? N plus k ki power n minus 1. N is 3, k ki power n is 27, minus 1, this is 30, minus 1, this is 29. Let us count the length. Let us count the length with another string. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 and 29. The length of this string is 29, which is the minimum possible. Now let's look at its implementation. So if we look at the implementation, so this is the find string function in which n and k are given. So the total number of strings possible will be k into n, which I used for some other purpose while implementing, but that was not used further. Okay, then I have some variables I and j. This is the string answer, which will contain my answer, and I have taken one temporary string. I have used an unordered map, which will map string to integers. So whenever a substring of length n of k different characters is present inside the answer, I will map it. Okay, so for example, here how we were marking the strings, so this map will be used further to add a new character. Okay, so at a given point of time, whether we are adding 2 and we are getting 0 to 2, so I will check whether 0 to 2 is present or not. If not present, add 2, otherwise go for adding 1. Okay, so that's why I have used map. Then first of all, the first string of length n, which will contain all the zeros, I have added it to my answer, and I have also stored it in temporary variable, and I have marked map of temporary string, that is all zeros of length n, as 1, that this is present in my answer. Then I will call a DFS on temporary string. I will pass answer string, I will pass map, and I will pass k. Now let's look at this DFS function. So in this, what I am basically doing is I am taking one, and finally I will return my answer. Okay, now let's have a look at this DFS function. So in DFS function, I get this string which I passed as temporary here. I am telling it current string. Okay, and this is my answer string, this is my unordered map, and this is my k. I will take one temporary string and I will take one integer I. Now I want n-1 characters to be overlapped, right? And after n-1 characters, I can either add k-1 or k-2 or 0 up to 0. So I will start looking from k-1 and go up till 0. First of all, this is the current string. This is the last substring of length n. Okay, in the main function it was all zeros, okay, of length n. It will keep on changing. So this is the current substring, and from that I have taken n minus 1 characters. How? I have called this substring function and I have passed in the starting index. So I have passed in the starting index and not mentioned the length or the ending index. So from index number 1 it will take all the characters. So it will not take the 0th character. Okay. This is the last substring of length n in the string our answer. Okay. Please remember that. So from that the last n minus 1 characters are taken in temporary string. Now in temporary string I will add the ith character starting from k minus 1. If that temporary string formed of length n is not present in the map, then I will mark it as true that now it is present. I will add I to my answer because a new substring of length n I am getting, and I will call a DFS further in which the new substring of length n which has last occurred in my answer will now be temporary. Remember, it was current. In that we took the last n minus 1 characters and added I to it, and then this will now become the new temporary string, new current string for the next iteration. So I have passed temporary string here, then I have passed answer, then map, and then k. Now why I have breaked from here? Because see, at this position, after this position I added 0 here, right? So this I will call the function recursively. This will keep on adding. Now when I will backtrack, I do not want to add 1 here again. That was 0. I will, in every function call I am adding only 1 character, right? And I will stop when it is not possible. So basically after adding 1 character which through which I can get a new substring of length n which was not present inside the map, I will break it. After every step, during backtracking I do not want to add more characters. In every function call only 1 character will be added, and finally I will return the answer string. Okay, what would be the time complexity? Time complexity would be big O of k की power n, right? Because we are adding how many characters inside the string? Inside the string we are adding n plus k की power n minus 1 characters. Okay, we added n characters using for loop, and we added this many characters using function call. Okay, so the time complexity of this is k की power n. And what will be the auxiliary space? The auxiliary space will be, the answer string will contain this many spaces, and the answer string will contain this many spaces, and the map in which we are storing strings. Okay, so we are storing k की power n strings, each of length n in the map. So the auxiliary space will be k की power n into n. So this will be the time complexity, and this will be the auxiliary space. And of course some auxiliary space will be used by the call stack of the recursion function also, but this will give the upper bound. Now let's submit this code. Let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is binary tree to CDLL. First of all, let us start by understanding the question. What does question say? Given a binary tree of n edges, the task is to convert this to a circularly doubly linked list. Okay, so we know the doubly linked list means each node will point to the next node and to the previous node, and it is also circular in nature. Okay, so the last node will also point to the first node, and first node will point to the last node. The left and right pointers in the nodes to be used as previous and next pointers respectively in circularly doubly linked list. So we are given a binary tree. Right, now in binary tree each node will have 2 pointers, one is to the left child and one is to the right child. So we can use these 2 pointers as the previous pointers and the next pointers of circularly doubly linked list. Okay, so we can convert that structure of binary tree itself into a circularly doubly linked list. Okay, the order of nodes in circularly doubly linked list must be same as in order of the given binary tree. Okay, so what should be the order of the nodes of the binary tree in the doubly linked list? It should be the in order traversal of binary tree. The first node of the in order traversal, leftmost node in binary tree, must be the head node of the circular doubly linked list. Okay, so if we look at this example, so what will be the in order traversal? What is in order traversal of binary tree? Left subtree, then current root, then right subtree. Okay, so this will be the first, this will be the second, and this will be the third. So this would be from head to tail, and this would be from tail to head. Okay, 2 1 3. Okay, So this would be the doubly linked list 3, 1, 2 in that form, and 2 will also be connected to 3 because it is circularly doubly. Okay, and here see, first 40 will come, then 20 will come, then 60, then 10, and then 30. That is the in order traversal of binary tree. So our doubly linked list will be 40, 20, 60, 10, and 30. 40 will be connected to 20 and 30. 20 will be connected, 20's next pointer will be connected to 60, and previous pointer will be connected to 40, and so on. Okay, you don't have to take input or print anything. Complete the function btree to c list that takes root as a parameter and returns the head of the linked list. Okay, the driver code prints the linked list twice, first in the right order and another time in the reverse order. We do not have to take care about that. We just need to convert the binary tree into the circular doubly linked list, and it will return it in this order. Okay, it will print the driver code, and the constraints are given here. The expected time complexity is big O of n, and expected auxiliary space is big O of h, where h is the height of the tree. So now if we think about solving this problem, then first of all let us say that this is the given binary tree and we want to convert it into a circular doubly linked list. Now here what they have said is, we can see what will be the structure of this binary tree. Each node will have a data point or a value. Each node will have a data or value. Each will have a left pointer to the left child, and each will have a right pointer to the right child. So we will keep the data or value as it is. Left pointer can be used as a previous pointer in a doubly linked list, and right pointer can be used as a next pointer in a doubly linked list. Okay, we want to convert this into circular doubly linked list. Okay, and the order in this circular doubly linked list would be the in order of this binary tree. Now to understand here, see what is the in order traversal of binary tree. In order traversal is traversing the left subtree first, then the current root, and then the right subtree. Okay, now theoretically, if whenever you want to find the in order traversal of a particular binary tree, what is the easiest way? You mark on the bottom of the all the nodes, and you start from here and you mark a path in this way. Okay, through the circumference of this tree, and you go from here to here, and whenever you encounter this sign, you take that node in the in order. Okay, so what will be the in order of this? So here I started traversing from here. When I came, I encountered this mark. Okay, so 40 will be the first one. Then when I went up, I encountered this mark, so 20. Then I will come here, I will encounter this mark, so 50. Then I will encounter this mark, so 10. So 50, 10. Then I will encounter this mark, so 30, and then I will encounter this mark, so 60. So the in order traversal is this. So what should be the output? In the output I should get, this is 40, this is 20, this is 50, this is 10, this is 30, this is 60. Okay, and it is a doubly linked list, so there will be a previous pointer also. So the previous pointers will be in this way, and it is circularly doubly linked list. Okay, so it is circular in nature. So the previous pointer of the first node will point to this, and the next pointer of this node will point to this. Okay, so this should be my output, and here we can use the left and right pointer of the binary tree for the next with respect to next and previous pointers of the nodes to convert it into a circularly doubly linked list. So what I can do here is, see, one way is to store the in order traversal of this binary tree in a, let's say, vector or array, then make a complete circularly doubly linked list. But for that we need to make new nodes, and here it is said that you do not need to make new nodes. Use the left and right pointers of the binary tree nodes as the previous and next pointers of the circularly linked list respectively. Okay, so what I can do is, I can traverse this tree in order. Okay, so left subtree, then the current root, and then the right subtree. At every point of time, I will keep two pointers. One is the previous pointer and one is the current pointer. Okay, at every point of time, I will keep two pointers, previous and current. Previous pointer will be pointing to the previous node in the in order traversal, and the current pointer will be pointing to the current node in the in order traversal. For example, let's say I am at 50, so my current pointer will be here and my previous pointer will be at 20. When I will go at 10, my current pointer will be here and my previous pointer will come here. Okay, so at every step of time, I will have two pointers, previous and current, and at every step I will say current left is equals to previous, and previous right is equals to current. Now why am I doing so? Because the left and right pointer in circularly doubly linked list will work as next pointer and previous pointer respectively. So for example, here 20 has this left pointer and right pointer. That left pointer in 20, this is the left pointer of 20, it will work as the previous pointer pointing to 40, and the right pointer will point to 50. It will work as the next pointer of circularly doubly linked list. Okay, so this is my idea. And whatever be the first node in the in order traversal, that will be my head. Okay, so I'll start the in order traversal from here, and initially my current will be equal to previous, will be equal to null, and my head pointer will also be equal to null. Okay, so what is the in order traversal? Left subtree, then root, then right subtree. So this is my root. I'll call the in order traversal here. I'll go on the left subtree. Now there is a still left subtree on the left part, so I'll still go on the left subtree. Now there is no left subtree, so this is the first node in the in order traversal. So let's say the pointer to this node is t. So I will say that if head is null, then head is equals to t. If head is null, then this is the first node in the in order traversal, right? So head is equals to t, and current is equals to previous is equals to t. When will I do this? If head, if let me put the if statement here. If head is null, then I will do this. If head is not null, then what I will do? I will say previous right is equals to current, and current left is equals to previous. Okay, now when I encountered this for the first time, I said that my head pointer is pointing towards this, and my current and previous are also equal to t. So what I will get is, I will get 40, my head pointer will be pointing here, and my current and my previous pointer are also pointing to this. Now I will backtrack from here. Okay, I will go to 20. When I will go to 20, so before moving on to 20, I will say my previous is equals to 40. Okay, because when I will go here, before moving on to that, my previous will remain current only. When I will go here, this will become my current node. So this will be my equal to current node. We will also look at the implementation, so things will be clear. Okay, don't worry about that now. So this became my current node. Now head is not null. See, when head was null, when we encountered the first node in the in order traversal, we said head equals to t, current equals to previous equal to t, and we got this. Now when we came here, our current node became equal to 20, and our previous node is this 40. Okay, now head is not null, so we said previous right is equals to current, or and current left is equals to previous. So this is my previous, my current is what, 20. So I said previous right is equals to current. Now my current is 20. Okay, it is somewhere here. I said previous right is equals to current, and current left is equals to previous. Okay, so this became like this. Now I will go here, but before I go there, I will say previous is equals to current. Okay, and then I will, so basically then I will call on the right subtree. So first of all, I'll call on the left subtree, then I will operate on the current root, and then I will call on the right subtree. Okay, so first of all, I will call recursively on the left subtree, then I will operate on the current node, and then I will recursively call on the right subtree. But before I call on the right subtree, so my current node will become this. For this, previous will be this. So I will update my previous to this. So my previous will come from here to here. Okay, and my current will come to 50. So this will also go, and my 50, and this will become my current. Now is head empty? Is head null? No. So previous right equals to current, and current left equals to previous. Previous right equals to current, current left equals to previous. Similarly, then I'll go backtracking here, then I'll go backtrack and here. Now this will become my current node, and this will become my previous node, right? Because at the last step I will be here, right? And again I will say that current left is previous, and previous right is current. So similarly, then 10 will be added, then 30 will be added, and then 60 will be added. At the end, after I complete this process, I will finally, my head pointer will be here, and at the last step my previous pointer will be here. Why? Right? Because previous pointer was first here, then it came here, then it came here, then it came here, then it came here, and then it came here. So after the complete in order traversal, I will say that my head left is equals to previous. So my head left will be equal to previous, and my previous right will be equal to head. So my previous right will be equal to head, so that it also forms the circle. Okay, now let's look at its actual implementation. So if we look at the actual implementation, so I have taken 2 pointers, head and previous is equals to null, and I have this is the function which we have to complete, in which we have been given the root node. So I have called the in order traversal on the root node. Now if we look at the in order function, so this is here I have passed the pointer current. Okay, so better understanding. Now if current is null, then return. If the current there is no node, then return. Otherwise, what is the in order traversal? First left subtree, then operate on the current node, then right subtree. So first of all, call the in order function recursively on the left subtree. Then if the head is null, it means this is the first node in the in order traversal, then head equals to previous equals to current, that is this current value. Okay, else previous right equals to current and current left equals to previous, so that it forms a doubly linked list. And before going on to the right subtree, we will say previous equals to current, because when I'm going to the right subtree, let's say this is 2, this is 1, and this is 3. So when I'm going from year to year, at present my current is this and my previous is this. Now when I say in order current right, so the next current will become this. Okay, this will become the next current, that is current right. But for that, the previous node in the in order traversal is this, right? So before calling that, we just update previous as current. Okay, so in this way the doubly linked list will be formed, and at the end, after completing this in order traversal, I will say head left is previous and previous right is head to form the circle. What will be the time complexity? We are visiting all the edges once or all the nodes once, so I can say big O of n. And what would be the auxiliary space? So the auxiliary space occupied here will be nothing but the call stack, which will be used to store the data of the recursive functions of this in order traversal. So how many recursive calls will be made on the call stack? It will be equal to big O of h, that is nothing but the height of the binary tree. At max, this many calls will be stored in the call stack. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.
Hello guys, let's solve the problem of the day. Well, today we have reverse a doubly linked list. So let's read the problem. The problem simply says, given a doubly linked list of n elements, your task is to reverse the doubly linked list in place. What does in place mean? That means we do not have to use any extra space. We just need to move the links here and there so that the linked list is reversed. Okay, now the task is we have to complete this function. Head is taken as a reference to the doubly linked list. New head. Okay, so this function should reverse the elements such that the tail becomes a new head and all the pointers pointing to in the right order. Done. You need to return the new head of the reversed list. Okay, you need to notice this. We have to return the new head, and all the things will be done with driver code. Fine. Now let's try to understand the code with some examples. So taking these sample test cases, let's see the first one. Fine. So what is the basic structure of a doubly linked list? If we have to say, we can say we have these 3 nodes, right? And each node has 2 connections. In usual manner, what would be the case? That means in singly linked list, this would have been the condition. But when we're talking about doubly linked list, that means we need to keep track of the previous. So 4's previous is 3, 5's previous is 4. And what is 3's previous? Well, just like 5's next is null, 3's previous is going to be null as well. Okay, this is the structure of a doubly linked list. Now, if we reverse this, what will be the answer? Again, the 3 nodes will be there. 5 will come here, 4 will be here, and 3 will be here. This time, notice, this is going to be null because 3 has become the tail, the last element, and 5 is the new head. 5's previous will be becoming null, and all the other links will be changed accordingly. That means now 3 is pointing towards 4 in the previous, and similarly 4's next has become 3. Fine. So we understand the task, that what we have to do. Let's try to understand what actually is happening when we are reversing the list. Let's take this example. And let me say 5, 3, 2. These are the values. Well, whenever a node is set inside a memory, whenever we are initializing a node, obviously it is also going to be having some address to it. So let's give some random addresses, right? And now let's try to position the pointers. First one, 5's previous, it is going to be null. 5's next, it is going to be 200, right? 3's previous is 5. That means we have to store 5's address, 100. 3's next is 300, correct? Similarly, 2's previous is this 200, right? And also, whenever we mark the pointers, that means the connection is made. When we are marking it, when we are marking 100 here, that means this connection is made. Similarly, when we wrote 300 here, this connection was done, and this connection was done here. Okay, 2's next is going to be null, right? Okay, this is normal condition. Now let's see what happens when we actually reverse the list. This will be 2, this will be 3, and this will be 5 after reversing. And now let's again make the links. This is going to be null, this is going to be null. Corresponding to 2, we have 300. Corresponding to 5, we have 100, and corresponding to 3, we have 200. Let's make up the pointers. It is going to be having 200. It will be having 300, 100, 200. Yep, done. Now we know how the connections are working. What are the changes here? We need to take a look, right? Take a look to it. So if we notice, let's say this node, we're noticing this node. What changes are here? What changes are here? We were having 3 towards its right. That means towards its, we can say next, it was having 2. And towards its previous, it was having 5. After reversing, 3 on the next side, is having 5, and on the previous side is having 2. Correct? We need to think of what is happening to one single node. And once we have figured out that what is happening, only the positions are swapping. Whatsoever was at the previous is now coming to the next, and whatsoever was on the next is now coming to previous. That means we are simply just swapping. Fine. And this is what we're doing with every node. Let's pick this one up. So 5 was having null on one side and address of 3 on one side. Once reversed, what is it having? 3 on this side and null on this side. See? 3's address on this side and null on this side. Simply, we do not have to do much here. We have to swap it. We have to swap these two values, correct? And swapping is quite easy. We just need a third variable. In this case, a pointer variable. We just have to have one temporary there, and we can swap these two values, and that would be it. And we have to do this for each and every node. That means we need to traverse it once from here till the last, and at every node we need to do this swapping. Let's see the approach for the same. So as we can see here, we just have to initialize 2 pointers. First is current, to just keep a track of on which node we are actually performing the swapping, and then temporary, just for helping us to swap 2 pointers. We need to start from the head, and then we need to move until. So firstly, we need to just store the currents previous to temp. That means we need to use our temp to store value of currents previous so that it doesn't get lost. Fine. Then we will update the previous with next, and we will update the next with the temporary value that we kept here, right? Simple swapping. Then we are updating the current with currents prev. Now, why we are doing that? I hope you remember what we do in usual linked list operations when we have to move forward. If this is our temporary that we are using for traversal, what we usually used to do, we do this, right? Temp equal temps next. This is how we travel. Now, in the case of, let's take this case. So we have 3, 5, 7 as our doubly linked list. After reversing, it will be 7, 5, 3. So if I'm here, correct? In this conditions, on 5's left, that means on 5's previous we have 3, next we have 7. Here on 5's previous we have 7, and on 5's next we have 3. If we see 5, then what will be the next node that we need to pick up after we are done swapping the links of 5? 7, right? We need to move in this direction because we need to do the swapping for every node. So just look here. We are here at 5. Once swapped, it will be something like this. We need to go to 7. And where is 7 here? At 5's previous. Thus, what we are doing, we are replacing current with current's previous. All right. So I hope you understand it now. Okay. Once this loop is executed, that means we have traveled the linked list. What will happen? Eventually, you need to just update the head because head is still pointing to the first node. You need to update the head with P's prev. That means we have, it's actually temps. So we need to update it to temps prev because temp is going to be at the last, right? We cannot keep a track of current here because current is becoming null. Then that is a terminating condition for this loop. We will use the temp. And eventually we will store temps previous to head. Fine. After the updation of head is done, we will simply return it. At this step, we will be returning it. Fine. Let's see the code for the same. Okay. So here is an example code for it. What I have done is I've just made a helper function here, and we actually need to return it. I'll write that later. Okay. So once we have this, what will be done? I'm just calling my helper function with this head. It is receiving head here. I have made 2 variables. The first one, the pointer variables. Well, actually, we are using Python, so we do not name it pointer variable, but you can understand the concept in the similar manner. So we have 2 variables. First is attached to head. Second, for the time being, this is your temporary, by the way. This is what we have to do. We have to store none, just analogous to null initially. After that, while current, unless current is becoming null. We will be doing this. First of all, just 3 lines of swapping anything, right? And then to move forward. Very clear. Then we need to just update ahead with temps previous because it is going to be the last node, which has now become the head. Fine. And this is a check that I've simply performed so that we are not going to encounter any error. So it will be checking that my temporary and my temporary's previous is actually not null. So once it is done, we'll be updating a head, and eventually after that, I'll simply return my head from here. It will be returning, and this will be coming here as the answer of helper, and that will be returned from this function. Fine. So I hope the code was pretty simple. If we talk about the complexity, space complexity is O1. That means constant. We are not using any extra space. We are just moving the pointers here and there. And the question actually was demanding in place. So it is here. And then we have time complexity to be On. Why On? Because N is the length of our doubly linked list, and we are just traveling the doubly linked list for one time. Okay, so I hope you've understood the complexity. Let's just test this code against test cases. Okay, so here is same code, and I made the changes. I have returned my head here and from here. Let's compile it. Okay, so it is giving us the expected output. Let's try to submit that. Okay, so it is passing all the test cases. So I hope you have understood the solution, and if you have, do tell me in the comments and like the video. Thank you.
Hi and welcome to Geeks for Geeks. Today we would be discussing the problem named as intersection of 2 sorted linked lists. So I don't think there is a need of problem statement. It is self-explanatory. Now we are given 2 linked lists and we need to find the intersection of it. So we can see 2 is an intersection, 4 is an intersection, and 6 is an intersection. After all of this, the answer would be 2, 4, and 6. So the most simple answer is that what is an intersection? If we see something again, then there is intersection. So if let's say, just take the example how this intuition is coming up. Let's say I am looking for a friend to partner up in a college where I'm new. I found a person named as, let's say, Ankit, and I found that his traits is not matching up with mine, and now I know, so I would try to find another friend. But if I don't remember that Ankit is not compatible with me, I might get to Ankit again, and again I might realize, okay, he is not compatible, I should move to other person. So the only difference is that to avoid the intersection with Ankit again, I need to remember that Ankit has different traits. So here also we need to remember so that we know that there is an intersection. Whenever we need to remember anything, we can say that we need to use hashing. The very first example is we can hash all the values of the first linked list and we can start traversing on the second linked list. If any value is seen before, that contributes to the intersection linked list. This is the easier example. But can you do it in just one traversal? Okay, like without any extra space. Can you directly build up the sorted one or not? Because in the first approach, we are hashing the values. But can you do this without hashing the values? Let's see this. So what we really can do is, we can have a pointer I, we can have a pointer j. Now I is not equal to j. Now to have an intersection, I should be equal to j. So I know that I is less than j because 1 is less than 2. So I can find a value 2 on the right hand side of a. So I would move forward the right hand side of I. Now I and j is equal to this. So we would have here, okay, this is fine. We have 2. Okay. Now we can't write directly here 2. So we need to make up a new linked list. So we would have a head and we would have a tail. Initially, both of them is pointing to something known as null. Okay. So at this point, we found a match and this would be the contribution. So we can say, see head and tail, you are now equal to something known as 2. Okay, now head and tail both are pointing to 2. How do we know that we need to make this? Because initially head and tail is null. So now after this, we now have an intersection, so we need to move forward. हो गया भैया इसका, अब आगे तो बढ़ो, आगे का बात करो. So to get the next intersection, we need to move forward I here and as well as j here. Now again 3 is less than 4. So to have a value like 4, we can move forward on the right side of the first linked list and we have 4 and we have now 4. So at this point, head is pointing to something. So we would say tail, your next, that is 2, 2's next is something known as 4 and now tail, can you move forward to the new data? So I would say tail, this is you. Tail is done. Now head is equals to 2 and tail is equals to 4. Now as this intersection is given, so we would say, can you move forward a little bit? Can you move forward j a little bit? At this point, I is again equal to j. So I would say tail, that is 4. 4, your next is something known as 6. And now tail, can you move forward to your next element? Now tail would become this. That is tail's next is 6. So we would come here. After this, as intersection is again done, we would move forward I to this and j to this. J is still within the boundary, but we don't have anything to compare in I. So I is now pointing to null, so we should stop at that instance. So if any of I and j is pointing to null, we would stop at that instance. And that is done. So now we would initialize 2 pointers, head and tail, initially to null. And here we would have I and j, so that we have a proper reference to this. Now, while I and j is not equal to null, while I is not equal to null, as well as j is not equal to null. Because any of them becomes a null value, then there is no point. So we would first find the value of i's data. I's data is equals to I dash data. And j data is equals to j dash data. Okay. Now we would say if I data is less than j data, like I was the upper one, if 3 and 4, if something known as this condition is happening up, 1 and 2, so we need to move forward this I. So we would say move forward I. Okay. So I is equals to i's next. Okay. Else if the condition, let's just have this, else if the condition, if i's data is less, we would move forward I. If j's data is less than i's data, we would move forward j. We would say j is equals to j's next. Okay. Else in other conditions, either I would be less than j or j would be less than I. In all other condition at this point, I is equal to j. I's data is equals to j's data. So we would say if head is equals to null, if head is equal to null, then we would say head is equals to tail is equals to the very first data, that is what? New node. Okay, new node with the data as how much? I's data. You can take either of the data. Else in all other condition, this is important, we would first say tail, your next is equal to new node of i's data, and then tell can you move forward to the next. Tail is equals to tail dash next. At the end this would be done, and we would say this, that return head. But after doing this, we need to move forward both the pointers. So at this point we would say I is equals to i's dash next and j is equals to j dash next. Now let us just compare and see how many errors are we making. Seems correct. So no error are being made, and that's just the solution. So we are iterating on each of the values exactly once. So the time complexity is big of n, and the space complexity is constant if we don't consider the return value, because we are not using any auxiliary data structure to store the result. That's it for today. Thank you and have a nice day.
Hello everyone, welcome to this video. So we are going to be solving the problem of the day again. Let's take a look at today's problem. Well, today we have got k sum parts. The problem is saying, given a binary tree and an integer k, find the number of paths in the tree which have their sum equals to k. Okay, a path may start from any node and end at any node in the downward direction. All right, and the answers could be very large, so we have to keep it in the modulo of 10 to the power 9 plus 7. Okay, the question is pretty simple. And is it demanding anything else? We just need to complete this function. We are given root and k. That is our just root and the target value. Let me just return the numbers. Yep. And we have to return an integer. So let's try to understand this problem with the help of the examples. So this is the first sample test case. Let's try to do it. Well, we have a very small tree here. It is just 1, 2, and 3. What do we have to do? We have to count the number of paths. Now, what is a path? A path could be between any two nodes. This time, there is no restriction that the path would be beginning from root or ending at leaves. The question is itself saying that a path could start from any node and end at any node. Just there is only one restriction, that the path is going to grow downwards. Fine. So if you take up any bigger tree, let's say this one, something like this. So a path could be anything. A path could be this, a path could be this, a path could be this one. Just it should grow downwards and it can start at any node and at any node. Fine. So we know what a path is. What paths do we need to count? The paths of which the sum is equal to the target. What is the target value? K is given as the target value here. So we are given K equals to 3 and this is our tree. This is our tree here. We need to calculate the paths which are actually summing up to 3. So if I say, is this path summing up to 3? Yes. 1 plus 2 equals 3. We got one path. Okay. So one is this one. Can we find any other one? Well, 3 is kept here, right? 3 is kept here. And one single node can also be the starting and the ending node. So the path will be itself, correct? So we can say, yes, this can also count up to 3. So the count is increased as well at this condition as well. Eventually, we have 2 paths. Thus, the output is 2, right? Still, it might be not much clear. Let's take a bigger tree with more paths so that you can understand it even better. All right, let's take a look at this tree. It is beginning from here. As you can see, this time we are given 5 as the target. What do we have to do? We need to find out the paths. So if now let's go in a pre-order manner so that it is more systematic. Once we begin from here, obviously 1 is not equal to 5. We cannot count it as a path. We'll grow. I'll go here. I'll say 3. The sum will be 4, right? So obviously 4 is still not 5. The path won't be considered. Now I will go here at 2. This time the total count will be 4 plus 2, 6. But if we just count 3 and 4, because it could start from any node and end at any node. 3 plus 5, we found one path, correct? We found 3 plus 2, that is 5. So this is our first path that we can count. Done. Now, backtracking to 3, we are going to grow this side. That means we are going to go here. So calculating this one, including 3 and including this one, we can say this is also a path. 3 plus 1 plus 1. Firstly, we got 3 plus 2, then we got 1 plus 3 plus 1, right? Then once this is done, and we are to proceed, how can we proceed in this manner? You already have this here. But if you see clearly, if I again begin from this 3 and go here till this last one, I can get one more path, which is 3 plus 1 plus 1, right? We have received 3 paths so far. Let's see if we can get more. Now if I have to go here, 1 minus 1 not equals to 5, but 1 minus 1 plus 5. This path is equals to 5. We can calculate this. So I'm saying 1 minus 1 plus 5, right? Okay. Once this is done, and we go on the left side of this minus 1, we can see this path, right? We can see this path. It is 1 minus 1 plus 4 plus 1. This is also 5. And if we just take this 4 plus 1 path, it is what? It is your 5 as well, right? Now, there is one more path left. If we consider this minus 1, 4 and 2, this will also lead us to 5. It is minus 1 plus 4 and plus 2, right? And obviously we have this 5. So again, the same condition that happened with 3. If we start from 5 and end at 5, that is also a path. This 5 will also be considered, right? So how many total paths do we have now? These are 1, 2, 3, 4, 5, 6, 7 and 8, right? So we have 8 as the answer. So now I hope it is clear what are we looking for and how are we going to approach this question. We are going to be using a pre-order traversal, okay? Now, this question can be approached in like a couple of ways. We are going to discuss them all. But a smarter way of doing this question is to at least keep the track of the paths that we are taking up here. Well, two primary approaches that we'll be discussing in this video is, first of all, keeping the track of path and calculating according to the path, right? That approach will actually end up being of O(n) square. How? We are going to see. The better approach could be, instead of keeping a track of path and calculating, we can maintain a hash map and we can simultaneously do the calculations. But we'd be keeping the track of gains this time, not the path. That solution would land up on O(n). Let's take a look at both of the approaches. First of all, let me discuss the first approach of O(n) square. What will happen in this one? Let me take a sample tree. Let's take this tree as a sample tree. Now, the target for it that I would take is, let's say, 5. We are talking about this approach. We have to keep the track of the path that we are taking. Okay, and what data structures can we use for that? We can use a vector or we can use a string, right? Or we can just typecast that later if we are having it of characters, or we can directly go for vector. Fine. Now, what we do is we start from here. We start from 3. We try to include 3 in our path, right? Now we move to 2. We move to 2. We are here. This is the string formed. Actually, we also consider one value, but just for the sake of explanation, let me start with a vector consisting of at least 2 values. So we have 3, 2 till here, right? Now what do we have to do here? We have to check for the sum. How can we check it? Yeah, we can just calculate it from here. That means we are beginning from the root, we are ending up till the path. But that is not necessary because we know the condition. Beginning and ending point of the path could be any node, not just root and the leaf. What can we do here? We can start from the end, because when we are traveling, we are changing up the endpoints, right? We are changing up the corners. It is up to us how up we are going. So assume we are at this one, we can track it till 2, or we can track it till 3, or even like it was a bigger tree, we could have tracked it till any point. So we are beginning from a certain point, that is our current call, and we can go up to calculate the sum from the end. Okay, so we'll take 2, we will add 3 to it. We got 5. The moment we got 5, we will make a universal counter, okay, the global variable counter, and we will increase it by 1 the moment we encounter any sum equals to the target value. Done. Now what will we do? We will go here. We will go to this 5 following the regular pre-order. Then once we are here at 5, the path that we are storing will be looking something like this, right? Here. This is the path. Now what do we have to do here? We have to start calculating the summation again from the end till the top. Now, what will we do? We'll add 5. We'll check that is it equal to the target. The moment we find 5 equals to 5, that means we are going to increase the counter again, right? These calls still here are done. Now what do? We need to backtrack. And the moment we backtrack, we actually need to remove the element that we have added in the path, because we are keeping track of the path here. That means we go back to 2. We are again ending up at path 3, 2. We need to just pop back this 5. Once that is done, I'll go here. That means my new path would be looking something like 3, 2, 1, right? I'll take 1. 1 plus 2, it will be 3. 3 plus 3, it will be 6. We did not find 5 at any place. That means we are not going to touch the counter. We'll backtrack. We'll be here. All the work of 2 is done. We'll backtrack once more. The path will be this 3 just, and then we'll move to the right side. Here, once we're going on the right side, what will we do? This 2 will be added. That means I will take 3, 2 again. Again, the calculation starts. I will say 2 plus 3. This will end up becoming 5. I will increase my counter. I will go on to the left side. It is 1 written here. 3, 2, 1 now. That means 1 plus 2, 3, 3 plus 3, 6. No 5 encountered. We are not going to touch the counter. Again, moving ahead. Now, what is happening? 3, 2, 1, 2. Right? This is the path. Starting from the end, 2 plus 1 plus 2. What do we get? 2 plus 1, 3. 3 plus 2, 5. We are having 5 here. Counter will be increased. Okay. Now, again, we'll backtrack here. We'll backtrack here because we do not have any other option here. Till here, it was 3, 2, right? And this is a new value, minus 2. So I'll do 3, 2, minus 2, right? Minus 2, 2, it will be 0. And plus 3, it will be plus 3. You're not encountering any 5. That means you're not going to increase the counter. Eventually, the answer that we'll have is 4. Right? And this is the number of paths that we are having, which are actually summing up to 5. Right? 3, 2, 5 itself, 3, 2 here, and this 3, 2, 1, 2. Okay? So I hope this approach is clear. But why we are saying that this can take up to ON squared? Why? Because we are traveling the tree, right? That means we are going to go to every node, right? But in the worst case scenario, the tree could be skewed completely. And then what do we have to do? We have to actually calculate it like this, right? We'll be calculating it like this. This one, then this one, then this one, and this one. It'll be storing every vector, or every element in the vector. And then for every vector, what are we doing? We are calculating the sum. We went to the first one, we calculated the sum. We went to the second one, we went back. We came to the third, we went back. We came to the fourth, we went back. So what are we doing? So because we are traveling back every time till the end, we can say broadly that it is taking up n square, right? How can we avoid this? How can we avoid this? Although for every average case, this solution works perfectly. No problem in that. But let's try to look for even optimized approach. Now this time, instead of maintaining a vector and keeping the track of the path, what I would do is I would keep a track of the gains that we are making while moving in the pre-order manner and while encountering every new node. What will we do? So I will just create up a hash map instead of a vector this time. And we'll be keeping the track of gains instead of keeping the track of path. Now I will just add up 0 and 1. Primarily, you'll get to know later. You'll realize it, why we are storing it. Now, the thing is, assume we are here at 3. We are here at 3. The summation will be 3 itself, right? The current sum that we have till here will be 3. What is our target? What is our target? Target is actually 5. We have to perform this. Current sum minus the target. What do we get? We get minus 2. We'll check, do we have minus 2 already present in the hash map? Well, currently it is not. So in this condition, what are we going to do? We are simply going to take a current sum, which is 3, and I'm going to put 1 corresponding to it. Fine. Okay, this done. Now moving to this 2. We are here. The current sum will now become 3 plus 2, that is 5. And now we have to do this 5, the current sum, minus the target. It will be equal to 0. Just for encountering this condition, we had this, right? If this is the condition, that means we are actually having the difference to be 0. We already have 1 as a value for it. So whatsoever corresponding value that we have here, corresponding to the key, we are having 1 here. We are going to add this value to our main counter. Again, you will be keeping a track of your counter. It will be a global variable. So what you will do is you will just add up 1 this time. Correct? So once we have successfully increased the counter, we have to do one more thing. We have to make a new entry here in the hash map. That will be with the current sum. The current sum is 5 here. And the value corresponding to it is 1 because we are encountering it for the first time in this iteration. Now once this is done, we are here at 5, right? A new entry. Current sum is 5, like sum till here is 5. We'll add up 5. The new current sum will become 10, correct? Now what do I have to do? I have to do 10 minus the target. What is the target? 5. We end up getting 5. We have to find this value in the hash map. Do we have this value? Yes, we have this value. What will we do? We will add up this one here in the counter. Okay. This one is representing the path that we have gotten till here. This one is representing the path that we have gotten till here. This is this path. What we are doing, we are actually making the gains. Initially, we were at 0, correct? Initially, we were at 0. Then at a point, where did we go? We went here, 3, right? 0 added up. Then 2 added up, we went here. It became 5, right? Then 5 added up, then it became 10. We are just subtracting the target from it. We are just subtracting the target from it, and we are seeing if the value is already available. We are taking up that path. That means a path has been made till here. Okay, we are calculating this one. We are subtracting this. If this is equal to the target, we will end up getting a path here. Okay. Now let's proceed on the right side. Okay, there is a catch here. Once you're backtracking, that means you are leaving 5 here. See, you are not keeping the track of it, right? You do not have to, you are not just moving ahead in that path. You're not keeping track of that gains. You're coming back to 2, and then you'll be keeping up the tracks. You will be keeping up the gains. So for that, what you have to do is, you have to decrease this value, right? You have to put -1 to this key. Okay, this time it will be 0 now. Or you can also delete this entry. That wouldn't make any difference. Now again, we are going to go to this 2. That means we are taking up the next path. This time, the current sum till here is 5. Remember that. 5 plus 1 will be 6. 6 minus 5, it will be 1. Do we have 1 here? We do not have 1 here. That means we are not going to make a count, but we are going to make one entry. That is going to be 1 corresponding to 1, because 1, we are just initializing it because a single path is still there, right? What is the condition? Okay, let me just mark it. Let me see if this condition is going to come here or not. The thing is, if you are at a condition that whatsoever value you are trying to enter is already present in the hash map in the form of a key, what you will do, you will increase it. If you do not have that already, you will put that value with 1. Now, once you are here, we have done it. Okay, we did not get any path here. This time we are going to backtrack. That means we can -1 it, and we will end up here, 5. All the things are done. We will backtrack, 3 here. This time we are going to go here on the other side. Again, it will be 3 plus 2, 5. What will we do? 5 minus 5. 5 minus 5. That means 0. We have 0 here. We'll increase it with a corresponding value plus 1. Now we take up this path. 5 plus 1, 6. 6 minus 5 end up being 1. Do we have 1 here? We do have 1 here. But the corresponding value here is 0. We are going to add up 0 because we have already found this path, and this is no path, right? This is just a record that we have kept, and it does not make any gain. Now what do? We are here. We're going to go further. It will be 5 plus 1, 6 plus 2, 8. We're going to do 8 minus 5. That means we get 3. Do we have 3 in the hash map? Yes, we have 3 in the hash map. What can we do? We can add the corresponding value 1 to it, right? What do we actually mean by that again? Let me quote it. Okay, see. First step 3, second step 2, one more step 1, one more step 2. Total part till here is 8. The target that we have is 5. If we subtract 5, that means if we subtract this, okay, the last value left is 3. If this value is present in the hash map, if we have encountered this, that means this is a valid path and we are just counting it up. Okay, fine. This is done till here. Now what do? We're going to backtrack. We're going to backtrack here. Now at this point, 5 is here. 5 minus 2. 5 minus 2, this will be 3. And 3 minus 5, this will be your minus 2. Do we have any entry for minus 2? We do not. We don't have any entry for minus 2. What will we do? We'll create an entry. Just the code will do, which actually is not going to be of any use. And the counter won't be changing. Fine. Again, eventually, the traversal is done. Okay, what is the answer that we are getting? Again, we are getting 4 as the answer. 4 paths. What are the paths? Let me retrace it. This 3, 2, this 3, 2, this 2, 1, 2, and then this 5 itself. We have the 4 paths with us. Correct? Okay, now let's again quickly discuss what was the flow of the recursive function that we were making. First of all, we need to calculate the current sum. So that means whatsoever sum we are getting till here, we need to add up the roots data to it to make the current sum. Then we will do sum minus the target. So the sum we have created, we need to minus target from it. We need to look that in a hash map. If that is present in our hash map, we need to increase our total with the value corresponding to it. Else, what do we have to do? We have to either make a new key if that is not already present. If that is already present, we need to increase the value of the key by 1. Okay. Now, once this is done, this is the main logic. We will call upon the subtrees. Okay. And all the things will be done by the recursion. Then once this is done, because we do have to unmake the things, we are backtracking. We need to reduce the value at sum. That means we need to reduce the corresponding value to the current sum's key. We have to do -1 there. Fine. So I hope you have understood the flow. Let's take a look at the code. So I have done my implementation in Python. You can use any language of your choice. So what I've done here is I've made this global variable total, which would be keeping the count. And then what I'm doing here is initially total is equals to 0. I'm creating one hash map in which I'm giving 0 plus 1 as the value, as the default value, because this is a condition if we are including the root in the path. If the difference of the current sum and the target is getting 0, this is just a corner case that we have to deal. Then what do we have to do? We are making up a call to the function find path sum. We are here at find path sum. We have to check if if the node, which I'm representing as current here, a little confusing. If that is none, I'll simply return. If that is not, again, this is the main flow. I will create up the current sum, and that is represented by s variable here. I will do s minus target. I'm looking that thing in my hash map. If the value is found, I'll just increase my total, my global count with it. If that is not the case, what do we have to do? We have to either, let me tell you the functionality of get. What happens with get is, if I'm giving s, 0, if s is already present, it will give the corresponding value. Or if s as a key is not present in your hash map, it will give 0. So it is covering up the else condition that we have discussed here. Okay, it will make a new key. If the key is not already present, the value by default will be 0. And if the key is already there, it will give the value. And in both the cases, what are we doing? We are adding 1 to it. So either it will be any new key which will correspond to 1, or any old key which will correspond to its own value plus 1. Okay, this is what will be happening here. After that, I've made up the calls to the left subtree and the right subtree. Once that is done, this is backtracking a step, and this is very crucial. We need to -1 the choice that we have made. The number that we have added, the gain that we have shown here, we need to subtract that. Once that is done, simply return it, and eventually in the main, once the functionality of this function is completely over, the total will be having the count that is required. We need to just return that total. Okay, let's try to test this code against all test cases. Okay, so here is the same code. Let's try to compile and run it. Okay, it is giving us the desired output. Let's try to submit that. Okay, so it is passing all the test cases. Fine. Let's quickly discuss the complexity. Well, we have already seen this approach is of ON. Why? Because now we are not wasting the time of going back and calculating the sum at every path, right? In the vector approach, we were going backward. We were calculating the sum, correct? And in this path, we are just looking up for the values in our hash map, which is of O1, which is going to be ON into 1, right? Which will eventually end up being ON. So I hope you understood the solution. And if you like the approach, you may comment that and do like the video. Thank you.
Hello and welcome everyone. I am Jadal Sanya, and in this video we are going to study the question determine if two trees are identical or not. So this question is the part of binary trees, and this question is very basic and you don't need to think a lot. So what is the prerequisite of this question? You simply need to know how to travel the tree, how to traverse the tree. That is the basic concept which we are going to use inside this question. Okay, and we are aiming for 20 likes in this video, right? So you guys can like this video and let's start. So first of all, we'll be reading the problem statement. It does not have much thing to discuss about. So given two binary trees, the task is to find if both of them are identical or not. Okay, so you have to just check whether two binary trees which are given to you are identical or not. And based on the input test case, you have to print yes or no. If identical, then print yes, else print no. Right? So let's have an understanding with the help of an example. Okay, so I've written down three different test cases and let's try to analyze all of them. So let's start with the first test case. Okay, so what I'll be doing, I'll be comparing one by one each and every node. So over here, you need to take care whether the node is present on the left hand side or on the right hand side, and who is the parent of that node. Okay, so over here, the first test case contains this tree. So I'll be comparing one by one each and every node. 1, okay, 2, yes, and 3. Right? So this is your tree 1 and this is your tree 2. I can see they are completely identical, right? So the output for this test case comes out to be yes. And in the question, you will be given a method and you have to return Boolean value for that method. Basically, depending upon whether it is identical or not, return true or false. And in the output, yes or no will be printed. Let's have a look at the second test case. So I can see the first node 4, okay, 5, yes, and the last one 7. Over here, I can observe that these nodes do not match, right? So these two trees are not identical, and hence the output for this test case comes out to be no. Fine. Let's have a look at the third example. Okay, so this is the third example. Let's have a comparison. 4 and 4, they both match. And over here, you can observe here node 5 is present, but over here nothing is present. Node 5 is not present. So although the other nodes are identical, but one of the node is missing, right? So it cannot be said that both these binary trees are identical, right? So for this test case, the output comes out to be no. Okay, so I've taken all different types of test cases which is possible when you will be given two different binary trees, right? So I hope you got a complete understanding of what the question is trying to say and how to approach this question. So let's have a discussion about how to solve this question, right? Let's start. So how to solve this question? So basically, if you want to solve this question, it's very simple. You simply need to travel the tree. So basically, have one pointer in tree 1 and have another pointer in tree 2. And whenever you are currently standing at any of the node, you will follow the same traversal technique. If you are going to follow first of all left traversal and then the right traversal, then both of them are going to be traversed in the same manner. So let's start. Let's understand how to travel the entire tree, how to traverse the entire tree. So I'll be having one pointer that will be P1, that will be pointing to the node of tree 1, and P2 will be pointing to T2. So the node of tree 2. Right? So P1 currently standing at P1. So P1 is currently pointing to 1 and P2 is also currently pointing to 1. So what I'll be doing, I'll be following a traversal technique in which first of all I'll be comparing the root node, comparing the current node whether they are same or not. And then I'll be going towards the left subtree and then I'll be traversing towards the right subtree. So this is nothing but pre-order traversal, right? So I'll be following pre-order traversal. Currently P1 is pointing to 1, P2 is also pointing to 1. Are they identical? Yes. So what I'll be doing, I'll be making a call to the left subtree. So your pointer will be currently pointing to this node number 2. Now, as you have encountered a new node, compare the values. Okay, I can see, are they identical? Yes. So move ahead. So go towards the left hand side, nothing is present. Traverse back, move towards the right hand side. 2 does not have any right node. right? So what you will be doing, you will be backtracking. So on backtracking, your pointer will again come back to node number 1, and now from this, as you have already explored the left subtree, you need to make a call towards the right subtree. So on making a call towards the right subtree, your pointer will be pointing to this node, both of them. Now compare, are their values equal or not? Yes, they are absolutely equal. And have a look at the left and right subtree. They don't have any left and right subtree, right? So did you find any of the node missing, or did you find any of the node not equal? No, nothing has been found such a way, right? So what I will be doing, I will be printing yes in this case. So basically, when you will be returning false, I will be just showing you in a different example, so you'll be getting a clear understanding what you have to return while traversing the tree. Okay, so now here comes the second test case. Okay, again doing the same process. This is your first pointer, this is your second pointer, right? So first of all, compare the values. Is 4 equivalent to 4? Yes, absolutely, it is equivalent to 4, right? So what I'll be doing, I will be making a call towards the left subtree. Okay, making a call towards the left subtree. Currently I'm pointing to 5. Is 5 equivalent to 5? Yes. So make a call towards the left subtree, but nothing is present. So try right subtree, nothing is present. So what I'll be doing, so this node is completely, so this subtree is completely identical, right? Both of them has this subtree identical. So from this point, you will be returning true. So true will be returned from the left hand side of 4. Basically, the left subtree of 4 will be returning you true, right? And now you have to find the value, that what is the value returned from the right subtree. So I have completed the traversal of the left subtree. Now I need to traverse the right subtree. So compare 7 and 6. So I can see first of all the comparison between the nodes. 7 is equivalent to 6. No, it is not equivalent, right? So from here onwards, what I will be doing, from this point itself, I will be returning false. Does not matter what the left and right subtree will be doing, but I will be returning false. So the right subtree of this 4 will be returning you what? It will be returning you false. And now let me just clear out this entire drawing and have a clear view. So you can observe that for this node, you got one value from the left hand side, that is true, and from the right subtree you got false. So overall, you cannot say that this is identical, right? Because you need to have true values written from both the ends. So hence the output comes out to be, you will be simply doing the AND operation of this values which are returned by the left and right subtree. So on doing the AND of true and false, you'll be getting false, absolutely, right? So the overall output comes out to be no. So over here, each and every node will be returning true or false. So basically, you will be saying that the subtree rooted at that current node, is it identical to the other tree or not, right? So if it is identical, both of them will be returning true towards its parent node, right? So this is the process which we'll be following. Now I'll be writing down. Let's have a look at this third test case as well, right? So you will be getting a clear understanding. So now let's start. This is your first pointer, right? So we'll be doing pre-order traversal. First of all, check the node value. Yes, it is equivalent to 4, right? So have a look at the left subtree. So left subtree over here, you can see this contains 5 and this does not contain any node, right? So it is possible that sometimes one of the node might be missing, right? So in this scenario, you can conclude that this subtree rooted at 5 is not identical to the subtree rooted at this node, because over here there is no subtree present on the left hand side of 4, right? So this is your tree 2 and this is your tree 1. So from this itself, you can return false. So basically, this left subtree will be returning you false to the node number 4. So the value 4 false will be returned, and over here as well false will be returned. And now let's have a look at the right subtree. So basically, we already got one false, so you already know that end of any false will be false, right? So basically, let's say if this returns true, then the overall output will be equivalent to false. Hence the output comes out to be no. So basically, basic traversal is required, and whenever you encounter any node, just compare the values, both the pointers values, right? And if you find any of the node is null and the other one is not null, then you can conclude that you have to return false in that scenario, right? So now let's have a look at the algorithmic steps. 2 to 3 things are there which we need to keep in mind. And as I'm going to use the recursive approach, we need to have one of the base case, right? So what can be the base case? So base case can be the null values. It is possible that the pointer 1 is also null and the pointer 2 is also null. So in that scenario, it means that you have reached the end of the tree. So basically, there is nothing present, subtree is not present. So that concludes that you have to return true at that point, right? So let's have a look at this algorithm. So now the first base case, the first thing that we need to check is that if we have the pointer 1 is also null and the pointer to P2 is also equivalent to null. In that scenario, we can conclude that you can simply return true in that sense. Okay, fine. Now what can be the other scenario? See, the other scenario is that P1 and P2, both of them are not null. P1 is also not null and your P2 is also not null. If both of them are not null, then first of all, what you need to do? First of all, you need to check the values of P1 and P2. P1 dot data, is it equal to P2 dot data? Yes or no? Okay, so whatever is the value, it might return true, it might return false, right? So you have to check this value. Then what you have to do, you have to make a call towards the left subtree and the right subtree, and both the subtrees will be returning some value, either true or false. So you simply need to have the AND operation, logical AND of all these values. So I'll be making a call towards the left subtree, P1 dot left and P2 dot left, right? And again, what I'll be doing, I'll be making a call towards the right subtree, function call P2 dot left, P2 dot right, basically right subtree, right? And you can have a call at the P2 dot right. Right, so the end of all these values will be concluding whether the subtree rooted at that node are identical or not. And at the end, what can be the other scenario? The other scenario can be that P1 is null and P2 is not null, right? Or it can be P2 is null but P1 is not null, right? So in that scenario, you know that the output is always going to be false, right? So the third thing is that if any of the above condition is not satisfied, then you can simply return false, right? So this is the entire algorithm. Okay, and now let's quickly write down the code for the same and let's have a look at the implementation part. Let's see. So over here, this is the entire implementation part of the algorithm which we saw right now. I have implemented in Java, but the same can be implemented in other languages. Just take the reference of the algorithm. Okay, so now over here, the first condition is the base condition. If both of them are null, over here, the pointer which I have used is root1 and root2, right? So don't confuse yourself. It is root1 and root2. So if both of them are null, then you can simply return true at that point. Now, if both of them are not null, then you have to first of all check their values, right? So I am comparing the values of root1 and root2. And then what I am doing, I am making a call towards the left subtree of both the root1 and root2. And then I am making a call towards the right subtree, right? And all these values will be done logical AND operation, right? And then whatever is the conclusion, that conclusion will be returned from here itself, right? And if this condition is not satisfied, then it means that either of them is null, right? So in that scenario, you know that the output is obviously going to be false, right? So I have simply added the return statement that contains false value, right? So now let's have a look at the submission. Let's try to submit and let's see the acceptance. So we can see that the problem has been successfully submitted, and let's try to analyze the time and space complexity. What can be the time and space complexity? Try to guess. So the time and space complexity obviously is going to be the size of the tree, right? So how many nodes are present? Let's say both the trees will be containing n number of nodes, right? So the overall time complexity will be total number of nodes required because you are going to traverse the entire tree, right? So the overall time complexity will be order of n. And what about the space complexity? So the space complexity will be the size occupied by your recursion, right? Recursive stack. And what is the maximum possibility of the size of the stack in this scenario? It is possible that the stack will be filled as much as the height of the tree. So what can be the height of the binary tree? It can be log n. So the space complexity in this scenario will be log n. And let's see what is the expected time in space complexity, order of n and order of height of the tree, right? So it is completely matching the expected time in space complexity, right? So this was it. This was the entire approach for the question determine if two trees are identical. If you really enjoyed this solution, do hit the like button and share it with your friends, and do comment down your approaches in the comment section, right? I'll be meeting you in the next video. Thank you for watching. Bye bye.
Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is symmetric tree. First of all, let us start by understanding the question. What does question say? Given a binary tree, check whether it is symmetric or not. That is, whether the binary tree is a mirror image of itself or not. So what basically they are saying is, we are given a binary tree. So that means that each node can have either 0 child or 1 child, or at max 2 child, right? Left and right. Okay. So we need to tell whether that binary tree is symmetric or not. So whether it is a mirror image of itself or not. So if we take mirror image of that binary tree and compare both of them, they should be equal. Or if we draw a line in between, then the left part should be a mirror image of the right part. Okay. So if we look at the first example here, then if I draw a mirror image of this, it would be exactly same. Or if I draw a line from center, then this is a mirror part of this, or this is a mirror image of this. Okay. So basically the left and right part are symmetric. Okay. So here the left child is 1, here the right child is 1, here the left child is 2, here the right child is 2. If you draw a line from between, both of them are, both the parts are symmetric. Okay. So that's why the output is true. Okay. If we look at second example, then these are definitely not symmetric, and hence the answer is false. You don't need to read input or print anything. Your task is to complete the function is symmetric, which takes the root of the binary tree as its input and returns true if the binary tree is the same as the mirror image of itself, else it returns false. The expected time complexity is big O of n, where n is the length number of nodes in the tree, and expected auxiliary space is height of the tree, and the constraints are given here. So now if we think about solving this problem, so basically see, we are given a binary tree and we need to tell whether it is symmetric or not. So whether it is mirror image of itself or not. Okay. So basically if I take one example, so let's say this is 10, this is 12 and this is 12. So is it symmetric? Yes. How? If I take a mirror image of it, the 10 will remain here only. This 12, okay, this 12 will come here, because on the mirror it will be here, and this is 12 will come here. Okay, and these two are exactly same, so we will say they are symmetric. Okay, what is another way? Just draw a line in between, and if you flip this, it will be these two will be equal. Okay, so if you flip it, it will overlap with this. Okay, or you can say if you take a mirror image of the left part, it will be printed on the right part, that is symmetric. Okay, so basically let's say one more example. So this is symmetric. Let's say I have 12 here, I have 12 here, and let's say I have 9 here and I have 9 here. Is this symmetric? No. See, here it is 10, here it is 12, 12, that's okay. But this 9 and 9, if this is the left child here, this should be the right child, then it will be symmetric. If I draw a mirror image, see, then what will happen? 10 will come here, right? Then this 12 will come here, and this 12 will go on the right side. Okay, then what will happen? This 9 will come here. Okay, if I draw it here, so this 9 will come here, and this 9, okay, this 9 will come here. Okay, now compare, is this equal to this? No, these two are on the left, these two are on the right side. Okay, so these are not symmetric. Even if you draw a line from the center, this and these are not mirror image of itself, and if you flip this over this, they will not overlap. Okay, so what we need to think of is that starting from the root node, if we move one step on the left, then on the right side we will move on the one step on the right. From here, if I move one step, so we will compare these two nodes. Okay, now from here, if I go to left, I will compare the right child of this, because it is on the right side. If I go here on the right, then I will compare the left child of this. Now, so basically these two will be compared and these two will be compared. Now from here, if I go to the left child, from here I will go on the right child, because we are comparing these two nodes. So this left child will be compared with this right child, and this right child will be compared with this left child. Okay, so basically that is what we need to do. So if we look at this example, so what I'll do, see, this node is common to both the parts. So what I'll do, I'll say check this node and this node. If they are not equal, return false. If they are equal, then for this node's left node, compare it with this node's right node, and this node's right node, compare it with this node's left node. This 8 and 8 are same, this 9 and 9 are same, so move further. So this node's left node, now I compared this 8 with this 8, right? So this node's left node will be compared with this node's right node, right? And I compared this 9 and this 9. So 9's left child will be compared with this 9's right child. Okay, now these and these are also same, so we will compare further. Now we are comparing these two. So this node's right child will be compared with this node's left child. So everywhere it is equal. So basically, if we are comparing two nodes, one from the left and one from the right part, we will compare its value, and then for the left part's node, its left child will be compared with the right child of the right part node, and for the left part node, its right child will be compared with the left child of the right part node. This we will do recursively, and at any step until we do not reach out of the tree, and at any step if the values do not match, even if two nodes, okay, even if there is one mismatch, we will say it is not symmetric and we will return false. Okay, now let's look at its actual implementation so you will have a better idea. So if you look at the actual implementation, so what I have done, first of all, I have taken one answer variable and marked this as true. Okay, now if the root is itself null, then return true, because an empty tree is symmetric. Okay, if the root is not null, then what I'll do, see, root was common to the left part and the right part, so I call the check symmetric function, and I will compare the root left node with the root right node, and I'll also pass the answer variable. So whenever there will be a mismatch, I'll mark the answer variable as false. Okay, now if we look at the check symmetric function, I have to compare a node R1 with node R2, and this is the answer variable. Now if both R1 and R2 are null, so if we have come out of the tree, or they do not exist, then return true, right? Because if we look here, for let's say for for 20, now this is R1 and this is R2. Okay, now let's say I called left child of this and right child of this, so this is also null and this is also null, or 6 left child is null and here 6 right child is null. So null and null are symmetric, right? These are symmetric, there are no values. Okay, so if R1, the two nodes which I need to compare, if both of them are null, then directly return, because that's true. Okay, but if R1 is null and R2 is not null, it means I needed to compare R1 and R2. Now R1 is null but R2 is not null, so they are not symmetric, so I'll mark answer variable as false. If R2 is null and R1 is not null, then also I'll mark answer as false. If both of them are not null, then first I'll compare their value. If R1 data is not equal to R2 data, then make answer variable as false. If R1 data equals to R2 data, then recursively check for further child. Okay, so I'll call the check symmetric function, and if I am calling the left child of the R1 node, I will compare it with the right child of R2 node, because R1 is a node on the left side of the tree and R2 is a node on the right side of the subtree. So if I am checking the left child of R1, I will compare it with the right child of R2 to check symmetric. Similarly, I'll call check symmetric function, and if I pass the right child of R1, I'll compare it with left child of R2 and I'll pass the answer variable. Okay, so finally this will compare all the possible values, and it will make answer equals to false if there is a mismatch, and then finally I will return answer. What will be the time complexity? Time complexity would be big O of n, because we are traversing through all the nodes. Okay, what would be auxiliary space? The auxiliary space here will be big O of height of tree. Now why height of tree? Because I am calling this recursive function. Okay, so a call stack will be maintained, and at max how many elements can be there in the call stack, recursion stack? It is equal to height of the tree. Okay, now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is AVL tree insertion. First of all, let us start by understanding the question. What does question say? Given an AVL tree and n values to be inserted in the tree, write a function to insert elements into the given AVL tree. So basically, we want to insert values in the AVL tree. Okay. The tree will be checked after each insertion. If it violates the properties of balanced binary search tree, an error message will be printed, followed by the in-order traversal of the tree at that moment. If instead all insertions are successful, in-order traversal of the tree will be printed. Okay, so if let's say I want to insert 3 values, let's say I want to insert 5, then 1 and then 4. So first of all 5 will be inserted, my tree will look like this, then 1 will be inserted, it will look like this, then 4 will be inserted, so initially it will look like this, then after some work it will finally look like this. Okay, so the in-order traversal of this balanced binary search tree or AVL tree will be 1, 4, 5. Okay, then if 7 values are to be inserted, it will become this. Okay, so we will look at it, and You don't need to read input or print anything. Complete the function insert to AVL, which takes the root of the tree and the value of the node to be inserted as input parameters and returns the root of the modified tree. So basically we are given this function. In this function the root of the AVL tree will be passed and the data which we want to insert will be passed, and we will be inserting that value, modified that tree if required, and then finally return the modified root. Okay, the expected time complexity is log n and expected auxiliary space is height of the tree, and the constraints are given here. So now if we think about solving this problem, so basically see, we want to insert values in AVL tree. Okay, so first of all we need to understand some basics of AVL tree. What is an AVL tree? It is a balanced binary search tree. What is balanced binary search tree? First of all, let us cut this in two parts. So what is balanced and what is binary search tree? Binary search tree is a binary tree in which the value of the root or the value of any node is greater than value of the all nodes in left subtree. Okay, and value of the node is less than all nodes value in right subtree. Okay, so that is basically a binary search tree. Okay, so let's say this is 12, this is let's say 9, this is let's say 8, this is let's say 10, let's say this is 13. Okay, so this condition should hold true for all the nodes. So for example, 12 is greater than all the nodes values in the left subtree and it is less than all the nodes in the right subtree. Similarly, 13 is the leaf node, so no need to check further. Now 9 is greater than all the nodes in the left subtree and less than all the nodes in the right subtree, and 8 and 10 are leaf nodes, so no need to check. So this is a binary search tree. Okay, now what is balanced binary search tree? See, if I give you this is a binary search tree. Okay, it is fulfilling this property, but this is not balanced binary search tree. Okay, what is the meaning of balanced binary search tree? It means that the balance factor of all the nodes should be either -1 or 0 or 1. Now what is balance factor? Balance factor is nothing but height of the left subtree minus height of the right subtree. Now this balance factor should be either -1 or 0 or 1 for all the nodes. If it is not from any of these values for even one node, then it is not balanced. Okay, so for example, what is the balance factor of this node? It is 0 because there is no left child, there is no right child. Similarly, balance factor here is 0. What is the balance factor of this node? Left child has height 1 and right child also has height 1. So the balance factor here is 0. Okay, what is the balance factor of this node? 0. What is the balance factor of this node? Height of the left subtree 1 and 2, height of the right subtree 1. Okay, so height means the longest path until the leaf. Okay, starting from that node. So this is 2 minus 1, so this is 1. So here all the nodes have balance factor from these three values only, so this is balanced. Here if I calculate the balance factor for this node, then height of left child is 1, 2 and 3, and there is no right child, so that is 0. So this is 3, so this is not balanced. Okay, similarly the balance factor here is 4, so this is not balanced. So what is balanced binary search tree or AVL tree? Where the balance factor of all the nodes is either -1, 0 or 1. Okay, now so if I want to do insertion in an AVL tree, what I will do is, first of all I will insert the value as per the rules of binary search tree. Okay, and then I will balance any unbalanced node. So first of all we'll simply insert the new value which we want to insert according to the rule of the binary search tree, and then if any node is unbalanced we will balance it. So for example, let's take this example. So this is 12, this is 9, this is 8, this is 10 and this is 13, right? So what I will do, let's say I want to insert 11. Okay, so first of all I'll start with the root node. if the value to be inserted is greater than the current node value which we are looking at, then that value will be in the right subtree according to the rules of the binary search tree. So we will go on the right subtree part. If the value to be inserted is less than the current node which we are looking at value, then we will go in the left subtree. If it is equal to, we will skip inserting it. Okay, we will not insert the same value. Let's say I want to insert 11. Now 11 is less than 12, so it will be in the left subtree of 12. So I'll come here. Now I'll compare 9 and 11. 11 is greater than 9, so it will be in the right subtree of 9. So I'll come here. Now 11 is greater than 10, so 10 will be in the right subtree of 11 will be in the right subtree of 10. There is no right subtree. So what I'll do, I'll insert 11 here. Is it a binary search tree? Yes. Is it a balanced binary search tree? We need to check. So how will we check the balance, whether it is balanced binary search tree or not? See, after every insertion, we are balancing it. Okay, so every insertion will be in two parts. One, insert the value and then balance the tree. Okay, so after every insertion, the tree will be balanced binary search tree or AVL tree. Okay, so whenever we insert a new value, we only need to check whether it is imbalanced with respect to that node or any of its ancestor. Because when I insert 11 here, height of this node will change, height of this node will change, height of this node will change, and height of this node will change. Height of its ancestor only will change. So those nodes can only become imbalanced. Okay, are you getting my point? For example, here there is one subtree T1 and here there is one subtree T2. Then T1 and T2, in that any node cannot get imbalanced. Okay, because before this step the tree was balanced. After every insertion we are balancing the tree, right? So now we inserted this, right? So now if I calculate the balance factor of 11, it will be 0. The balance factor of 10 is 0 minus 1, that is minus 1, that is also balanced. The balance factor of 9 is 1, height of left subtree, and 2, height of right subtree, that is minus 1, that is also balanced. The balance factor of 12 is 1, 2, 3, height of the left subtree is 3, and 1, height of the right subtree is 1. So 3 minus 1, that is 2. So this is not balanced by balanced binary search tree. This is not balanced with respect to this. Okay, now what we need to do, now let's have a look at this. But the first step is clear. How will we insert it? We will keep going on left or right with respect to the property of the binary search tree, and whenever we reach a leaf node, we will insert on the left child or right child respectively as per the value. Then we will keep coming back, and for all its ancestor we'll check the balancing factor, and if they are not balanced we will need to do some work. Now let's look at it. So now after inserting a value, let's say the tree became unbalanced. Okay, so let's say it became unbalanced with respect to node X. Okay, in all the 4 cases. Here X, Y and Z are nodes and T1, T2, T3, T4 are subtrees. Okay, so now this is the first case when let's say X is the first unbalanced node when after inserting the value when we were checking their ancestors one by one during backtracking, X is the node which is unbalanced. Okay, so let's say the value which we inserted is in the left child of the left subtree of X. Okay, so what is the left subtree of X? It is starting from Y. The value which we inserted is in the left child of Y. Okay, so it is somewhere in this part. Okay, so this is called left case. Okay, similarly here let's say the value which we inserted is in the right child, in the right subtree of the left subtree of X. Okay, so the left subtree of X starts from Y, and in its right subtree we inserted the value. So this is called left right case. Okay, similarly here this is called right case. Let's say the value which we inserted is in this part. Okay, and this is called right left case. Okay, now let's say the tree is imbalanced. Okay, from the point of view of X. Okay, so now what we will do here is, here we need to do a right rotation. Here we need to do a right rotation on X. Okay, so what basically right rotation on X means, we will this part we will rotate it on the right. So X will come on the right and Y will come on the top. So Y will come here, X will come here, T1 will come here, Z will come here, T3 will come here, sorry, this is a subtree, and T4 will come here. Now understand one thing. So X is the right child of Y. Okay. Now right child of Y was T2. So now where will we place it? See, understand one thing. T2 is less than X, but it is greater than Y. So T2 will come on the right of Y because it is greater than Y, but it will come on the left of X because it is less than X. Also, the left child of X is now empty. So what I can do is I can place T2 here. Okay. And this will now become balanced. Okay. Why? See, here, initially, let's say it was inserted somewhere here. Okay. Let's say my, let's take a simple example. Okay. So let's say the value, there is a 1 here, it is x1, here it is x2. Now these are nodes. Okay, these are not subtree, and this is x3. Okay, and let's say here there is no value, here there is no value, and here also initially there was no value. Okay, so if I look at this, what is the balance factor of this? 2 minus 1, 1. What is the balance factor of this? 0. What is the balance factor of this? 0. Balance factor of this? 0. Balance factor of this? 0. So everything is balanced. Suppose I enter x3 here. Okay, x3 is taken. No. Okay, suppose I enter x3 here. Now what is the balance factor of this? 0. Balance factor of this? 1. Balance factor of this? 1. 2 minus 1, 1. Balance factor of this? 3 minus 1, 2. So it is imbalanced from this point of view. So if I right rotate it, what will happen here if I draw it here? So y will come here, x will come here, x1 will come here, then x2, that is the right child of y, will be the left child of x, z will come here, and x3 will come here. Now is it balanced? Look, everything is balanced. This balance factor is 0, this is 0, this is 0, this balance factor is 1, this balance factor is 0. So it is balanced. So what we do is we do the right rotation on x. Okay, don't worry about the implementation, we will have a look at that. Now this is the left right case, okay, where the new node inserted is somewhere here, okay, in this subtree, and due to that it became imbalanced. Okay, now we will not be taking such kind of examples for every case. You can take an example where the tree was initially balanced, and after inserting the value in the right child of the left subtree of x, it became imbalanced from the point of view of x. Such example you need to take, okay, and then work out on it. Okay, so here what we will do, first of all, here we will do left rotation on y, and then we will do right rotation on x. Okay, so left rotation on y means catch y and rotate it left. Okay, so what will happen? X will come here, then z will come here, t1 will remain here only, right? Then z will come here, t2, okay, or z will come here. Now y will be the left child of z, okay, and t3, t4 will come here, t4 will come here, okay. Now t3 is the left child of z, it will become the right child of y. Okay, similarly how t2 became the left child of x here, t3 will become the right child of y, and t2 will remain here only. Okay, so this will happen, and after this you will do right rotation on x. Okay, so z will come on the top, then x will come on the right, and t1 will come here. Okay, so t1 came here, x, t1 and z are done. Now t4, that is the right child of z, will be the left child of x. So t4 will come here, y will come here, and t2 will come here, and t3 will come here. Okay, so this is the left rotation on y, and then the right rotation on x, and this will be a balanced AVL, balanced binary search tree or an AVL tree. Now let me rub this part, and then we'll look at these two cases. Okay, so now let's look at these two cases. So this is the right case where the new node inserted is somewhere in the right subtree, right child of the, in the right subtree of the right child of x, and x is the imbalanced node. Okay, first imbalanced node starting from the leaf node. Okay, so now what we will do, this is right case, so we will simply do a left rotation on x. Okay, so we will catch it and rotate it left. So y will come on the top, x will come in the left child of y, t1 will remain the left child of x, now t2 will become the right child of x. Okay, then z will remain here only, this will become t3 and this will become t4, and this will be a balanced one. Okay, now let's look at the fourth case. This is the right left case. So what we will do here, so here the new node is inserted in the left subtree of the right child of x, and x is the imbalanced node. Okay, so here what we will do, first of all we will do a right rotation on y, and then we will do a left rotation on x. Okay, so let's do a right rotation on y. So y will be shifted right, z will come on the top. Okay, so what I will get, this is x, and y will be shifted right, so z will come here, y will come here, right, t2 will come here, then what is the right child of z? It is t4, right? Right child of z will be the left child of y, so this will become t4, then t3 will remain here only, and t1 will remain here only. Okay, now we will do left rotation on x, so x will be rotated left. Okay, so what will happen, let me draw it here, z will come on the top, x will come here, t1 subtree will remain here only, t3 subtree will come here, then y will come here, and t4 will come here, and t2 will come here, and this will be balanced. Okay, so this is what we are going to do. Now let's look at its actual implementation. So now if we look at the actual implementation, so see here, first of all, this is the function which we need to complete. This is the node which root of the binary search tree or the AVL tree, and this is the data which we want to insert. If node is null, means this is the first value which we need to insert, then node is equals to new node and data. So this is a constructor function which is defined in the driver code, where you pass the data. So a node will be defined, its height will be defined as 1, and left and right subtree will be given 0 or null pointers. Okay, and then we will return this node only, because this is the new modified head of the or root of the AVL tree. Now if the data is to be inserted is greater than current node data, then we will insert it on the right subtree. So right node right is equals to insert to AVL tree. I'll recursively call this function node right and pass the data. Now understand one thing, we are from this function we will be passing the modified root or modified root node of the AVL tree. Okay, so at every step, see, if I am inserting in the right subtree, then that right subtree's root node, okay, whatever that it may be modified, so I want to get it back into this pointer only. So I am writing node right is equals to insert this. Okay, because this will also be returning pointer to the root of the right subtree of the current node. Okay, then else if data is less than the current node data, then recursively call the left subtree. Otherwise if it is same, then simply pass the node. Okay, if that node data and the new data which we want to insert is same, then simply call insert it. Okay, so finally what will happen is we will recursively go below the tree according to the rules of the binary search tree, and at some point of time we will reach a null node. Okay, this condition will occur either when we will reach the root node of a binary leaf node of a binary search tree and then null child, or when initially the tree is empty. So when we will reach the leaf child, we will make a new node and return it. Okay, so after completing this process, the height of the current node will be updated. It will be 1 plus max of height of left child or height of right child. Okay, we will update its height also. Then we will call for the balance of the current node. So now this is to insert the node. Now during backtracking, we will update the height and check for the balance of each node. Okay, so what is the balance, how it is checked? So get balance is if node is null, return 0, otherwise return height of left subtree minus height of right subtree. That is the balance factor. Okay, and what is the height function? If n is null, return 0, otherwise return the height parameter from that node. Okay, so after getting the balance factor, if the balance factor is greater than 1 and if the data is less than the node left data, now understand one thing, if the balance factor is greater than 1, see, if the balance factor is either -1 or 0 or 1, then the tree is balanced from that node point of view. If it is not none of this, then it is imbalanced. So balance factor can be either greater than 1 or balance factor can be either less than -1 for a node when it is imbalanced. Now what is balance factor? Balance factor is height of the left subtree minus height of the right subtree. So if it is greater than 1, it means height of the left subtree is greater than height of the right subtree. It means the new node which was inserted is inserted in the left subtree only, because before inserting that node my tree was balanced, because after every insertion I am balancing my tree. So if the balance factor of a particular node is greater than 1, it means height of the left subtree is greater than height of the right subtree, and the new node is inserted in the left subtree. Okay, so now there can be two cases. Let's say this is x, this is y. Now it can be inserted on this part or on this part. If it is inserted here, it will become left case. If you remember, if it is inserted here, it will become left case. Now when it will be inserted here, when the value of the node to be inserted, the value of the new data value which is to be inserted is less than the left child value of the current node which is imbalanced. Okay, this balance factor is greater than 1. So if the new value to be inserted is less than y, then it will be inserted here, it will be left case. If it is greater than y, it will be left case. Okay, and the balance factor is greater than 1. So if balance factor is greater than 1 and data to be inserted is less than node left data, so this is my node, this is my node left, that is the left child. If the data inserted is less than this, it will be inserted here, and if balance factor is greater than 1, it is left case. In left case, what I do right rotation on the node, on this node. Okay, is this much clear? Similarly, if balance factor is less than -1 and data is greater than node right data, then do left rotation on node. This will basically give you right case. Okay, you can draw and have a look. If balance factor is greater than 1 and data is greater than node left data, okay, this is node left. If balance factor is greater than 1 and new data is to be inserted is greater than this, then it will be inserted here, it will be left case. So first of all, I will do left rotation on the left subtree left child and store that new modified root of the left child here, and then I will do right rotation on the current node, and then I will return the modified node. If balance factor, this is the fourth case, right left case, you can draw and check it. Okay, and finally we will return the let's say it is none of these cases, so tree is balanced. So if it is none of these cases, I will return the node simply. Now let's look at these left and right rotation functions. So let's look at the left rotation function. So see, basically x is the root node, okay, which is imbalanced. Okay, so let me write down with respect to this so we can understand better. Okay, now y is the right child of left. Okay, so y is the right child of left and t2 is the left child of y. T2 is the left child of y. T2 means that's a subtree. Okay, and then they have done nothing. Okay, so basically see, here they are doing a left rotation on x. Okay, so let's say this is T3 and let's say this is T4. If I do left rotation on x, my y will come on the top. Okay, now y will come on the top, x will come here, T4 will come here. Okay, T3 will come here and T2 will come here. Okay, now tell me what are the things that have changed. X became the left child of y, y's right child is T3, so T3 is not changed. T4 is the left child of x, T4 is not changed. T2, which was the left child of y, now became the right child of x. Okay, so T2 has changed. That's why they have taken only these values. X is the current node, y is the right child, and T2 is the left part of y. Why I have taken a pointer to that? Because now it will become the right child of x. Look, y left is equals to x, the left of y will now become x, and that's why I have stored the y left before only, so that I do not miss it. And the right child of x will now become t2. Right child of x will now become t2, and the height of which subtrees will be modified. Okay, so the rotation is complete, but we need to modify the height. Will the height of T3, any node of T3 will be updated? No. Will the height of any node of T2 will be updated? No. Will the height of T4, any nodes in T4 will be updated? No. Height of X will be updated, yes, because now it has T2 as a child, and height of Y will be updated because now it has X and T4 as a child, okay, in its subtree. So X height will be 1 plus max of left and right, and Y height will be 1 plus max of left and right. And then finally we will return Y, because this is the new root of this subtree, okay. And similarly you can have a look at the right rotation by taking one example. What will be the time complexity? See, first of all, we are doing insertion. How much time it will take? It will take log n time. Why? Because it is balanced binary search tree. So if there are n nodes, the height can be at max log n, okay. And in binary search tree, at each step we either go or left or right, and then we either go left or right, and then when we reach the leaf node, we insert the respective value, okay. So for inserting, it will be log n. Plus, during backtracking, we check whether it is balanced or not. For checking whether it is balanced or not, we calculate its height. Now for each node, we update its height as we go up. So it takes constant amount of time. And rotation also takes constant amount of time, because if any node is not balanced, there are at max 2 rotations required. Okay, so this is the log n time which we require to traverse below, and then again during the backtracking. Okay, what would be the auxiliary space? This will also be equal to log n, or you can say big O of height of tree. Why? Because we will be calling the recursive functions will be so those recursive functions will require a stack which will require this much space, and also the new values which we are inserting will require this much space. Okay, so this will be the auxiliary space, and this will be the time complexity. Now let's submit this code. Let's submit it. So we have solved this question successfully. I hope you have understood this solution completely. Thank you. Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is Pascal triangle. First of all, let us start by understanding the question. What does question say? Given a positive integer n, return the nth row of the Pascal's triangle. Pascal's triangle is a triangular array of the binomial coefficients formed by summing up the elements of the previous row. So basically, there is a triangle which is basically called Pascal's triangle, which is made by following a certain condition, and in that we need to return the nth row. Okay, the elements can be large, so return it modulo 10 to the power 9 plus 7. So the values in the nth row can be quite large, so we need to return them modulo 10 to the power 9 plus 7. So this is basically Pascal's triangle, in which this is the first row which has element 1, this is the second row which has element 1 and 1. Then if you can see, the first row has 1 element, second row has 2 elements, third row has 3 elements, fourth row has 4 elements, fifth row has 5 elements, and so on. Also, in first row there is only single element 1, in the second row there are 2 elements 1 1. From the third row onwards, the first and last elements are 1, and other than those elements, the remaining elements are made by summing up the 2 elements from the above row. Okay, so if you look here, so this is 1, this 2 is made by summing these 2 elements, and this is the last one. If we look at this row, then this is 1, this element is made by summing up these 2 elements from the previous row, this element is made by summing up these 2 elements from the previous row, and this element is 1. So first and last elements are 1, and the remaining elements made by summing up the 2 elements, one from the left side and one from the right side from the above row, and in that way we get the complete triangle. For example, if n equals to 4, we need to return the 4th row. This is the 4th row. The values in the 4th row are 1 3 3 1, so we need to return 1 3 3 1. Okay, 4th row of Pascal's triangle is 1 3 3 1. Similarly, 5th row is this. Complete the function nth row of Pascal's triangle, which takes n as input parameters and returns an array representing the answer. You don't need to print the answer or take input. So basically we need to return an array which represents the n elements of the nth row. Okay, the expected time complexity is big O of n square, and expected auxiliary space is big O of n square, and the constraints are given here. So if we think about solving this problem, so see, let us observe the Pascal's triangle again. So the first row has only single element 1, the second row has two elements 1, 1. From the third row onwards, the first and last elements are 1, and the remaining elements are made by summing up the two elements from the above row, one from the left side and one from the right side. So basically, if there are two elements, I will write down the three elements on the below row, 1 here, 1 here, and 1 here in between the gaps. Okay. So this element will be made by summing up these two elements, that is 1 plus 1, 2, and the last element will be 1. So the first row has one element, the second row has two elements, the third row has three elements, the fourth row has four elements, the fifth row has five elements, the sixth row has six elements, and so on. Okay. Now if we write down the fourth row, then the first element is 1. This element is made by summing up these two elements. So 1 plus 2 is 3. This element is made by summing these two elements, that is 2 plus 1, 3, and the last element will be 1. The fifth row, first element is 1. This element is made by summing these two elements, that is 4. This element is made by summing these two elements, that is 3 and 3, 6. This element is made by summing these two elements, that is 4, and the last element is 1. If we look at the sixth row, the first element is 1. This element will be 4 plus 1, 5. This element will be 4 plus 6, 10. This element will be 6 plus 4, 10. This element will be 4 plus 1, 5. And the last element will be 1, and so on. Okay. So basically, we are given n, that is the row number in the input, and we need to return the nth row of the Pascal's triangle. So now how can we implement this? So basically, see, what we can do is we can take two arrays. One is, let's say, A1 and one is A2. Okay. A1 will be used to generate all odd rows. Okay. And A2 will be used to generate all even number rows. Okay. So now basically what we can do is we can initialize A1 with 1. There is only one element describing the first row, and A2 with 1, 1 describing the second row. Now from A3 onwards, we can see this is the third row. It will be stored in A1 because 3 is odd. Now this can be generated using this A2, right? Because initially A1 is 1 and A2 is 1, 1. Now I will use A2 and generate A3, which is nothing but what? 1, 2, 1. Now, so basically this is the third row which will be stored in A1. Okay. Now the fourth row will be stored in A2 and it will be generated using this A1, which is basically storing the third row right now. So A2 will be equal to 1, 3, 3, 1. Okay. Now how will we do this? So basically whenever I am generating a particular element in a particular row, if that element is the first element or the last element, its value will be 1. If that element is not the first element or the last element, let's suppose in the ith row I am generating jth element, then that element will be equal to the sum of the elements of j minus 1 index and j index from the above row. So what I'm trying to tell is, see, A2 is basically representing fourth row right now, right? Now let's say I want to generate fifth row which will be stored in A1. Okay, so the first element will be 1. I know there will be 5 elements. Okay, so the first element will be 1. What will be second element? So A1 of I will be equals to A1 or A2 of I minus 1 plus A2 of I. Okay, so the first index element will be equal to sum of this and this. Look here, the first index elements will be sum of 0 index and first index. Okay, so that will be 4. The second index element will be sum of first index and second index. First index and second index sum will be stored at second index. That will be 6. Similarly, third index element will be sum of second index and third index from the A2. So this will be 4 and the last element will be 1. Now using this and using this equation, I will generate A2. So A1 will contain the elements of the odd row, A2 will contain the elements of the even row, and I will keep on generating until I reach n. And then finally I will return the row containing the elements of the nth row. Let's look at its implementation. So if we look at the implementation, so I have taken two rows A1 and A2. This will hold the values of the odd number of rows and this will hold the values of the even number of rows. And I have taken one mod 10 to the power 9 plus 7 to take mod at different places. First of all, I have initialized the first row in A1 which is equal to 0. There is only one element, and A2 of 0 equals to A2 of 1 equals to 1, which is describing the second row. Then from third row up till nth row, I will be generating new rows. So if I is equals to even, if I modulo 2 is 0, so I will be storing the answers in A2 because the row number is even, and I will be using A1 as the previous row. So in the ith row there will be I number of elements, so there will be from 0 to I minus 1. Okay, if it is the first element or if it is the last element, simply write a2 of j equals to 1. If they are not the first or last element, then a2 of j will be equal to a1 of j minus 1 index and j index element, their sum from a1, okay, because that is the previous odd number row having values, and modulo mod. Similarly, if I is even, so we will be storing the values in a1 and using a2 as the previous row. So for j equals to 0 to I minus 1, if it is the first or last element, make it equal to 1, else make it equal to a1 of j equals to a2 of j minus 1 plus a2 of j modulo mod. Then finally I will store, since they want the answer to be stored in vector, so I have taken one vector answer, and in that I will if n is even, so if the row number which I need to return is even, then my answer will be in a2. If n is odd, my answer will be in a1. So for I equals to 0 to n minus 1, answer dot pushback a2 of I or answer dot pushback a1 of I, and finally I will return the answer vector. What would be the time complexity? See, I am generating all the elements from the first row to the nth row. First row has one element, second row has two elements, third row has three elements, up to nth row has n elements, which is nothing but n into n plus 1 by 2. So the time complexity will be equal to big O of n square. And what would be the auxiliary space required here? See, I am using only two arrays, a1 and a2, and vector answer. Okay, this will contain n elements. A1 and A2 will also contain order of n elements. These are array of size n plus 1. So the total auxiliary space here will be big O of n. I hope you understood it. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.
Hi and welcome to Geeks for Geeks. Today we would be discussing a really very interesting question, which is shuffle integers. So before we move forward, first let us talk about the most important feedback of this problem. The solution for this problem is non-intuitive. You don't really have an intuitive based solution rather than an observation which is absolutely very small, and it won't make sense to you if you are an intermediate or a beginner. Okay, this is the first step. The very next learning you can get out of this problem is, if you were not able to deduce the solution from your pen and paper, you would realize that investing more than an hour or 30 minutes does not make sense, okay, because you are in the wrong direction. So the learning that I want to tell you is that what you can do is, if you see up a problem, you keep hustling over it until you have a direction to move. If for 15 minutes you are blank, turn up to the hint section and then you would have a direction. Okay, so kindly do this. Don't just like take a problem and just think over that problem for the next one day. This is not a thing, and only DSA is not required for interviews. Other aspects excluding DSA are also important. So this is the small learning that I wanted to just punch in at this point of time. Now let us just move back to the context that we were here for. So the problem is pretty easy to say. We are given an even sized array. So we are given an even sized array. Let's say 1, 2, 3, 4. What they want is, let's say this is the array, and at all times the size of the array, that is n, it would be even. This is given. N modulo 2 would be equal to 0. This just means this. So what they want is, they want you to think that this array is divided in between, and what they want is the first element of the first array and the next element should be the first element of the second array, and this third element should be the second element of the first array and the second element of the fourth array. Let's just have it again. Okay, let's just have it again with some more. Okay, 1 2 3 4 5 6 7 8. We need to divide the array and think that these two are different arrays. This is, let's say, array A, and this is, let's say, array B. What they want is first element of the first array accompanied by first element of the second array, then the second element of the first array, and the second element of the second array, third element, third, and then 7, then 4, and then we have something like 8. So you might have guessed, but let me just tell you, the numbers are contiguous. This is not mandatory. The numbers can be random and they don't follow a sorted ordering. The sorted ordering and contiguous is maintained in the sample test cases or visualization to make you realize that how so on earth this array is being formed. Okay, so the numbers can be random and they can be in any order. Okay, this is given. Now you don't really have a direction to move forward. You try to think that yes, I would have kind of 2-pointer thing. Okay, I would have a 2-pointer. The very first solution, this just gives me to the very first solution. I would go to the very first point, that is this one, and go to nth by 2, and then I would have the very first element, then this element. After taking that element, I would move forward the pointer. Okay, then we have 2, then we have 6, then we move forward the pointer, and then we have 3, then we have 7, then we move forward the pointer to something like this. Then we move forward the pointer, 3, 7, this would be 4 and 8. After this has exhausted, so we are at n. So we need an auxiliary space, okay, to form this. So the time we are iterating on each element exactly once. So the time complexity would be big of n, and the space complexity is also big of n, because we are using an auxiliary data structure. Okay. Let's say now your interviewer is telling you that how on earth you can do this without using any auxiliary data structure. So if I'm not allowed to use an auxiliary data structure, I'm left with variables, because variables contribute constant to the time space complexity. मतलब जितने भी variables define कर लो, time complexity में वो constant ही contribute करेगी. If you didn't know, now you know. Okay. So now I would try to think in terms of variables. You can do that on a pen and paper. After you have a bigger array, let's say you just take 1, 2, 3, 4, 6, 7, 8, 9, 10, you would come to the conclusion that this is not possible, or this is becoming highly complex. Okay. So now this part is not intuitive. Like this transition from this point to the current solution is not intuitive. You need to keep this in mind. The only intuition you have is to notice that the array elements are less than equal to 10 to the power 3. This is the only small thing, because generally the elements are less than equal to 9 or 10 to the power 18 or something, but here the element size is less. So if you are a very keen observer or a very sharp observer, you would be able to have this conclusion. Other than that, if you are a regular programmer like me, you won't really come to this. Okay, so now the solution is that we just use the given array. Like we have 1, 2, 3, 4, 5, 6, 7 and 8. Now let's just talk about the number 10 to the power 3. The number can be, the constraints is from 1 till less than equal to a of I would be less than equal to 10 to the power 3. What is basically 10 to the power 3? 10 to the power 3 just implies that the 2 raised to the power is how much? Like if you raise to the power 2 raised to the power 10 is 1024. Okay, 10 to the power 3 is how much? 1000. So 1024 is nothing but 2 till 10 to the power 10 at max. So you know that to store this elements, like if there are 32 bits, okay, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say the first 5, okay. So if you observe, let's say these are 32 blocks. This is 32 block. So the last 10 blocks would be used to store the number. What do I meant by this? Like if you, let's say we have like something 1, 2, 3, 4, 5, 6, 7, let's say. So less than 8. Less than 8 means 2 to the power 3. So to store all this in the binary form, only the last 3 bits would be used. Like 1 can be represented something like 1. This can be represented like 1 0. This can be represented like 1 1. This can be represented like 1 0 0. This can be 5 can be represented as 1 0 0 1. This can be represented as 1 1 0. This can be represented as 1 1 1. I just meant this. So to store a value less than 2 to the power 3, we would be only using the last 3 bits. Okay, last 3 bits. Other than this, you won't ever require. So if the given number is less than 2 to less than equal to less than 2 to the power 10, then you know that only the first 10 blocks is used. Now let's just see what I meant to say really. Let's say we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have 7. Let's just take 6. Okay, as of now, let's just say that the elements would be less than 8, which just implies that the elements would be less than 2 to the power 3. Okay, so just like in reality it is 2 to the power 10, but we would take here 2 to the power 3, and in this would be replaced with how much? Let me just tell you that also. This would be replaced by, let me just tell you, the original one is that less than equal to 1000, and this is less than equal to 2 to the power 10, but for simplicity we are taking less than 8 and 2 to the power 3 to just showcase you. Now let's just say that there are 6 blocks, 1, 2, 3, 4, like let's just have 6. Okay, let's just have 6. Let's say this is 1, 2, 3, 4, 5 and 6. So we have 6 blocks. Okay, so we know that to store numbers less than 8, we only need the last 3 blocks. So we would require 1, 1 0, 1 1, 1 0 0. We would require 1 0 1, and we would require 1 1 0. So what we would do is we would store the auxiliary thing. We would store the auxiliary thing in the first 3, like last 3 blocks is used. So we would store the first 3 blocks here. So now we know that this needs to be, like I want to merge which numbers? I want to merge 1 with 4. So what I would do is, I would say C4, 1, you use this block, and 4, you kindly use this block. So 4 would say, okay, just have me here. Give me this block. And by doing this, at this position, you would be storing 1, 4 by using, like you would be able to store 2 variables in a single position. Okay, like combination of 1 and 4 can be stored in this format. But how on earth we are doing this? Let me just tell you that also. Let's say we want to store 1 and 4. So what we would do is, we would first have 1. That is, the representation is this. let's say we say that this element would take the first 3 blocks, this element would take 4 would take the next 3 block. Okay, now what I want to do is 4. So I want the representation to be something like this, and what I would do is I would add zeros here. Let me just have this in different color to show you how am I having the zeros. I would have zeros here, and now if I do a OR, I simply do a OR between them, that would result something like this: 1 1 and 0 0 1. And if you observe, the first three bit is 1 and the last 3 bit is 4. Again, how we would be retrieving x and y, that is another task, but as of now just understand how we are keeping x and y. Now, how we can add zeros in the end. So if we write 1 0 0, left shift by 3, it would be simply 1 0 0, and in the end 3 values would be added, which is nothing but 4 left shift by 3. So we can say that x OR with y left shift by 3. This is how we would be storing the combination of x and y. Store x and y. This is how we would be storing x and y, by doing left shift. So let's just first store x and y everywhere. So 4, this would be stored as 1 0 0, this would be 0 0 1. So let's just have everything again. So this would be 1 0 0, and this would be 0 0 1. This would be the value. This value would be 0 1 0 and 5. What is the binary representation of 5? 5's binary representation is 4 plus 1, that is 1 0 1. So 1 0 1. 3's representation is how much? First we would be storing 3, that is 1 1, and we would add here 0. So let's just have here 3 and 6. We want to store that. 3's binary representation is 1 1, and we would have 0, and the next number is 6, which is how much? 4 and 2. So 1 1 0. Okay, 1 1 0. So now this is 3 and 6, this is 2 and 5, this is 1 and 4. This is how we would be having. Now the task is to retrieve the value. How we can retrieve the value? So now let's say from this number I want to retrieve 1 and 4. Okay, I want to retrieve 1 and 4. Okay, so what I would do is I need simply the last 3 bits, and all other bits are useless to me. So what I would just say is, so if I want to retrieve the last 3 bits, this is 1 0 0 0 0 1. This is how you do problem solving. So if I have something like this, okay, if I have something like this, like let's say this is 1 1 1, and rest these all are zeros, and I do an AND operation with this. So this would result in 1, this would result in 0, this would result in 0 0 0 0, and this is what? This was this element, that is 1. So this is how we are getting x. So we can retrieve this x. Let's retrieve something more. Let's say we want to retrieve this value. Okay, 2 and 5. So 5 was 1 0 1. 4 plus 1. Okay. So 1 0 1 0 1 0. 1 0 1 0 1 0. 1 0 1 0 1 0. Let's say I want to retrieve the last 3 bits. So what I can do is, I can simply do a AND with 1, 1, 1, and these all values would be different. And if I do, I would be able to retrieve, if I do a AND with something like this, this would be 1, this would be 0, this would be 0, 0, 0, 0. And we have the value that is 2. So we are able to retrieve x. But how on earth we would have this value? This is nothing but 2 to the power, like how many ones we want. If we want 2 ones, this is, what is the represent, like what is this? 2 to the power 0, that is 1. 1 plus 2 to the power 1, that is 2. 2 to the power 2, that is 4. So this value is nothing but 7. 7 is what? 7 is 2 to the power 3 minus 1. So number of ones we want in the binary representation, let's say we want something like 1, 2, 3, 4. This is nothing but 2 to the power 4 minus 1. What is 2 to the power 4 minus 1? 16 minus 1 is equals to 15, and the binary representation of 15 is 2 to the power 0 plus 2 to the power 1, 2 to the power 2, 2 to the power 3. Is this value equal to 15? Yes, this value should be equal to 15. 2 to the power 3, 8. 8 plus 2 to the 4 plus 2 plus 1, which is equals to 7 plus 8 is equals to 15. See, we are having this value. So this value can be generated by this. This is a simple idea, like it is used a lot in bit manipulation. Okay, just see all the small ideas. So we got the value of x. If we want the same values as y, what we can really do is, we can just left shift by 3. Like 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This was 1, 0, 1, 0, 1, 0, 0, 1, 0. Getting the y is easier. So we can just left shift by 3 and we would have something like 1, 0, 1. Everything has right shift by 3. So by doing right shift by 3, we are having the value of y. And now we can start putting up x and y. So we have all the combinations of x and y at this point, and now we can just retrieve the result. How we can retrieve the result? The very first one was to have AND with 2 to the power this minus 1. Okay, and this would be done. 2 to the power 3 minus 1. We would just do an AND with this and we would have x. To get y, we would simply do left shift by 3. So now we have x and y. Now where to put x and y? We need to start putting up x and y. So now I can retrieve the value of x and y 3 and 6. So what I would really do is, I would start putting elements in the back. Why not in the front? Because if I put in the front, then this value would be erased. Why? Because 1 and 4 needs to be kept at this point. Here I would write 1, here I would write 4. So this value is lost. This value is lost. So to have a cunning implementation, we would have from the back, because these all elements are not important to us. The values that holds the data are this side, the left hand side, not on the right hand side. So we would start putting up elements on the right hand side. So on the right hand side, we have 3 and 6. So we would write here 3, we would write here 6 from n minus 2, and we would go here. So we would point at the half. So we would start from the half and we would go to the front. So now we would start from this. We would have x and y. We would have x and y. Again, we would have this value. We would put up x and y. Again, we would have this value. We would put up x and we would put up y. This is how we are doing from the back. Now let's move to the implementation, and this would make more sense. I'm a very lazy person, would be replacing the ARR with A, and now we would be starting off. So we just need to go till the middle element. Okay, so because for int I is equals to 0, I is less than n by 2 and I plus plus, and that value would be A of I is equals to A of I left shift by 10. Like 3 should be replaced by 10. Okay, so you are moving everything on this side, and now I would do a OR to keep that value on that side. So I would do A of I is equals to A of I or with A of I plus n divided by 2. Okay, so now first one move to the these are the two blocks. This is the first 10 bit, this is the last 10 bit. First that value moved to this value and this block is empty. Now we do an OR, so this block would be filled. Okay, this is done. Now we would have a pointer to the last element because we would start putting up elements in the last. For int I is equals to n minus 1. Then we would start from the last. Okay, I showed you, I made a diagram like this and started moving on the right. So for int I is equals to middle minus 1. Okay, that is n divided by 2 minus 1. I is greater than equal to 0 and I minus minus. At this point, we will first retrieve the x. X is equals to A of I. We would do a AND with how much? 2 raised to the power 10. 2 raised to the power 10. 2 raised to the power 10. 2 raised to the power 10 minus 1. Okay. So now to raise 2 to the power 10, a simpler, easy technique is, this is again a small learning, 1 left shift by 10. This is equal to 2 raised to the power 10. Okay. Now we would retrieve the y. Y is equals to a right shift by 10. Like the first, so I told just move this block outside. Now this block is remaining. So this block was that element. So we are having x and y. Now we are able to retrieve x and y. So we would keep that element in the end. A of j is equals to x. A of j minus 1 would be y. A of j minus 1 would be y. And j minus 2 is equals to, like, 2 elements are done. So now we would move here. That is it. And now let's just compile and run and see how many errors are we making. Now you were this long for this video. Just let me be honest with you. When I solved this problem, like, it has been years since I'm coding and it has been years since I'm teaching. Okay, being a little bit intermediate at programming, I saw that I'm not able to think of a solution intuitively. So I took it by ego and I didn't see the solution for an entire day, and I kept thinking until and unless I realized that I earlier thought that this problem is of graph, then I thought DSU, and then in the end when I saw the small constraint, I came to the conclusion that this problem is of bit manipulation. So it took me a lot of time to solve this problem. This is non-intuitive. So when I solved this problem, this is a completely different direction. So that's it for today. Thank you and have a nice day. Hi and welcome to Geeks for Geeks. Today we would be discussing an easy problem of recursion. So basically it is not an easy problem as a whole, but if you are learning recursion, this problem is a good start, to be honest. So let's start off with this problem. This problem tells us that we are given a number. Let's say we are given the value 16. So at this next instance, what they want is, they want us to subtract 5, that is 11. And then they want us to subtract 5 again, 6. And we need to keep subtracting until the value becomes less than 0. After that, we need to again start adding. Okay, so if we start adding, this would somewhat again become 1. This would become 6, this would become 11, this would become 16. Okay, so this is what they want basically. But they are telling us that we can't really use loops or something. So we need to use recursion. So whenever, like, this is a common pattern, whenever the question mentions that can you do this without using loop, the alternative to loop most of the time is recursion itself. So now a small observation at this instance is, if you see up, that this if you exclude this part is nothing but a reflection of this part. What I meant is that if I can trace back and I would get 1, then I can get 1, I can get 11, and I can get 16. So instead of me going down, I can say that they want me, just looking the problem statement in another way, I need to go up. I need to go up. And if you observe, first we are coming down this, and then we are just going up. And we can kind of use the same idea. Okay. So we have a number n. We have a number n. Okay. And we would call for n minus 1. This is n minus 5. This could be understood from the recursion that this would be the state. Okay. We would call for n, and when n is called, I want it to insert. Like what I meant to do is, like what I can say is, whenever a number is there, I want it to first insert. So I would say insert n. This is done. And then call for, let's say this is n, this is rec, and then call for rec of n minus 1. Then minus 5. This is also understood. Like we are having 16. First we write 16 or print 16. Then we go for 16 minus 5. Then again we print 16 and then we go for 11 minus 6. Instead of print, I am writing insert because we need to return as a vector itself. Okay. Good enough. And now when we hit n minus 5, we want to print it. But we don't want to print it again. So what I can say is that here we are inserting, and then I can just inject an if statement at this point, that if n is less than 0, return. Why? Because it is n, my minus 4 would already be returned. But now what I want is, I want it to insert this value, that is 1. Again, after the recursion, after 1 is done. Like this is when in the process of going back, we want it to insert. In the process of going back, this seems like this is stealed recursion. Okay, like after the recursion is complete, in the process of going back, we want it to insert again. So I would just say insert or print again. N. Now let us just visualize this again if we want. So now see, first we would have rec of 16. This would first print, as this is not less than 0. So this would call for rec of 11. Then this would call for rec of 6. And then this would call for rec of 1. Again this is greater than 0. Again we would call for rec of minus 4. So if you see 16, 11, 6, 1, minus 4 would get printed from this statement. Okay. Now, when this thing we would handle explicitly, that if n is 0, return. And then we would, in the process of coming back, when this is done and this if statement is not getting executed, again we would insert n. This does the magic. So in the process of coming back, we would insert 1. Again, this if statement is done, this is done. So in the process of coming back, we would insert 16, then 11, then 16. And this is how we are getting this output. That's it. Now let us move to the implementation, and this would be done itself. So we would have something like vector v. So I'm just doing everything in the global space because of my previous experiences. That is, I'm a competitive programmer. So let's just move forward. So v dot push back. First we insert the value, current value n. Then if n becomes less than equal to 0, then we would return that. After this thing is done, in the process of going back, we want it to insert. Okay, but before that, let's just call for, instead of rec, this would be pattern. So that rec was completely, that is recursion. I just use rec for every time. And this would be n minus 5. And in the process of coming back, we want it to insert the value again, that is push back again. And then after everything is done, just return B. Okay, now just compile it and see how many errors are we making. Seems like no error is being made. Let's just submit and see if we can get an AC. That's it for today. Thank you and have a nice day.
Hello people, we are again here to solve the problem of the day. Well, today we are having a detect cycle using DSU, that is disjoint set union. Let's read the question and try to see the approach. The question is saying, given an undirected graph with no self loops with V from 0 to V minus 1 nodes and edges E, the task is to check if there is any cycle in the undirected graph. Pretty simple problem statement. We will be given a graph in which we will be having an integer v, denoting that we are having nodes from 0 to v minus 1, and we'll be given the edges. Simple, right? And specifically in this question, it is mentioned that we should be using disjoint set union approach for solving this question. Let's see how we are going to approach this problem. Okay, the test cases are here again. Let's see. Taking this example up. As you can see, in this graph, there is one loop, right? There is one loop that is existing. That's this one. So eventually the answer has to be true. And in this one, you cannot find any loop of such kind. Thus the answer has to be 0, that there is no loop that is existing in this graph. The question statement is pretty simple. Let me quickly tell you a little about DSU if you don't already know it. DSU or disjoint set union is actually, you can call it as a data structure, or it is more similar to just like you have a stack and queues. It is not actually a data structure, but it is a concept. And once we use DSU in graphs, it makes many of the things very, very efficient. So first of all, in DSU, there are two functions. First is find and second is your union. Correct. So what do we do in DSU actually? We make up sets. Okay, we make up sets, and the set is in form of trees. What am I saying? Let's see. Okay, assume this like these are a bunch of nodes that are given, and they do have some edges here. Correct. Now, if we need to create a DSU out of it, what do we actually need to do? Okay. Let's say you have two more data structures. Let's go with parent first. Okay, so parent is going to be an array that you have to make. What will it be doing? Okay, let's say we are starting with 1. If I give you this node 1 and I ask you what is a parent of 1, obviously you would say that 1 itself is a parent because we are not associating any node with it, right? So we can say 1 is the parent, right? Initially, if we see it like this, at 1th index, what will be the value? 1. That means 1 is a parent of 1. Now, if I take 2 and I make union of this, that means there was one set in which only 1 was there. Now I'm making up a set with another, you can say, node, and I'm making union of these two. So if I'm doing union, what will actually be done is either 2 will be made a child of 1 or vice versa. So here as the option, let me just make up this connection. I will introduce 2 as the child of 1. Fine. Now what will happen at the second index? What will be written? 1 will be written. That means if we are having 2 here, 2 is actually belonging to this set in which the parent node is 1. All right. And how are we going to know? How are we going to know that? Now we know what is the function of union. Whenever we keep on attaching the nodes to it, it will be making them either the children or the parent, right, of sets. And we can even take 2 trees. Assume this is one tree, correct? We have 1 and 2, and this union was there, which was 3 and 4. So 3 and 5, right? In which 3 was parent and 5 was child, something like that. Now when we put union of these two, we just have to make one thing as parent, another as child, and depending upon what is the optimal thing, you can study it in depth. If I have to make a set of it, it can look something like this, right? Now we know what union function is doing, correct? It is composing of sets. And what is the meaning of this find function? It will tell of which set you are belonging to, that node is belonging to, or what parent does it have. So if I say find 3 here, what is going to be the answer? After this union, what is going to be the answer? The answer will be 1. That means 3 will be storing 1, 5 will be storing 3. And eventually, okay, let me first tell you about 3. When we have find 3, what will we get? We will get 1 directly because it is attached to 1. 1 will be the parent. 1 will be the parent. Now if I ask about 5, does 5 belong to this row? What will be the answer? The answer that find will return is going to be 1. But how will find approach it? The function find will approach it by saying that 5 is having 3 as a parent. Once it will reach 3, it will see that 3 is having 1 as a parent. Then it will reach 1. Then it will see 1 is 1's parent. That means this is the point when your index and the node you are saving becomes equal. This is the point where you have to return in find. Okay, that means at this point you know that which what is the parent of that particular set. Done. Now again, okay, assuming this set was not made yet. This set was not made yet. Then if I ask you about this one, this set, now I'll say find 3. What will I get? I'll get 3 at this position. Okay. Now if I say find 5, what will I get? I'll get 3 because union is not formed and this is an individual set here. Fine. I hope now the terms find and union are clear to you and what are they doing, and parent you can form an array of that to keep a track of all the sets. Okay, so this was a little brief about DSU. How we are going to make use of it in our task, that is to find cycles. Assuming this is a random graph that I have taken, that is given to you as the question. Now what do we have to do? We have to compose these sets. Okay, now let's say it is like this. Fine. So what will you do? You will start composing your sets. First of all, you will have a parent array in which every node is going to be their own parent because no set is made. Then you would start. Let's say we picked up this edge. Now we have to make up this set, correct? 1 will be parent, right? Or 0 could be parent depending upon your choice. Then you need to keep on adding to this set. Okay, let's say we now picked up this edge. One more set created, right? Now, whenever we are encountering a new edge, that means now I have to include 4. Firstly, what I'll check, to what set it belongs. If it does not belong to the same set that I am in, that means I have to include it and I have to put union. So if you are here in this set and you are seeing 4 here, you see 4 is not in that set, not in the same set. That means what do you have to do? What do you have to do? You need to make up, okay, let me take this path only. Okay, you need to make up this set. That means that it will also be included like this, correct? Now this will be the set. Now again, this cell will be having one single parent. Let us assume that 2 will be the parent. And now this is the cell. That means it has expanded. Now once we are here, we need to see that the set we are making, if it encounters any node that actually is making a loop. Because if you are here at 2, you will then check for 1 as well. If you're picking up this edge, you will first of all check what? You will first of all check that when we're taking this up, it is a new node. But once you are here, once you take up this edge, 1, 4, you will see that it is belonging to the same set. Once you get to this position, that means the cycle is present in the graph. And if you take up every edge of your graph and you do not encounter this situation, That means each and every edge actually may be belonging to separate sets. If that is the case, then there will be no cycle. If you encounter such condition, if you are here, if you come till this point, you can say that cycle is there, and simply you can return true in that question, right? Pretty simple. By using find and union, it makes so many concepts really easier. We do have different methods for doing the same thing. We can use hash maps, or we can use different approaches for finding out whether there is cycle or not. But DSU is found to be usually most optimized approach. Let's see the code for the same. Okay, so here is the code. Let's quickly go through it. You can see this is the implementation of DSU, and here is the main logic of the question. We are simply making up parent and rank. Rank is there just to optimize your union function more. Okay, now we are creating up a set initially for our implementation. Then I'm going through each and every edge. This loop is for picking up each and every edge that is given in the question. Now I'm just checking up. I'm finding out if that edge, that means if it is u to v, then if we are checking the same thing with v, we are checking the same thing with u. What we are saying, please find the set. That means what does find do? Find tells that what is the parent of that particular set. If the parent of both the sets are same, that means both belong to the same set. And thus, if that situation occurs, we can simply return 1. And if that is not the condition, we need to make the union. We need to compose them in the same set, right? And we have to go on further till our edges are exhausted, right? Pretty simple. Let's try to run this code. Okay, so here's the same code. Let's try running it. Okay, so it is giving the right output. Let's try submitting it against the test cases. All right. So it is passing all the test cases. So I hope you have understood the solution. And if you like the approach, surely comment that down. I'd be seeing that. And if you have any doubts, you can comment that too. We'll be responding to it. And do like the video. And keep on solving POTDs.
So hello and welcome everyone. I am Jadal Sanya, and in this video we are going to solve the question sum of dependencies in a graph. The question is labeled as easy. It does not require very much complex algorithm or intuition is not required. So this question is going to be very easy. So let's try to understand what to do in this question. So let's start. So in this question you will be given a directed graph with v nodes and e edges. If there is an edge from u to v, then we'll say that u depends upon v. So number of dependencies, that is NOD, for a node x is the total count of nodes that x depends upon. Find out the sum of number of dependencies of every node. So basically in this question we have to find out, for the given directed graph, we have to find out the total count of dependencies of every node. And whatever is the sum of dependencies, we have to print it in the output. So that is the question. The question is pretty simple. So now let's try to understand with the help of a test case so that we can have a clear understanding what does it mean by dependencies. So over here I have taken the same example which is given to us in the question, and over here in this example v and e denotes the number of nodes and number of edges respectively. So v is for the total number of nodes and e is for the total number of edges, and the edges array is given over here. So let's try to draw a directed graph out of this given edges array. So it says 0 to 2, so there will be an edge from 0 to 2. So 0 to 3, right? So this will be the edge, and 1 to 3, so there will be edge from 1 to 3, and 2 to 3. So this is how the graph will look like. So now it has been mentioned what is the definition of the dependency. Let's say there is an edge from u to v, then it has been said that u is dependent upon the node v. So the dependency of the node u in this scenario comes out to be 1 because there is an outgoing edge from u to v. So basically according to this question, the dependency is the total number of outgoing edges from a node. So let's try to mark down what is the dependency of every node over here. So let's start with the node number 0. So over here you can observe how many outgoing edges are there. I can see 2, so the dependency will be 2. For this node 2, how many outgoing edges? Only 1. For this 1, how many outgoing edges? 1. And for this 3, how many outgoing edges? 0. So what is the count? That is 2 plus 1 plus 1 plus 0, that comes out to be 4. and hence the output for this test case comes out to be 4. Right? I hope you understood what is the meaning of dependencies according to this question. Okay, so that is the question, and we have to just print the sum of the dependencies. So now let's try to understand what can be done in this scenario, how to find the total number of dependencies. So according to the definition, I can just convert the given definition of this question into a single statement, that is, you have to count the number of outgoing edges. Count the number of outgoing edges. Outgoing edges of every node. So in a directed graph, when can you think, like, what is the scenario that will say that this node has an outgoing edge? Whenever any node will have some adjacent node, at that time only that particular node will have an outgoing edges, right? So what you can do in this graph, for each and every node, you can simply count the total number of adjacent vertices. Okay, so in this question, you will be given an adjacency list. And how does an adjacency list look like for this test case? Let's have a look. So if this is the test case, then your adjacency list will look something like this. So let me just copy this entire test case over here, and let's analyze it. So in this question, the edges array has been displayed, right? But over here, according to the problem statement, according to the pseudocode which is already given, you will be passed an adjacency list. So adjacency list of this graph will look something like this. So we know that for 0, how many adjacent nodes are there? I can see 2 and 3 are the adjacent nodes. For 1, how many adjacent nodes are there? I can see only 3. So for 2, how many adjacent nodes are there? 3. And for 3, how many adjacent nodes are there? So the adjacency list contains 0, right? So on this adjacency list, what you can do, you can just iterate over this entire adjacency list, and one by one, for each and every particular node, count the size of the list. What is the size of this adjacency list? 2. What is the size of this adjacency list? 1. What is the size of the adjacency list? 1. And over here, 0. Just keep the sum of this total number and you will be getting the total count of dependencies for the given directed graph. That is how we can solve this question. Okay, I hope you understood how to solve this question. So now let's get back to the coding implementation for the same, and let's try to write down some code. So over here I've written down the code in Java, but the same can be implemented in other languages, right? So you can take the help of this code. So this is the sum of dependencies method, and in this method you have to write down the entire logic. See, as an argument, as I mentioned, you will be passed an adjacency list, right? So over here an array list of array lists that represents an adjacency list in a graph has been passed. Okay, and V denotes the total number of vertices. So now what I have done, I have taken a local variable, that is sum variable, initialized to 0. Now I am iterating over each and every adjacency list. Okay, so I'm just fetching the adjacent nodes, that is the list of adjacent nodes, and I'm just calculating what is the size of each and every adjacent node, right? Basically, what is the size of each and every adjacency list, and I'm just keeping the size added to the sum variable, and at the end just return this value of the sum variable, and that's it. Okay, no complex. So it is not very much complex to understand, and let's try to compile and run, and let's see what is the compilation. So the compilation has been completed, and let's try to submit this as well. And we can see that the problem has been successfully submitted, right? So let's try to analyze the time and space complexity. So what do you think, what will be the time and space complexity? So over here, if we analyze the time complexity, there is a for loop inside this logic, right? And this for loop will be iterating over the entire adjacency list. So how many lists will be present inside an adjacency list? The total count of the list will be equivalent to the total number of nodes present inside the graph, right? For each and every node, you will be having an adjacency list, right, inside the adjacency list. So the overall time complexity of this approach comes out to be order of V, that is total number of vertices, and the space complexity in this scenario is constant. I am not using anything extra that depends upon the size of the input test case, right? So that is the time and space complexity for this question. So that was the entire implementation and coding part for the question sum of dependencies in a graph. I hope you really enjoyed this solution, and if you really enjoyed the solution, do hit the like button and share it with your friends. So that was it for in this video, and I'll see you in the next video.
Hello everyone, my name is Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is Eulerian circuit and path. First of all, let us start by understanding the question. What does question say? An Eulerian path is a path in graph that visits every edge exactly once, and it starts and ends up at different vertices. Okay, this should be vertices. So it is a path that visits every edge present in the graph. Okay, it does not mention every vertex. Okay, it visits every edge exactly once. An Eulerian circuit is a Eulerian path which starts and ends on the same vertex. So what will be Eulerian circuit? It will be a path which visits every edge exactly once and starts and ends on the same vertex. Given undirected acyclic graph with V nodes and E edges with adjacency list ADJ, return 2 if the graph contains an Eulerian circuit, else if the graph contains a Eulerian path, return 1, otherwise return 0. So if there is Eulerian circuit, then you need to return 2. If the graph has Eulerian path, you need to return 1, otherwise you need to return 0. Okay, now there is a bit contradicting, because if there is a Eulerian circuit present in the graph, then it will be a cycle only, right? But that's okay, let's neglect that part, acyclic. So if we look at this, then this is a Eulerian circuit, because I can go from 0 to 2, 2 to 1 and 1 to 0. It will visit all the edges exactly once, and it will start and end on the same vertex. So I'll return 2. Now if I look in this, if I start from 1, I'll go to 0, and from 0 I'll go to 2. So this will be a Eulerian path, because it will visit every edge exactly once, and it will start and end on different vertices. So I'll return 1. You don't need to read or print anything. Your task is to complete the function is Euler circuit, which takes number of vertices in the graph denoted as V and adjacency list of graph denoted as AGJ, and returns 2 if graph contains Eulerian circuit, else if graph contains an Eulerian path, it returns 1, otherwise it will return 0. The expected time complexity is big O of V plus E, where E is the number of edges in the graph, and the expected space complexity is big O of V. So now if we think about solving this problem, then see, if our graph is having Eulerian circuit, okay, then we need to return what? We need to return 2. If it contains Eulerian path, then we need to return 1, and in all the other cases we need to return what? 0. Now understand one thing. What does mean? It means to have a Eulerian circuit, it means that there exists a path such that it exists, it ends and starts on the same vertex, and it covers all the edges exactly once. Okay, so there is one possibility. Let's say you have 5 number of nodes, okay, 0 to 4. So this is 0 number node, this is, let's say, second number node, this is 4th number node, this is, let's say, first number node, and this is, let's say, third number node. So this is the possibility. This is a Eulerian circuit. Why? Because you can start from any vertex. Let's say you start from 2. So you went to 2 from 2 to 4, 4 to 1, 1 to 3, 3 to 0, and 0 to 2. So you visited every edge exactly once, and you started and ended on the same vertex. Please remember, if there was a branch other than this, let's say here is one more, then this would never become a Eulerian circuit. Okay, even if it now it is like this. Why? Because you will not visit every edge exactly once. For example, you started at 2, then you went to 4, then 1, then 3, then 0, then 2. Okay, now let's say you went to 5, then to 4, and then to 2. So you started and ended on the same vertex, but you visited this edge twice. So this is not a Eulerian circuit. Okay, so we need to take care of that. So one possibility is this. Can we think of some other possibility? Yes, this is kind of an edge case. What? In order to find a Eulerian circuit, see, one more possibility is, let's say you have 6 number of nodes from 0 to 5, then 0, 2, let's say 4, 1. Okay, and let's say this is 3, and let's say this is 5. This is also a Eulerian circuit. Why? Because from 0 I can go to 2, from 2 I can go to 4, from 4 I can go to 1, and from 1 I can go to 0. Right? So I will start and end on the same vertex, and every edge will be visited exactly once, every edge present in the graph. So this is also contains a Eulerian circuit. So here also I will return 2, here also I will return 2. So these are the two cases for this. How will we do Eulerian path? So basically it will not form a cycle, but there will not be any branch. It would be a straight path. Okay, so for example, if I have, let's say, 0, 1, 2, 3, 4. So this is a Eulerian path. Now as soon as I put a branch, okay, a multiple branch, so what will happen? See, let's say I start from 0. From 0 I go to 1, from 1 I go to 2, from 2 I go to 3, from 3 I go to 4. Now in order to visit this edge, I need to come back, and when I come back, I will visit this edge twice. So it will not be a Eulerian path. In Eulerian path, every edge will be visited exactly once, and we start and end on different vertices. Okay, so if it is of this form, then it is a Eulerian path. Okay, there is this case. Okay, we will return 1. And what can be other case like this, right? So what can be other case of Eulerian path? Let's say 0 to 4. Okay, let's say v is equals to 5. There are 5 vertices from 0 to 4. So it is like this, 1 and 3. So these two are individual. You can start from 0, and at 4 you will visit every edge exactly once, and you will start and end on different vertices. So in this case also we will return 1. Okay, and in all the other cases we will return 0. So in these two cases we have Eulerian circuit, will return 2. In these two cases we have Eulerian path, will return 1, and in all the other cases we will return 0. Now how will we implement it? See, what is the degree of all the vertices here? Degree is 2. It means how many edges are connected to that vertex. So this also has degree 2, 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 and all the vertices have degree 2. Here if I look, this has degree 2, this has degree 2, this has degree 2, and this has degree 2. This has degree 0, and this has degree 0. Okay, so if I can say a number of vertices with a 2 degree plus number of vertices with 0 degree is equals to V, then in that case I have a Eulerian circuit. Okay, what will be this? Here all the vertices in between will have degree 2, and the end vertices will have degree 1. Okay, so all the vertices in between will have degree 2. Similarly, here the vertex in between will have degree 2, end vertex will have degree 1, and these vertices will have degree 0. So if number of vertices with degree 1 is 2, and number of vertices with degree 2 plus degree 0, number of vertices with degree 1 is 2, that is the end vertices on the Eulerian path, and number of vertices with degree 2 plus number of vertices with degree 0 is equal to V minus 2, because 2 are covered here. Okay, then in this case we have Eulerian path, and in all the other cases we will return 0. Now let's look at its actual implementation. So let's look at the actual implementation. So I have taken one degree array in which I will basically store the degree of each vertex by seeing the adjacency list. Then I have taken one variable 2 which will store the number of vertices in the graph with degree 2. I have taken one variable 1 which will store the number of vertices in the graph with degree 1, and I have taken one variable 0 which will store the number of vertices in the graph with degree 0. I have initialized all the degrees as 0. Then I have traversed for all the vertices. I have traversed the adjacency list, and whatever be the x in the adjacency list, I have counted its degree x plus plus. Okay, so basically let's say in the adjacency list of I there is some value j. Okay, then I will say degree of j plus plus, right? So degree of j will increase. Now this is a edge between I and j, right? So degree of I should also increase. When it will increase? When we will traverse the adjacency list of j. In that somewhere it will be I, and during that time degree of I will increase. Okay, so basically we will traverse the adjacency list and make degree of x plus plus. X are all the elements present in different adjacency list. Then I will traverse all the vertices after counting the degree. If the degree of a particular vertex is 2, then I will say 2 plus plus. If it is 1, I'll say 1 plus plus. If it is 0, I'll say 0 plus plus. Finally, if number of vertices with degree 2 plus number of vertices with degree 0 is equals to V, it is a Eulerian circuit. If number of vertices with degree 1 is 2 and number of vertices with degree 2 plus degree 0 is V minus 2, it is a Eulerian path, and in all the other cases we will return 0. What will be the time complexity? If I look here, we have one for loop of this will basically traverse all the edges, so big O of E plus this is the size of the number of vertices, so big O of V plus E. And what will be the auxiliary space? You see here I have taken this array of size V, so it will be big O of V. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully.
Hello everyone, I am Karan Masru. Welcome to this video.
In this video, we are going to look at the solution of the problem, that is shortest path from 1 to n. First of all, let us start by understanding the question. What does question say? Consider a directed graph whose vertices are numbered from 1 to n. Okay, so we have a graph which is directed, means the edges have a direction, and the number of vertices are n, and the number of vertex numbers are from 1 to n. So 1, 2, 3, 4 up to n. There is a edge from a vertex I to vertex j if and only if j equals to I plus 1. So let's say there is a vertex I with value 3, and if j is 4, then there will be a vertex from 3 to 4. Okay, or j is equals to 3 times I. So let's say I is 3 and j is 9, then there will be a directed edge from 3 to 9. The task is to find minimum number of edges in a path from vertex 1 to n. So basically, see, we are given a graph in which there are n vertices, and the edges will be between from vertex I to vertex j if j equals to I plus 1, or if j equals to 3 times I. And our task is to find the minimum number of edges in the path from 1 to n. Okay, so what are the minimum number of edges which we need to travel if we need to reach vertex n starting from vertex 1? So if n is equals to 9, then you need to travel 2 edges. So from 1 you can go to 3 because 3 is 3 times 1, and from 3 you can go to 9 because 9 is 3 times 3. So there will be a edge from 3 to 9 also. Okay, so in 2 steps you can reach 9. Okay, similarly, if n is equals to 4, then you need 2 steps. Okay, so from 1 to 3 and then 3 to 4. Okay, you don't need to read input or print anything. Your task is to complete the function minimum step, which takes an integer n as input and returns the minimum number of edges in the path from vertex 1 to n. The expected time complexity is log n, and expected auxiliary space is constant, and the constraints are given here. So if we now try to solve this problem, then let us look at this graph where the value of n is 10. Okay, so there are 10 vertices numbered from 1 to n. Now this is a directed graph, so all the edges will have a direction. Okay, so let's say this is vertex I and this is vertex j, then there is a direction of the edge. Okay, now there is a directed edge from vertex I to vertex j, means you can travel from vertex I to vertex j. Okay, now there are directed edges in the graph only if j equals to I plus 1, means the value of j is 1 more than I, or j's value is 3 times I. Okay, so out of these two things, if there is one thing, then there will be a directed edge from I to j. So if I now try to make the edges, then from 1 to 2 there will be a directed edge because 2 is 1 more than 1. Similarly, there will be a directed edge from 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9 and 9 to 10. Why? Because these all holds what? J equals to I plus 1. Like if I take j equals to 5 and I equals to 4, then j equals to I plus 1. So we got these many edges. Now how many edges will be there satisfying this condition? Let's say I is 1, then j will be equal to what? 3 times 1, that is 3. So there will be a directed edge from here to here. I is 2, j will be 6. So there will be a directed edge from here to here. I is 3, j will be equal to 9. There will be a directed edge from here to here. Now if I is 4, j will be 12. So we do not have those many vertices. So this is the graph. Now I want to find the minimum number of edges or the shortest path from vertex 1 to vertex n. Okay, so how will I get minimum path? By taking as large steps as possible. Okay, so if let's say I take multiple of 3 at if I come from 1 to 2. Okay, let's say I go from 1 to 2. Then from 2, let's say I made this step and I went to 6. Okay, then from 6 I will go to 7, then from 7 I will go to 8, then 9 and then 10. So how many edges are there? 1, 2, 3, 4, 5, 6. Okay, so there are 6 edges in this path from 1 to n. But if I take as big step as possible, see, basically I want to go from smallest vertex number to largest vertex number. Okay, so as big step as I will take, the number of edges will reduce. Okay, so what is the biggest step? 3 to 9. Okay, so I somehow want to reach from 3 to 9. Okay, so let's say I go from 1 to 2, 2 to 3, and from 3 I'll go to 9. Okay, and then from 9 I'll go to 10. So this will take 1, 2, 3 and 4 number of edges. Okay, so this will take 4 number of edges. Now there is even better way. What? From 1 I can directly go to 3, right? So from 1 to 3, 3 to 9 and 9 to 10. So this is 1, 2, 3, 3 number of edges. So my answer is 3 for 10. Now how will I find it? See, one way is to create this graph and apply some shortest path algorithm. Okay, that is one way. What is easier way? Think of this in reverse direction. Okay, so here basically what's happening is, see, from 1 I can go to 2, from 2 I can go to 6, from 6 I can go to 7, from 7 I went to 8, from 8 I went to 9, from 9 I went to 10. Okay, similarly, if you look at the graph, if I am at a vertex I can go to vertex I plus 1, or I can go to vertex 3i. Okay, so let's think of it in this way, that you are starting with value 1 and you want to make this value equals to n, and at every step you can either increment this value by plus 1 or you can multiply this value by 3. Okay, what are the minimum steps to make this value 1 equal to n? You can also tell this. Now think of this in reverse direction. What will be the minimum steps to reach from n to 1 by either subtracting 1 or dividing by 3 at every step? Now why am I doing so? Because see, here I multiplied 2 by 3 and I went to 6. Okay, but what was the better approach? Better approach was to multiply 3 and reach 9. So as big step as I can take. Okay, so what I can do is I can think of it in reverse direction. I'll start with n and I want to find the minimum steps to reach 1. Okay, and at every step I'll either divide the number by 3 if it is divisible by 3. So the largest number which is first encountered will take the biggest step, and so the number of steps or the number of edges will be minimum. Or if the number is not divisible by 3, do minus 1. Okay, so let's take an example. Let's say n is 10. So I'll start with 10 and I want to make this value 1. Okay, so 10 is divisible by 3? No. So subtract 1. So this will become 9. This is divisible by 3, divided by 3. This will become 3. This is also divisible by 3, divided by 3. This will become 1. And we have reached 1. So how many steps I took? This is 1, 2 and 3 steps, right? This is the first step, this is the second step, and this is the third step. So my answer is 3. Okay, take another example, 14. So is it divisible by 3? No. So subtract 1. Is it divisible by 3? No. So subtract 1. Is it divisible by 3? Yes. So divided by 3. Now is it divisible by 3? No. So subtract 1. Is it divisible by 3? Yes. So divided by 3. So how many steps are there? 1, 2, 3, 4 and 5. So my answer is 5. So this is what we are going to do. Now let's look at its actual code. So if we look at the actual code, so what I have done, I have taken one variable answer which is initialized with 0, and while n is greater than 1, so while n is not equal to 1, if n is divisible by 3, divided by 3 and make answer plus plus, else subtract it by 1 and make answer plus plus, and finally return answer. What would be the time complexity for this? It would be big O of log n base 3 because we are dividing it by 3. And what would be the auxiliary space for this? It will be constant because I am taking only this one new variable. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.